Alright, so welcome to the second lecture of this course, and in this lecture we're just going to learn how to download Python. So the reason we need to download Python is because we have to get that IDLE in which we write the Python code. It's absolutely necessary to download Python before we start writing any of the Python syntax. So first thing first, what I want you to do is head over to python.org. And what python.org is, So what python.org is, it's basically the official site of the Python programming language. Over here you can have documentation, you can download stuff, and it's a really nice place. So I definitely suggest later on, whenever you're free, check out the site. You can check out the documentation, the community, some success stories, stuff like that. But what we're going to be doing is, if you scroll down a bit, or you can just go ahead to the download section, and you're going to download for Mac OS X 3.4.3. Now, if you're on a Windows, it should probably say download for Windows 10 or Windows 8, whatever your version is. And you want to select Python 3.3 over here. In case you're not seeing something, what you can always do is scroll down a little further, and you'll see this download icon over here. Go ahead and select Python 3.4.3. So it says all this good stuff. It was released on February 25th, 2015. Major new features, stuff like that. We don't really have to use any of that. Basically, take a look at this stuff, the files. So if you're on a Windows, definitely use the one that was for an OS Windows. So probably the Windows x86 64 MSI installer, or you might do the one underneath that, the Windows x86 MSI installer. So if you're on a Windows machine, definitely click one of those. If you're on a Mac OS X, obviously do the one which has the Mac OS X. So I do have the latest version of Mac OS X, which is higher than 10.6, so I'm going to select this one. Okay, and again, it just depends on your machine, what you have. And now you're going to see a package being installed over here. So it has a 3.4.3 package. And I'm not going to go through, or I'll just open this for you, but I won't be going through the steps of installing Python 3.4.3 again, since I already have. But the concept is quite simple. Same thing for a Windows machine. The package will download. All you need to do is go through the steps, go through each one of these steps, and once it's downloaded, you should be able to see it. So for Mac users, I'll quickly show you how to get to it. Let me just get this file over here. Okay, give it a few seconds. So going into applications, over here, you're going to see Python 3.4 appear. Okay, so right now my machine is taking a little bit of a longer time than usual. However, if you're on a Windows machine, you're going to go into your C drive or D drive or whatever your main hard drive disk is. And over there, you're going to see a folder called Python 27 or Python 34. So if you select that, that's where all your IDLE and Python launcher and stuff will be. So as you can see, now my Python 3.4 package has been installed. I have my IDLE, my Python documentation, my Python launcher, and so on. So for the coding part of Python, we'll be doing our maximum coding inside of this IDLE. Okay, so it's over here where we write the code. I'll quickly show you how the IDLE looks like. It's bouncing around right now. It's going to take me a little bit of time. But basically, throughout this course, we'll be using this IDLE to write all of our Python code. Okay, so this is how the IDLE looks like. As you can see right now, I'm using Python 3.4.3. If you hit enter, this is where you write code. So I won't be showing you the code in this lecture. This lecture is all about downloading Python and installing it on our machine. Now, in the next lecture, we'll go ahead and create a very simple Hello World program. See you then. Alright, so in the previous lecture, we learned how to install Python on our machine, okay? And right now, in front of your screen, you should have your shell open. So I'm not going to take too much time here. Basically, I'm going to create a Hello World program. So in almost every single programming language, the first step a beginner takes is creating a Hello World. I'm not sure why that is, but it's always there. So let's go ahead and do that. Basically, we're just going to print out Hello World. So it's not too complicated. What I want you to do is type print, okay, so P-R-I-N-T, and then in brackets, put in quotation marks. So print, bracket, and then quotation marks, hello world. Hello world, okay? So basically what we're doing is we're calling the print function, and we're printing out hello world. There we go. So as you can see right from the start, the syntax of Python is very easy. It's pretty straightforward. I mean, as we go on to more beginner and advanced concepts, you'll realize, hey, Python is actually really easy. So this was a simple hello world program, and this was the end of section 1. So we just learned how to download Python. There was a welcome lecture before that, and in this lecture we learned how to create a very simple hello world program. There was nothing to teach you actually, I just wanted to get that done with. And in the next section we'll move on to the basics of Python. So variables, strings, lists, dictionary, stuff like that. So that's it for my side, and see you in the next section. Hi guys, Avi here. Now, if you've already had some experience with Python, you know how things work, go ahead and skip this section. Basically, this is your first time programming, or if this is your first time dealing with Python, then this section is for you. In this section, we plan to cover all the basics of Python, from variable types and loops to functions and classes. Now, let's get started. So, in this lecture, we're going to be talking about variables. First thing first, what is a variable? Now, if you've dealt with any programming language before, you know what variable is. A variable is a reserved memory space. Okay? Now, this memory space can hold any value, and it is assigned to a term. So, for example, I can create a variable called maybe my age, so age, and I can set that equal to anything I want. I can set it to maybe a text, so I can set it to some text. I can set it to my actual age, which is a number. I can say age is equal to 14. So here what we've done is we've created a variable whose name is age and whose value is 14. Now, wherever in the Python program I call on age, I'm going to get the value as 14. Okay? Now, the neat thing about variables is you can always change the value. Remember, variables are not permanent. Variables are changeable. So I can now say, hey, my birthday was yesterday, I am now 15 years old. So age is now equal to 15, and if I print out age, I get the value as 15. So this is key. Now, while assigning variables to Python, the concept is very, very simple. First part is the variable name. It can be Bob, it can be John, you can have a capital letter, you can have all caps. Doesn't really matter. You just need an identifier. Now, if I try doing maybe like print is equal to something, I can't do that because print is a function in Python. So these are, the case does matter when you're assigning variables, but however, stick to some normal names. Maybe if you're trying to get a print variable, then my print or something like that. Now with variables, it's very simple. It's a 3-step procedure. You write your identifier, or a variable name, a var name. You use an equal sign to say that, hey, I'm assigning the value to the variable var name, and then what you do is you give it its value. For example, I'm creating var name as an integer with 12. So something like that. Alright, fantastic. So in this lecture, we just gave a very, very brief introduction to variables, how to assign variables, and what variables are. Now in the next lecture, we'll talk about multiple declaration of variables. See you in the next lecture. Alright, so in the previous lecture, we talked about variables and how to assign them to values. Now the question comes, let's say you're dealing with a big Python project and you have to create variables of every single person in your class. Let's say you have 10 people and each one has, different names. So it's a very tedious project. What you do is maybe something like person 1, set that equal to maybe Abby, person 2, set that equal to James, and on and on. So this would continue on till person 10, and by that time you would have collapsed and you'd be groaning, oh my god, I hate Python. Well, that's not the case. Here we talk about multiple declaration. And all it does is you can assign multiple values to multiple variables in one line. Now, the way it works, well, you can do something along the lines of this. Person 1, person 2, person 3. And I want to set person 1, person 2, and person 3's value as Abby, James and LeBron. Okay, so once I do this, if I now say person 1, I get Abby, person 2, I get James, and person 3, I get LeBron. You see how it made our work a lot more easier? We didn't have any problem of declaring variables. So this is a very nice feature of Python, multiple declaration. Now let's say we had another case. You had one string. Let's call that string as apples. And you had 10 variables. And what you wanted to do was you wanted to assign apples the value to all the 10 variables. So something along the lines of this. var1 is equal to apples. var2 is equal to apples. Whoops. Okay. var3 is equal to apples, right? And so on. So right now, as you can see, it's giving me an error. var3 is equal to apples, invalid syntax. If you haven't guessed already, let's just go through this error as a learning process. You cannot give spaces while implementing or creating your variables. Your variables must be one word. You can do maybe something like my name is, so joining all the words together, but in the end, your variable name must be one word. Anyways, going back to our main point, we wanted to set each variable, var1, var2, and var3 as apples without having to do it repetitively. How would we do that? Well, there's also the concept of multiple assignment, where I can say var1 is equal to var2, whoops, is equal to var2, is equal to var3, which is equal to apples. Isn't that neat? So now, if I call on var2 or var3 or even var1, all three of these variables have the value of apples. Fantastic. So let's quickly recap what we learned in this lecture. We learned about multiple declaration, where you can assign 3 variables, 3 different values in just one line. And then you also learned about how you can do multiple assignment. 3 variables can also have the exact same value. Fantastic. So in the next lecture, we'll talk about data types. If you don't know what data types are, let me give you a quick hint. What we have been using so far have all been data types. See you in the next lecture. Alright, so let's go ahead and get started with data types. Right now, I think the shell is looking a bit crowded. So what I'm going to do is, I believe there is an option for me to restart shell, but that won't do anything actually right now. So I'm just going to close my IDLE, or yes, and I'm going to reopen this again just to make it a bit more easier for you guys so that you're not too confused about what's going on the screen. So my IDLE is taking a bit of time to load. There we go. And let me get into the screen size. All right. So we're now talking about data types. So what is a data type? Well, the data stored in a variable, right? Our age variable, our name variable, can be of many types. So far we've dealt with numbers, right? And we've dealt with text, which we call as strings. The remaining 3 main data types, or the standard data types, are lists, tuples, and dictionaries. Now we'll get to these 3 later on in the following few lectures. Right now we're just talking about numbers. This whole lecture, let's just talk about numbers. How does this work? So we've already dealt with the basics of numbers. So age is equal to 10, var him is equal to 15 or 35. So you know the basics of how to add these numbers, right? And that's basically the core concept. Now what we want is we want to learn, hey, how do I add variables? How do I subtract variables? So the way we do that is with something called operators. Now, you must have learned probably in pre-K actually what operators are. Addition, subtraction, multiplication, and division. The 4 simple operators. So what I'm going to do is I'm going to create 2 variables, age 1, set that as my age, and age 2, set that as maybe I believe my dad's age, which is 40. And let's say I gave you the puzzle, create a 3rd variable, age 3, which has the sum of age 1 and age 2. How would you do that? Well, to the layman, it's sort of obvious, but with Python, it's quite simple. The the way we're going to do this is age 3 is going to be equal to age 1 plus age 2. So this is where we use operators. Now, if you print out age 3's value, we get 54. It's that simple. Now, we've used addition. Let's use subtraction, multiplication, and division. Age 1 minus age 2, what do we get? Minus 26. Age 1 divided by age 2, we get 0.35. And age 1 into age 2, again, note, the into sign is an asterisk sign that you get by shift 8. We get 560. Now, the last operator I want to talk about here, at least for arithmetic operators, I can't speak today, is modulus. So the modulus operator, all it does is it gives you the remainder of a division, okay? Right now, we divided age 1 by age 2 and got 0.35. What do you think the remainder is when we divide age 1 by age 2? Well, if you're good at mathematics, age 1 mod age 2, which is percent sign, you're going to get 14. Why? Because 40 or 14 is not divisible by 40 in the sense that not even by 1. So you get 0, remainder 14. Okay? So these are the main 5 operators that you're going to use in Python. Now, in the next lecture, we're going to be talking about strings. So adding strings, how strings work, and stuff like that. See you in the next lecture. Hi guys. Now, before I start, I just want to point out Python is a fantastic language to learn. Now, if you're learning this as your first programming language, that's amazing because Python is probably, for my sake at least, one of the easiest programming languages to learn. Now, let's get on to strings. So, strings in Python, as we've already seen, are characters denoted in quotation marks, right? So I could say a variable my name and set it in a value of quotation marks, some characters, right? Let's do my actual name for Python's sake. And we've talked about adding, so operators, addition, stuff like that. So my quiz or my question here right now is I'm going to create a variable, first name, set that equal to Avi. I'm going to create a second variable, second name, set that equal to Jane. I should have actually created the last name, but that's fine. And now what I want you to do is create a variable called full name, which has the sum of full first name and second name. Now, if you're already a step ahead of me, concept's quite simple. First name plus second name, and if you now print out full name, you get Avi Jane. So you see this error of a space, right? And probably the easiest way we can get rid of that is by adding a quotation marks in the middle with a space. So first name plus quotation marks with a space plus second name. So now if we print out full name, we will now get Avi Jane. Awesome. Now the question I give to you is, suppose I give you this text, Avinash, and then gibberish, okay? And the goal, or sorry, I was actually supposed to assign that to a variable. So random should be equal to, and then let me just copy this, Command C. All right, random is equal to Avinash, gibberish, blah, blah, blah. And the goal I'm trying to give you here is, hey, I want you to return me Avinash. That's it. I don't want any of the gibberish stuff. I don't want the space I have over here. All I want is this clear and simple Avinash. How do I do that? Well, thanks to Python, we now have the slice operator. Now, the core concept of slice is you can get or you can slice any part of the string from wherever to wherever. The way it works, you type in random and then you type the 2 square brackets. And in the square brackets, let's go give it a try. So I'm going to go through several example cases so that you get the idea of what's happening, and then we'll actually slice out Avinash. Now, first example case. Let's say you just wanted the first letter or a single letter. Hey, what's the 10th letter in this statement? You're going to say random 10. What does it give out? B. If you actually wanted to count, Avinash is 7, 8, 9, 10. So you're probably wondering, hey, Avinash is 7 plus the space 9, 10. Why has it given me B instead of what I think is I? And the reason it's done this is is because the indexing of almost everything in Python starts at zeros. When we get to arrays or actually lists and dictionaries, indexing starts at 0. So think about it like this. The first character in the string, its position is the 0th position, then 1, then 2, then 3. For example, now if I wanted to get the actual 10th position, I do 10 minus 1, right? If you wanted to get the xth position in the string, you do x minus 1. It's that simple. So if I wanted to get the actual 10th position, I do random 9 and I'd get I. Cool. So the next case is I want to get a slice. Let's say from the first character to the 4th character. How do I do that? Well, we've talked about this. So what's the first character in the list? Well, the index position is 0. So we do random, and then using the slice function, we do 0. Now we say colon, hey, we got the first position, where do we want to go up till? Well, we're going to say, let's say I want to go to maybe the, let's say Avi. So I believe that's the 3rd. So 0 to 3, 0, 1, 2, 3, but it won't count the 3. Exactly. So the slice function here, what it's saying is, give me the first position, right? So where do you want me to slice from? And then give me 1 after your end position. For example, I wanted Avi. A is 0, V is 1, I is 2. Instead, I gave 0 to 3 so that it returns me 0, 1, 2. The last one, 3, isn't counted. Now with this knowledge, go ahead, do a quick challenge here. Give me Avinash, or whatever statement you've given me or written, give me your name. So I'm going to pause the video. You should hopefully do this. It's actually just one simple statement. Let's take a look. Alright, hopefully you managed that. If you didn't, that's absolutely fine. We're going to do random 0, okay? And like I've talked about, my name is how many characters? It's 7, right? So let's go ahead and put in 7. Now, if you realize, I've already thought one step ahead. So 0, 1, 2, 3, 4, 5, 6, and then one more, which is 7. So 0 to 7, and I get Avinash. Fantastic. Now, before I end this lecture, there's one more thing I want to cover. Let's say I wanted everything from the 3rd character. So I wanted Nosh gibberish. What would I do then? Well, it's actually quite simple. I'm going to use the slice function and say random from the 3rd character, which is 2, to everything after that. Random 2 colon. And once I do that, I get Inosh, gibberish, blah, blah, blah. So these are a few simple functions that you can use with the splice. So whenever you have a string and you're trying to get a specific string out of that string, you can use the splice function. Fantastic! So we learned a lot in this lecture. First thing first, we learned about strings, how to add strings, adding that extra gap. After that, we learned how to get a specific string out of the main string. So searching and splicing. That's the core concept. Nice. Now, in the next lecture, what I want to talk about is the next data type. So we've discussed about integers. We've talked about strings. Let's go ahead and move on to lists. Okay? See you in the next lecture. Alright, so in the last lecture we talked about strings. We discussed how we can split strings, slice strings, how strings work, and so on. And again, there are several functions that we can use with strings, and we'll get to them later in the course. But basically, I just wanted to give you a quick introduction on how strings work. Now we get on to lists. So, for example, let's say I had to go to maybe Fred Meyer or Target or any shopping store that's maybe near you. And I was creating a list. So let's create a shopping list of the things I need to buy. And I'm going to be using a string here. So I have a shopping list. Maybe I need eggs. I might need some carrots. Oh, I need milk, cherries, and let's add one more, apples. Okay. So let's say I had to go to a shopping store and I had all these different items that I had to buy. So right now what the problem is that if I need to know what's the first item in my list, what do I have remaining, stuff like that, I can't do that with a string. Right now, if I just want to find out what's my first item, I'll have to do shopping list and then use some splicing stuff, but that also depends on if I know the number of characters. Right now, if I just print shopping list, I'm just going to get egg, carrots, milk, cherries, and apples. There's no specific way to find out what's my first item, what's my third item, what's the last item I have to get. And this is where the Python term lists and the more general term arrays comes in. So again, let's create a new list, shopping list 2.0 or 2, and let's create an array over here. And the way to create an array is we're going to be using 2 square brackets, and in the square brackets you're now going to add your items. So our first item was eggs, comma, our second item was carrots, comma, third item was milk, cherries, apples. So these lists, right, they're the most versatile data type available in Python. All the items, the items in a list can be of any data type, strings, numbers, etc., etc., but they can be. So this is our shopping list in which we've used an array. Now, for example, if I print out shopping list 2, what do I get? I get eggs, carrots, milk, cherries, apples in square brackets. And now you're wondering, hey, what's the difference between shopping list 2 and shopping list 1? The only difference I can see is that we're adding these square brackets. Well, guys, the whole point of arrays is that we can now use indexing to get our values. Whenever you create an array, and again, in arrays, you can add any value whatsoever. You could have added integers, floats, you could have added decimal values, stuff like that into the array. Right now, since it's a shopping list, I've used strings. But the whole point of arrays is they've given each value an index number. So I'm at the grocery store, and I've checked marked eggs, but I'm not sure what is my next item in my list. So what we can do now is if we do shopping list 2, and then in square brackets right next to it, 2, we get milk. So you're probably wondering, well, why didn't we get carrots? It's a second value. Well, think about it like this. Just like we talked about characters in the last lecture, with lists, it's the exact same thing. The indexing in a list, in a string, in almost all data types in Python, it starts at 0. So the eggs index is 0. If I want to know what is my first item in my list, I'm going to use shopping list 2, and then in square brackets, the first item, which is 0. If I want to find out, hey, what's my fourth item in my list? I'm going to say shopping list 2, and then n minus 1. If I want to know the fourth, it's 4 minus 1, 3. So shopping list 3, it's cherries. So this is where lists become more and more useful. And this isn't the end. There's tons of functions you can add with lists. Right now, all we've done is we've accessed values. Let's say I was at the shopping store or at the grocery store, and I'm like, wait, I don't need milk anymore. I realized I have 2 cartons at home. Instead, I need chocolate. How do I update the value in list? Right now, if we were using a string, there was no way we could do that. We'd have to rewrite the string over and over again. Waste of time. However, with lists, it's quite simple. First, find the position. What's our position? It's going to be 2. So all we're going to say here is shopping list 2 should now be equal to chocolate. Do you see what we did there? All we're saying, string object does not support item assignment. The error I was getting here is, sorry about that. It's shopping list 2, since the variable name was shopping list 2. So here, in case I want to change milk to chocolate, now typing in chocolate again. And if I print out shopping list 2, we get eggs, carrots, chocolate, cherries, apples. Isn't that cool? So you can update values in lists. You can change, you can delete, you can add. These lists are the most versatile object you'll find in Python. And as we get along in the course, as we add or dive deeper into Python, lists will be one of the main objects we use every day. So play around with this, and in the next lecture, I'll be showing you some cool functions that we can use with lists. See you then. Alright, so let's get started. We're on lists now, and so far we've learned that lists are very versatile. You can add objects, you can change the object in lists, but what else is there to it? So let's go over a few main functions that are inbuilt with Python. So the first one let's talk about is deleting an item. I'm at the grocery store and I realized we have tons of apples at home. I don't need to buy anything else. How do I delete apples from my list? So the quickest way to do that would be using the del function, D-E-L, okay? As you can see, as soon as we wrote it, it's become highlighted in a yellowish color, which is great. So it's del, and then we have to specify which list. So shopping list 2, and then the position of the item. So the position of the item is the 5th, so n-1 is 4, and it now says unexpected indent. So I will discuss this in a future lecture, but indenting in Python is quite key. Okay, I'm going to tell that right now, but I'll explain it more in detail probably in the following lectures. So del shopping list 2, 4th position. Now if I print out shopping list 2, what do we get? Eggs, carrots, chocolate, cherries. So apples has been deleted. Right now, take a mental note of all the functions that we're using. So let's go ahead and quickly make a note of the functions that we're learning in our arrays. First one was the del function, okay? The del function, all it does is it deletes an item from the list. So this is key. Whenever you have an extra item or if you have an unnecessary item, you can instantaneously delete it. Next, so we haven't discussed what happens when we want to add arrays. What happens when we want to subtract from arrays or compare arrays. So there's functions for all of that. Right now, I'm going to create two simple arrays. Array 1, that's going to have the value, let's say 23, 54, and 64, I guess. And array 2, which will have the values of 43 and 23. So if you're probably wondering here, how do I add array 1 and array 2? It's the exact same way we did with strings. So we can say array 3 should be equal to array 1 plus array 2. And by doing so, array 2, and if we now print out array 3, we'll get all 5 values. So adding arrays is as the exact same thing as adding strings. There's nothing to worry about there. Next function. So we've discussed delete. We've discussed adding arrays together. The next function we're going to discuss is len. So many times when you have arrays, you're adding object after object, object after object, and in the end you want to know, hey, how many objects have I added? What's the total number of objects in my list? That's where the function len comes in. So type with me here, len, and as you can see, it's again been highlighted, except this time purple. Len shopping list 2. So len shopping list 2 returns us 4. The whole concept of len is it returns us the length of the array. If I have 5 objects, it returns 5. If I have 15 objects, it returns 15. And once we get into loops, right? Once we understand how loops work, which will be, I'm pretty sure, in the next 3 or 4 lectures, then I'll show you how we can use len to iterate through our array. There's many different ways you can do that, but we'll get to there. Now, before I end this lecture, let's discuss 2 more functions, max and min. For example, I'm going to call this array num array, and I'm going to set it as the values of 36, 75, 100, or 1000, or 10,000 for 1, and -5. So I've created a num array. It has 5 random values. Now, if you're wondering, how do I get the biggest value out of this array? And how do I get the smallest value? That's where the max and min function come in. So just like we used len, we typed len and then in brackets, the exact same way we can use the max and min functions. So max num array, sorry I can't speak today, and min num array. So by doing so, you can now get the maximum and minimum values of an array. Let's go ahead and add them to our notes. So we have del, we have len, we have max, and we have min. So again, there are tons, and again, tons of functions that you can use with arrays in Python. Alright, so before I end this lecture, let me just show you two more functions. And you're probably wondering, let's move on from lists. I'm getting bored with lists. Don't worry, this shouldn't take too long. So we discussed del, len, max, and min. Now, for example, if you want to add another object to your list, we've created this fantastic shopping list, and then you're like, oh shoot, I forgot to add broccoli. I mean, I hate broccoli, but still. So the way we can do that is shopping list 2.append. The whole meaning of append is add an object. So shopping list 2.append, I want to append broccoli, okay? And if you now print out shopping list 2, we're gonna get eggs, carrots, chocolate, cherries, broccoli. It's that simple. So the append function will now add objects to your list. And last but not least, we have the count function. Let's say you have an array in which multiple values are repeating. 2, 2, 2, 3, 4, 4, 5, 6, 6, 6. And in that scenario, you want to know how many times is 2 repeating? How many times is 6 repeating? Stuff like that. That's where the count function comes in. So something you can do is shopping list 2 or 2.count, and let's say how many times is chocolate repeating in my shopping list. It's going to return 1 because I've added chocolate only once. Alright, fantastic guys. So we've discussed, I believe, 6 main functions dealing with arrays. Let me go ahead and add append and count. So these 6 functions will get you a long way through with lists. There are several more that we're going to discuss as we go along with this course, but hopefully you got a basic understanding of how lists work. Again, lists are the exact same thing as arrays. If you've ever dealt with another programming language before, you must have heard about arrays, right? Arrays and lists are the exact same thing. Don't worry, they're not confusing at all. Now in the next lecture, we'll talk about dictionaries. So dictionaries is again another very cool data type which stores values, except it's just like a key. So it has a key and a value, a key and a value. So it's pretty cool, and we'll see to that in the next lecture. Alright, so in this lecture we're going to be talking about dictionaries. And before we even get to how to create dictionaries and all that stuff, let's actually talk about where are dictionaries used and how they work. So I'm sure all of you must have seen a map, right? Any sort of map, maybe a map of America, map of Asia, map of the whole world. However, in every map, you'll always see a legend, right? Now this legend comes in the format of a key and a value. So the way it works is, suppose there's a lot of green on the map. Green means land, right? Maybe there's some blue. Blue means water. Maybe some yellowish red, that means desert. Some white, which means mountains. Stuff like that. So it's color coded. You have a key. It can be any color, any sort of value or object, and each key has a value. So the exact same way a dictionary works, and it's actually pretty cool. So let's think about it like this. Suppose I have a class of 10 students, alright? So we have a class of 10 students, and I have each student's name. So I'm going to create students, and I'm going to set that as each student's name. So I have Eric, and I have his age, he's 14. I have Bob, and his age is maybe 12. I have Tina, and her age might be 26. I mean, it's random values. And let's do one more for now. Let's do Chris. Chris. And his age is 15. So right now, just follow along, okay? Don't type this out with me. I'm just showing you an example of where dictionaries are useful and where arrays are not. So suppose we have these 4 students in our class, Eric, Bob, Tina, and Chris. And we know each of their positions, and that's all great. However, I want to find out what each student's name is. I have a list of students. Eric, Bob, Tina, Chris, Jake, blah, 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 blah. And what I want to do is, for each of these students, I want to know their age. And they're in this array. So the way I would do this is, for each position of the student, let's say I'm talking about Eric, his is the first position, I know his age is the second position, right? If I'm talking about Bob over here, I know Bob is whatever his position plus 1. So 1, 2, 3 plus 1 is 4. 12 is his age is at the 4th position. And that's the way you would do it for these 4 people. You would find out where their name is, and then you'd find out what's the position ahead of it. Suppose you have 100 students though. Let's say 1,000. What do you do then? Do you search for each student and then try to find, hey, what's ahead of it? No, that's not at all how you're supposed to do it. Well, that's where dictionaries come in. So let's go ahead and create a new students variable. And instead of using square brackets, use curly brackets. So dictionaries are actually similar to arrays in the sense of how they're written, but the only difference is a colon. For example, we're writing Eric and 14. So the way we're going to write this is Eric colon 14. All right. So this is the key. This is the value. All right. Let's do 2 more here. Let's say I want to add Bob, and what's his age? 12. So you write the key colon the value, and then we're talking about Tina. So Tina, and it's 26. All right. So this is our student's dictionary, and you know why this is neat? Well, we can now access any of these values by putting in the key. I'm like, all right, so I need to find out what Bob's age is. How do I do that? Well, it's quite simple. You put in students, and then in square brackets, you type in Bob. And as soon as you do that, it returns you 12. So just like a maps legend works, the exact same way a dictionary works. You put in keys, you get the values, okay? So the concept of this is very, very simple, and it's quite useful. Now let's think that Bob left the school, all right? Bob was a very bad child. He never studied, never did his homework, stuff like that, and he just left the school. What happens then? How do we update this dictionary? Well, guys, it's actually quite simple. All we do now is we update the dictionary. Either, in this case, let's say if Bob left the school, we'd have to delete the entry. Otherwise, maybe for a different example, let's say Bob had his birthday yesterday and he's now turned 13. So how do we update Bob's value? Well, the way we can do that is saying student, and then Bob is now, or actually capital B, is now equal to 13. So we have now updated Bob's value in our dictionary. So going back to the statement and printing it out again, we now have 13. And since we're already on the topic, let's finish off deleting a student as well. So Bob had his birthday yesterday, he had a fantastic party, and sadly, today is his last day of school. So we now have to get him out of the students list. How do we do that? Well, it's quite simple. If you remember back in a lecture or 2 ago, we were talking about the delete statement. We worked with it in arrays. Well, it's pretty much the same concept over here. What we do is we say del, and then we delete the dictionary name. In this case, it's students. And what part of students do we want to remove? We want to remove the Bob part. So the key and value of the key Bob and its value will now be deleted from the student's dictionary. So now if you print out students, Eric 14, Tina 26. So you're probably wondering, well, is this case sensitive? So go ahead and try it out. What I want you to do is just type in students and then type in Eric lowercase. Does it work? No, it doesn't. So over here, this is a fantastic error. Let's quickly go over it. All it's saying is key error Eric. All it's asking you is, dude, there's no key that exists called Eric. And the reason is our key is capitalized E. So good thing to note here is that it is case sensitive. So keys in dictionaries of Python are case sensitive. You want to put the exact key that you created up top. So if you go down here and you add Eric, then press enter, you get 14. So fantastic. I mean, we've learned about dictionaries. We've learned how they work, how to delete, how to update. And in the next lecture, let's just quickly go over a few properties and functions of dictionaries that we can use. All right? See you in the next lecture. Right, so in the last lecture, we talked about dictionaries. We learned how dictionaries work, a very basic introduction on how we can use dictionaries. In this lecture, I'll just show you some basic functions that are used with dictionaries. Len, delete, keys, values, etc. that you can use to get some specific data out of your dictionary. Let's get started. The first functions that I want to talk about are dealing with deletion. Suppose we have a dictionary, and I'm going to go ahead and create, again, a student's dictionary. And I'll be quick, okay? So Jobs, I guess, Steve Jobs, his age is 15. Mark, his age is 24. And let's create one more. His name is Avi, and his age is 14. So I've created a very simple students dictionary, and you should do so as well if you have not deleted the previous lectures one. And here are the few functions I'm going to show you. So the first function here is going to be our deletion. So let's say I have this fantastic students dictionary, and then I realized, hey, I don't need this students dictionary anymore. How do I clear all the values in the dictionary? Well, for that, it's quite simple. Students.clear and 2 brackets, the parentheses, normal brackets. Once you do that, students, if you now print it out, is empty because we have cleared everything in our dictionary. Next, now we have an empty dictionary. Why are we even keeping this dictionary? Let's go ahead and completely delete it. How do we do that? So we've completely cleared our dictionary. We now have a dictionary that is completely empty. How do I just delete it? I don't want it anymore. So the way you do that is using the del command. It's going to be del and then students. So now if I print out students, I get an error. Name students is not defined. So this is basically how you clear and delete your dictionary. Next. So just like we talked about in arrays, you can find out the length of your dictionary using our len function. So if I type in len students, we will now realize, hey, there are 3 key value pairs in my students dictionary. 1, 2, 3. Quite simple. And after that, let's say I want to find out what are all my keys and what are all my values. I don't care about these pairs. I want them separate. So if you want to find out what are all my keys, you're going to use the function students dot, and you can go down and do keys. So you need to add the brackets after that. So student dot keys. And it now gives us dict keys, Mark, Jobs, Avi. So these are the 3, what would you say, keys of our dictionary. Now, if I want to get the values, I'd use the function students.values, students.values, my bad. And we now get 24, 15, 14. On another hand, I would just like to tell you, as you can see, our dictionary was Jobs, Mark, Avi, but it printed out Mark, Jobs, Avi. So Mark and Jobs got switched. And this is the thing with dictionaries. It's an unordered object. This is key. So if you keep on printing out a dictionary, you will get a different result most of the time. It's not ordered. So if I said students, give me the first value, it doesn't work like that. It's an unordered dictionary, meaning there is no indexing of the objects. It's completely random. All right. Now, before I end this lecture, let's go over another 1 or 2 functions. One last one I want to go over actually is, let's create another dictionary here. I'm going to go down to students. Let me call this students 2 and change up some of the keys over here. All right, so job mar of, and it's the same keys. And let's say I wanted to add student 2's values to my students dictionary. Well, one way you can do that is using the update function. So I could say students.update, and then I can update it with students 2's that's spelled right. Student 2's values and keys. So if I now call this function students.update students 2, and I now print out students, I now see mark of job, jobs, Avi. So I've literally added all the value pairs or the key value pairs of students 2 to students. So that's one way to add dictionaries. Again, there's probably other ways, but this is a simple function to do it. So these are the quite main functions that we'll ever use or in this course with Python. The len function, deleting and clearing of a dictionary, getting the keys and the values, and updating one dictionary to another. So hopefully you understood everything that's going on. Again, if you have any questions whatsoever in the previous few lectures, or if you're not understanding, well, what is a dictionary, why is it update, or what is students.keys, please leave a question and I'll get back to you as soon as I can. Now, in the next lecture, what we're going to do is we'll talk about tuples. So tuples, again, is another data type that's been introduced into Python, which is not in most programming languages, I believe. But let's definitely take a look at tuples and see what they can give us. All right? See you then. Alright, so today we're going to be talking about tuples. And before we even start, let me just talk about what tuples are. So tuples and lists, both of them are actually quite similar, but with tuples, the data cannot change. Tuples are what we call immutable. And all that means is, suppose if I create a tuple, and it has a value science, maths, and 23, alright? So 3 random objects in my tuple. I can't append to the tuple, I can't delete from the tuple. That tuple will remain as it is, okay? It's immutable, it cannot change. So let's go ahead and create a tuple, and then you'll slowly understand how things work. So creating a tuple is not at all hard. For example, with lists, we use square brackets, dictionaries, curly brackets. In tuples, we use our normal round brackets. So tup1 is equal to, and then let's go ahead and put in 3 objects. Maths, 23, and dogs. Alright, so this is our tuple, right? Now if you notice with our tuple, there is no append function. If I try appending something to our tuple, ASD, I get an error. Tuple object has no attribute append. If I try to delete an object of our tuple, if I say tup1 delete and delete the maths object, what happens? Tuple object does not support item deletion. So looking at these errors, we can now tell that when you create a tuple, no matter what you do, you can't edit the objects in it. However, you can always reinitialize the variable with a new tuple, so with new data, sorry. So tup1 can now be equal to cheese. And if I now print out tup1, I will get cheese because I've set the variable tup1 to a new tuple, alright? So now that we're talking about tuples, let's go ahead and understand why do we use tuples. Well, think about it. For example, if you were getting the user's location, right? What you could do is you could store his coordinates in a tuple, and you can create that new tuple every second. With lists, however, what you do is you'd append to that list every single time a new coordinate location came. So think of tuples as an immutable object which will never change. Maybe a high score. The high score could be stored in a tuple, and whenever a new high score comes, you can create a new tuple variable. Stuff like that. But basic concept is tuples do not change. Once you create one, it's hard to edit unless you create a new variable. Alright, so now that we're here, let's go ahead and talk about slicing. Just like in lists, we learned about you can slice. So I can say from tup1 to tup5, or I can get the first object, second object. Indexation is there in tuples. So I can do something along the lines of tup1, and if I want to get the first value, I'll now get maths. If I do tup1, second value, I'll get 23, and so on. And then, just like we learned about lists, there's also the concept of slicing. So I can do something like tup1, 0 to 2. So I'll get maths and 23. If I do tup1, 0 to 3, I'll get all of them. Maths, 23, dogs. So just like in lists, tuples also have the concept of slicing. You can get the first value, the second value, as many values as you want using the slicing that we learned via lists. And before I end this lecture, let's go over one more function actually, and that's going to be the delete function. So there's no way to delete the objects in a tuple. But what if you want to completely remove the tuple? You don't want the tuple to exist anymore. Then what do? Well, just like we learned with lists, it's the exact same function, del tup1. So it's quite simple actually, there's nothing much to tuples, but once you understand what's actually going on, it makes life a lot more easier. Alright, so let's quickly recap what we learned with tuples. Tuples are an immutable object. That means that the data that you put in a tuple cannot be appended, cannot be deleted. You can recreate the variable and put in new information, but once you create a tuple, you cannot change it. Now, tuples and lists are actually quite similar in the sense of slicing and data values. Tups or tuples can hold any sorts of data values that you want, and using slicing and indexing, you can get the values that you want. For example, over here, like we did, for the first value of our tuple was maths by calling this index function. Alright? Then we learned that you can also slice and how to delete a tuple. Great! So now that we've understood the basic data types in Python, I want to move on to some conditional statements, loops, and so on. See you in the next lecture. Alright, so in this lecture we're going to be talking about conditional statements. First of all, what is a condition? Think about it like this. So, for example, let's say you're thinking of creating a Facebook account. Most of you by now must have a Facebook account, but if you're still a kid like me, I still have one, but if you're less than 13, you're not supposed to. So let's think about the condition that goes in creating a Facebook account. What happens? Well, the condition is, hey, if you're older than 13 years of age, you're allowed to have a Facebook account. Else, you're not. So these if and else conditions come into play over here. Every conditional statement will have an if or an else. If the specific condition is true, do blah. Else, do blah. So we always check if the condition is true or false. If it's true, we do something. If it's false, we do something else. Let's go ahead and create a very simple if and else statement. So the way it works, if, right, we write if and then we write our condition. If 5 is greater than 2, all right, and we know it is obviously, then after the condition we put a colon and now we write our statement. So let's say if 5 is greater than 2, I want to print out my name is Bob. Okay, something, it can be anything you want. All right. So as you can see, if 5 is greater than 2, we printed out my name is Bob, and that's exactly what we got. 5 is greater than 2. Now let's bring this back one more step. So if 5 is greater than 2, print Bob. What if it's not? Else, what do we want? Well, let's think about, if 5 isn't greater than 2, then let's say, print the earth has collapsed. Alright? So obviously, now if you think about it, 5 will always be greater than 2. So this else statement will never be run. Conditional statements always work on the true and false capabilities, right? If this is true, only the next statement will get printed. Else will be completely forgotten. This will not even be considered. However, if this 5 greater than 2 or this condition is false, then we go straight to else and see what the print statement is. Alright, now let's go ahead and execute the else statement. If 2 is greater than 5, alright, print my name is Bob, else print the earth has collapsed. The earth has collapsed. Fantastic. So this is a very simple if and else statement, okay? This is where we're checking if a condition is true. If it is, we're printing out my name is Bob. Otherwise, if the condition is false, we're printing out the earth has collapsed. Alright? So fantastic job. Basically, this is just a quick introduction into conditional statements. In the following 2 or 3 lectures, we're going to talk about logical operators, alright, relational operators, and then we'll delve deeper into nested if or else statements. See you in the next lecture. Alright, so this lecture I want to devote to operators. Right, in the last or actually in the previous few lectures, we've learned about our normal operators, which were addition, subtraction, multiplication, division, and so on. However, in this lecture, we're going to be talking about relational operators. So going back to our if statement, alright, I'm going to create that same if statement again. If 5 is greater than 2, print hello. Alright. If 5 is greater than 2, print hello, we get hello. However, over here, I want you to know what is this, right? This 5 greater than 2. What does this greater sign even mean? Well, this is what we call a relational operator. These relational operators help us to compare and contrast values to get a Boolean value. So, a Boolean value, I'm sorry, I haven't explained this before, is a true or a false. So every time we use a relational operator, we'll always get a Boolean value back, either a true or a false. It's actually quite neat. So in all, there are six relational operators in Python till date that I know of. And these are greater than, less than, greater than equal to, less than equal to, equal to, and not equal to. So let's cover all 6 in this lecture, and then we'll move on to some more complex if and else statements. First, greater than. So as you see already up top, we've discussed what is greater sign. If you do 6 greater than 3, you'll get true. If you do 3 greater than 7, we'll get false. So the greater sign compares to see if this value, the first value, is greater than the second value. Obviously you know that, so I'm not going to talk too much about the mathematical part. I'm just showing you what the operators do. Next, less than. So we have 4 less than 8, true. We have 3 less than 1, false. So this is greater than, less than. We can compare to see if an object is greater than or less than the other object. Now we come to greater than or equal to. So what greater than or equal to checks is, hey, is this object greater than this or is it equal to this? If either one of these conditions is true, then it will return true. Alright, so let's go ahead and check it out. If 4 is greater than 4, we get true. Because even though 4 is not greater than 4, it's still equal to 4. And that's why we got true. The exact same way we can check if 5 is less than or equal to 6, for example, it's going to return true. And if you do 5 is less than or equal to 5, we still get true. But because even though 5 is not less than 5, it's still equal to 5. Fantastic. So we've covered 4 of the 6 main relational operators, and the last 2 I believe are the best 2 operators. First one is the equal to equal to. So let's go ahead and create an if statement where we're comparing 2 of the same numbers. So if 5 is equal to 5, okay? If 5 is equal to 5, and we get an invalid syntax. So this is key, alright? It says invalid syntax, and you're probably wondering, what's wrong? All we're saying here is if 5 is equal to 5. I mean, there could possibly be nothing wrong in this statement. However, think about it. When we're initializing a variable, what's happening? If I create a variable called apple and set it equal to 5, what am I saying? I have created an instance of something and I'm setting the value of 5 to it using an equal sign. The exact same way Python thinks. What Python is seeing here is you're setting the value of 5 to 5. This equal sign means you're assigning the value of B to A. You're not comparing, you're not contrasting, you're setting the value of something to something else. And that's not what we want. This is where the double equal sign comes in. If 5 is equal to 5, alright, if you use a double equal sign, that specifies that you're comparing and contrasting. You're just checking to see if the value 5 is equal to the value 5. Obviously it is, so let's go ahead and print out hello. And we're gonna get hello, alright? So the double equal is used to compare and contrast to see if the values are the same, and the single equal is to assign a value. Remember that because it's going to come into use a lot in the following few sections. So the last relational operator is the not equal to. And all this checks to see is to make sure object A is not equal to object B. For example, if I say 4 is not equal to 6, I get true because 4 isn't equal to 6. If I say 4 is not equal to 4, I get false. Alright, so we're finally done with relational operators. We've discussed all 6 of them: greater than, less than, greater than equal to, less than equal to, double equal to, and not equal to. And all 6 of these relational operators will be used in our future lectures when we deal with more complex if statements, else statements, loops, etc. So go ahead, play around with these operators, get a feel of it. Again, instead of numbers, try using variables. Create a variable called num1, you can set that equal to 5, num2, you can set that equal to 6, and you can compare and contrast these different variables. So all I want you to do is get a hang of these relational operators, make sure you understand what each one of them does, because in the future we'll be using them a lot. So fantastic job, and in the next lecture what we'll do is we'll cover some more complex if and else statements. And actually, before we even get to that, I want to talk about indexing or spacing in Python. See you then. Alright, so in the last lecture, we talked about relational operators. We discussed about the 6 operators: greater than, less than, greater than equal to, less than equal to, equal to, and not equal to. So these 6 relational operators are used in if and else statements. Now, before we get to loops and what they do, I quickly want to go over nested if statements. So far, all we've discussed is if and else statements, and we've understood how they work. In this lecture, what I want to do is, again, nested if-else statements. I want to go over that. And then we'll also go over another type of if statement called elif. Okay? if, else, elif. So let's get started. First thing first, nested if statements. So I'm going to create a very simple if statement right now. First, I'm going to initialize a variable called age and set it equal to my age, 14. And now what I'm going to say is, if age is greater than 13, I want to say print you are eligible for Facebook. All right. So like we've discussed before. And as you can see right now, you are eligible for Facebook. Fantastic. So we created a very simple if statement over here. We just check to see if the variable age is greater than 13. Now what I want to do is I want to say, hey, if the age is greater than 13, all right, if that's true, fantastic. Then I also want to check for if the user's name is Bob. If it's Bob, you get special privileges. If it's not, then print the regular eligible for Facebook. This is where nested if-else statements come in. Let's take a look. So over here, once I do if age is greater than 13, instead of doing the print directly, I'm going to put a new if-else statement. If age is greater than 13, if name, so actually before we do that, let's go ahead and initialize my name variable. So, alright, it looks like it's not letting me delete that. So let me go ahead and create a name variable. Set it equal to Bob. Alright, so if age is greater than 13, now we put our second if statement, which is called a nested if statement. If name is equal to Bob, then what do we want? Print, whoops, you get special privileges. Alright, and now let's go ahead and add the else statement. So if name is equal to Bob, print you get special privileges, else print our normal you are eligible for Facebook. Print you are eligible for Facebook. Alright, so now if we run this, we get you get special privileges. So this is the concept of nested if-else statements. Basically all we're doing is we're adding one if statement under the second. And you're probably wondering, how do I know if it's nested or not? That's where the spacing comes in. Alright, so right here we can see that if age is greater than 13 is the highest in the order. That is that this is the biggest index so far. Then you can see that this if and else are the next subclass of if, and then after that print is part of this if statement and this print statement is part of the else. So spacing or indexing, I'm not sure what you'd call it here, is quite key in Python. You need to make sure that your spacing is right. So if we had done the print statement over here, okay, it would have done we would have got an indexer. So over here, if I backspace this print, and now if I hit enter, you get syntax error, expected and indented block. So these indents are actually quite key in Python. Again, that's something you should know. So whenever you're writing Python code, normally it'll do it for you. But if you're writing maybe an HTML doc or something, then make sure you get your indentation right. Alright, so let's go ahead and end this lecture over here. In the next lecture, we're going to talk about elif statements. So this lecture we learned about nested if and else statements. I thought that was pretty cool. Now what you can do is you can put multiple if and else statements in one bracket of code. Fantastic. See you in the next lecture. Alright, so in the last lecture we left off with nested if and else statements. This lecture we're going to talk about elif statements. So let's get started. First off, we've learned that if and else statements work on the following basis. I can say if, or first of all, let me create a variable. I'm going to call it day. Day is equal to, today is Tuesday, so I'm going to go ahead and put in Tuesday. Alright, whoops. Okay. Day is equal to Tuesday. Now, let's say I'm checking for each day. So if day is equal to Monday, then print sunny. Alright. And now I do a simple else statement over here to specify, oh, whoops. My bad. Again, my bad. Alright, one sec. So else print rainy. Okay? And for the specific, the basis of this program, it works fantastic. If day is equal to Monday, which it's not, it won't print sunny, it's going to print rainy. However, what if I wanted a specific case for Tuesday? I have if day is equal to Monday. Monday is a possibility. But what if day is equal to Tuesday? I know that on Tuesday it's going to be cloudy. But based on this code, cloudy will never come. How do I make it so that cloudy comes? Well, this is where elif statement comes in. And if you've already guessed it, elif stands for else if. So basically, it's another if statement you can add. So let's do this. If day is equal, let me just bring this down over here. Actually, that's fine. If day is equal to Monday, all right, this is our first statement over here. I want to say print sunny, right? Now, else if, okay, elif day is equal to Tuesday, I want to print cloudy, okay, this is our second exception or second condition. And otherwise, if none of them are true, then I want to print out rainy. So think of elif as another one. Oh, okay, sorry about that. Looks like it's a spelling mistake. I spelled Tuesday wrong. Tuesday, my bad. So now if you enter this out, we get... Wait, what? Oh my god. Okay, my bad, guys. I spelled day wrong, or I spelled Tuesday wrong and day as well. So if day is equal to Tuesday, all right, let's get that straight. And then let's bring this if statement down and run this again. Cloudy, yay. So this is the whole concept of elif. For example, if I have multiple conditions I want to go through and it's not being done in my simple if and else program, what I can do is I can continuously add more and more of these elif statements. These are basically, if this is true, do this, else if this condition, then do this, else if this condition, and so on until you get to an else where if nothing else, if none of these options return true, then do the else. So you can play around with the elif. You can create some very simple, what would you say? Some simple if and else or elif statements, and yeah, fantastic. There will be some exercises again at the end of the section where you can quickly go through your what you've learned. If you want some practice with this if and elif stuff, definitely take a look at the exercises. Otherwise, let's move on to the next lecture, which will be about loops. See you then. Alright, so today we're going to be talking about logical operators. And so far we've discussed arithmetic operators, the plus, minus, divide, and multiply. We've talked about relational operators. We've greater than, less than, equal to, greater than, equal to, and so on. And finally, we now get to our logical operators. So I wanted to cover if statements and else statements before we talked about logical operators because that's where we actually use them. So I'm going to create a quick if statement over here. So first let me initialize a variable. I'm going to do another age. And if age is greater than 13, print you are eligible for Facebook. So again, this is the same example we used before, but I want to show you something here. So let's say I have this fantastic if statement, okay? If age is greater than 13, print you are eligible for Facebook, everything works and it's fine. What if I wanted to check for more than one condition in my if statement? For example, if the age is greater than 13 and his name starts, or if his name is Avi, then he's eligible for Facebook. If his name is not Avi, then he's not eligible for Facebook. How does that work? Well, this is where logical operators come in. What we can do is we can say if age is greater than 13 and the second condition. So if age is greater than 13 and name is equal to Avi, I know we haven't initialized the name variable yet, but that's fine. Print out you are eligible for Facebook. Eligible. So today was an error, name is not defined, and so on. But here I just wanted to show you how you can use logical operators in if and else statements to add more than one condition in the same line. So let's quickly cover what logical operators there are. There's actually two, and or. So for and to work, for and to return true, condition 1 and condition 2 must return true. It can't be that this one is false and this one's true, or this one is false and this one, I'm not sure what I'm saying. So it can't be this one is true and this one is false, or this one is true and this one is false. Both the conditions must return true for the statement to work.
However, with OR, let's go ahead and initialize a name. I'm going to call myself Bob. So let's go ahead and bring this statement down. If age is greater than 13, or, does it let us change? Yes. If age is greater than 13 or name is equal to Avi, print eligible. Now if you notice, it prints out eligible. And you're probably wondering, well, name isn't equal to Avi. How is this working? This is the case with OR. With OR, it doesn't matter which condition is true as long as one condition is true. For example, age is greater than 13. My age is 14. 14 is greater than 13. However, name is false. This condition returns false. But since there is a true, since this condition is true, no matter what the case is for the second one, this can be true or false, we'll get the eligible statement printed out. So this is the thing with AND and OR logical operators. You can use them in your if statements, else statements, wherever you want, but they allow you to add more and more conditions to what you already have. Whenever you're creating an app or whenever you're doing Python coding, if you have multiple conditions you need to check to, you can do it all in one line. Alright, so this is basically what I wanted to cover for this lecture, and now we're finally done with operators, and I'll see you in the next lecture.
Alright, let's get started with loops. So, first thing first, what are loops and how do they work? Well, loops are basically code that is done again and again until the condition becomes false. So think of it like this. The condition is checked. If it's true, the code or the conditional code is run, and then the condition is checked again. If true, the conditional code is run again, then the condition is checked again. And this cycle keeps on going until the condition becomes false, and then the loop stops. Alright? So loops are very, very useful in Python, and there are two types of loops. For this lecture, we're going to be discussing about for loops, and in the next lecture, we'll actually talk about while loops. And then there's also nested loops and so on, but we'll get to those in a different lecture. So, for loops, okay, what are for loops? For loops basically execute a sequence of statements multiple times and abbreviates the code that manages the loop variable. So, a simple for loop here would be, for example, the way you're going to write it is for, and then a variable name. You could say for I, for A, for Bob, anything, but normally you use a letter. So for I in range, okay, and then you put the range brackets from, let's say 0 to 5. 0 to 5. Do what? Print I. Alright, so let's take a quick look at what this code is doing. For I in range 0, 5. All this statement says is assign the value from 0 to 5 to I. So I value becomes 0, I's value becomes 1, I's value becomes 2, and so on until this loop ends. And then all we're doing is print I. So if we run this, we get 0, 1, 2, 3, 4. Fantastic. So this is what we call a very, very simple for loop. Okay? So, what's next with for loops? Well, you can iterate through lists, dictionaries, tuples, and so on. So let's create a quick list over here. I'm going to call it shopping list. And let me go ahead and add some items. So, whoops. Milk, eggs, one sec. Oranges. Alright? This is my shopping list. Now what I can do with for loops is I can iterate through the shopping list. Well, how is this going to work? Let's take a look back up here at what the code was doing. When we said for I in something, all we did is we assigned the value of that something, we iterated through it, and we assigned each of the values to I. So every time a value was assigned to I, the code ran, or the code was run. So over here in our shopping list, what we can do now is for I in shopping list, okay? So for I in shopping list, all we have to do is print I. And when we do that, we're going to get milk, eggs, orange. So it's pretty simple. With the for loop, there's two things you can do. One is you can set a range, and this range can be from any value you want, from 0 to 10, 10 to 15, whatever you want, and it iterates through those numbers. It'll go, if you're doing from 10 to 15, 10, 11, 12, 13, 14. And then what you can do with for loops is you can iterate through a set of data. For example, if I have a tuple, let me go ahead and create a tup. Tup is equal to 2, 4, 3, and 6, 2, 43, 6. I can say for I in tup, print I. And what do I get? 243, 6. So you can use for loops to iterate through data as well. Now let's go back to our range function over here. What we did is we called for I in range, and then we specified the starting value and the ending value. Guess what? There's more to it. Right now, all we've done is we've set the value as the x and the y, so the starting value and the ending value. But there's also one more value you can add to this range function. Think about it. You might get it, you might not. But basically, what it is it is called the incrementator. Okay? You can add the increment factor as well to this for loop. For example, if I wanted all the even numbers, okay, how would that work? I do from, let's say, the first 50 even numbers. So I do for I in range, my starting number, to my nth plus 1 number. So if I want 100, I do 101. And then what am I counting by? I'm counting by 2s. Okay? Again, this is very cool. So it looks like it gives me invalid syntax. That was because I forgot my colon. So for I in range, 0, 101, 2, print I. Now, if you're one step ahead of me, what does it print? It prints all the even numbers from 0 to 100. Isn't that cool? So let's go back to the code we wrote. And let me just explain this one more time here. The range function, which is this, takes in 3 parameters. The starting value, the ending value plus 1, and then the incrementator. So do you want to go by 2s? Do you want to go by 1s? Do you want to go by 3s? And you can go negative as well. For example, if you want to count down from 100 to 0, your starting value would be 100, your ending value would be 0, and then you'd say the incrementator as -1. Something along those lines. Well, let's go ahead and give it a try. So can we change this? Yes. 100, 0, -1. Does it allow us? Let's take a look. Yes, it does. As you can see, now we're counting down from 100 to 1. So this is some of the benefits of the for loop. You can do code quickly. Instead of printing out each of the individual items of a list, or let's say printing the numbers from 1 to 5, you do print 1, print 2, print 3, and so on. Instead of doing all those accumulative print statements, you can do it in 2 lines. For I in 1, 6, print I. And all that returns you is... Oh, I'm sorry, I forgot the range function. My bad. Oh, God. For I in range 1, 6, print I, you get 1, 2, 3, 4, 5. So this is where loops come handy. They make your code work much faster, much easier, and much simpler. Fantastic job, guys. If you have any questions about for loops, definitely leave a comment. For loops are amazing to use and I love them. Now, on the next lecture, what we're going to do is we're going to talk about while loops. So this lecture was a brief introduction to for loops. I just wanted to give you the idea of how it worked. And in the next lecture, let's talk about while loops. Alright, so in this lecture, we're going to be talking about while loops. Okay, and let's go ahead and understand what while loops are. So in the last lecture, for loops were something where we used a range function or we iterated through a set of data. While loops, on the other hand, are completely different. The way while loops work is it repeatedly checks for one single condition. If that condition is true, the code runs. If that condition is false, the code or the while loop ends. Alright? So it's very interesting, very fun. Let's go ahead and check it out. So I'm going to create a variable. I'm going to call it counter. Okay? And I'm going to set it equal to 5. So looks like that slash was on an accident, my bad. And over here what I want to do is I'm going to say if while counter is less than 10, okay? While counter is less than 10, print counter or quota, print counter, and then I want to increase counter by 1. So it's giving me an invalid syntax. That's something I picked up while using Swift, my bad. So counter is equal to counter plus 1. And I'll explain what I'm doing. Alright, so 5, 6, 7, 8, 9. Let's go over the code we just wrote. While counter is less than 10, what does this statement say? All it's saying, or I mean pretty much it's simple English, it's all, it will, Alright, so let's take a look at what this code is doing. Over here, the first statement, while counter is less than 10, is the conditional statement. All it's checking to see is, has the value of counter become greater than 10? If it has, then this loop will end, otherwise this loop will go on forever. Now, the next two statements, printing out counter and then increasing the counter by 1. Now you're probably wondering, well, why are we increasing the counter by 1? I mean, why does it have to do with anything? Well, let's go ahead and leave it. While counter is less than 10, print counter, and nothing happens. Well, why? Because right now, if you print out counter, its value is 10. We've already set up counter to be increased to 10. Let's go ahead, set counter back to 5, and print out or run the statement again. What happens? Your system will eventually crash. I'm not going to show you, but in the end, your IDLE will crash, some bug will happen. Anyways, I'm going to restart my shell. So, shell, restart shell. Yes. And that ended the program. Anyways, as you can see, you need to have a way to end this conditional statement. You shouldn't have an infinite loop. Right now, what we created is an infinite loop. Counter's value is never increasing. So this whole condition is sort of pointless, and the function or the code after that will be running forever. Anyways, this was a brief introduction to while loops. Play around with them. Again, they are very interesting. You can play around with the conditions, but the basic format of the while loop is it keeps on checking for a condition, and once that condition becomes false, the whole loop ends. Infinite loops are actually pretty cool. I mean, you can always create one and see how long your machine lasts until it dies, but don't do that. It's gonna be a burden to your machine. Move on, and in the next lecture, let's talk about nested for loops. See you then. Alright, so in this lecture, we're going to be talking about nested loops. And just like we learned about nested if and else statements, the concept is quite similar. Let's get started. So I'm going to create a very simple for loop for I in range 0 to 5, I guess. And then what I'm going to do is I'm going to create another for loop inside of this. For A in range 0 to 5, print A. So I'm going to give you a quick quiz actually. I'm sorry. A quick quiz as to how many times do you think a number will be printed. I'm not asking a specific number, just how many times do you think a number will be printed from this above code? 5, 10, 25, 50, how many? So give it a thought, think about how this code is going to work, and then once you're done, run the code and let's see. So hopefully you've got your guess by now, and let's go ahead and run this. What happens? Well, it ran 25 times. So if you got 25, fantastic job. Otherwise, let's go ahead and see why. First statement says for I in range 0, 5. Let's take it from the beginning. So 0 was assigned to I. As soon as 0 was assigned to I, this function ran for A in range 0, 5. So in this function, 0 was assigned to A, then it printed A. 1 was assigned to A, then it printed A. 2, 3, 4 were assigned to A, and then it printed A, and then finally we came back to this for statement. Then 1 becomes assigned to I, and then it goes again. So basically this function is being repeated 5 times. This is where nested loops come in. Later on when we get to exercises, when we're creating maybe a prime, finding prime numbers or stuff like that, that's where this comes useful. So actually, you know what? Let's go ahead and create a prime number generator. This is our challenge for today. So what I want you to do is, using your knowledge about for loops and about the modulus sign, the remainder sign, again, if you forgot what it is, if I do 5 mod 2, it's 1. I believe I have taught you about the modulus. If I haven't, I'm sorry. So modulus sign is basically a remainder sign. So what I can do is I can check, for example, what is 6 remainder 3? Or 6 divided by 3, do I get a remainder? No, because 3 is divisible by 6. If I do 8% 2, I'll get no remainder because it's divisible by 2, but the mod sign gives me the remainder. So knowing that, and knowing how your for statements work, can you give me the first 10 prime numbers? This is my challenge to you guys. If you can, fantastic. If you can't, wait for a few seconds and let's try it out. Alright, so with the knowledge of modulus, what I want you to do is create a very simple prime, give me the first 10 prime numbers. And no, I don't want you to print out 2, 3, 5, 7, and so on. I actually want you to use your code using for loops and get me those first 10 prime numbers. So I'm going to end the video here and I'm going to give you some time to do it. If you're not sure how to do it, do not worry. I'll explain it in the next video. Otherwise, if you have some idea of how prime numbers work, definitely give it a try and let's take a look at what you get in the next lecture. Alright, so today we're going to be creating a very simple prime number generator. And in this prime number generator, all we want is the first 10 prime numbers. So I know that the 10th prime number is 29. So I'm going to generate numbers from 2 to 30. Alright, so for I in range 2 to 30, my bad, 2 to 30, or 30, yes, 30. What do I want to do? Well, let's think about actually how this prime number generator is going to work. So we have our numbers, okay? The number that we want to check if it is prime is going to be stored in our I variable. Now we want to create another variable, all right? And we want to keep on checking. So let me go ahead and show you via Paintbrush, okay? Paintbrush is a fantastic tool. I'm going to go ahead and open it up and let me show you guys how this is going to work. So explaining is a bit tough for me, especially how this this is going to work, but one sec. My bad. So okay. Alright, so let's take 5 numbers for example. I'm going to take 10, 11, 12, 13, and 14. How is this going to work? So these 5 numbers are stored in our I variable, okay? Once our for loop runs, these 5 numbers will eventually come. Now, the way this prime number generator is going to work is, we're going to take another variable. We're going to call it j, okay? J's value is going to start from 2. And it's going to go all the way up till this number, or less than this number. So J's condition is going to be, J has to be less than 10 or less than I. This is the condition we're creating over here. J has to be less than I. Alright. Now once this condition is true, we want to check if I percent J is equal to 0. What does this mean? If I percent J is equal to 0, we know that this number is not a prime number, okay? If I percent 0 or I percent J is not equal to 0, then we increase J by 1, okay? This whole loop keeps on repeating until J becomes equal to I. And when that happens, we know that I is a prime number. So this may have been a little bit confusing to you. Listen to this again, and once we write the code, you'll actually understand what's happening. So I'm going to go ahead and minimize this or close this, and I'm going to get started on this code. So we have for I in range 2, 30. So I'm going to initialize my j variable over here. J is now going to be equal to 2. So while j is less than I, okay, while j is less than I, what do I want to do? Well, I want to say if I percent j is equal to 0, alright, if I percent j is equal to 0, so what I want to do is, before I actually even add the function over here, if I percent j is equal to 0, I want to create a variable called counter and set that equal to 0. So if I%j is equal to 0, this means that if the I number is divisible at all, okay, then I want to set counter equal to 1. Else, I want to increase j by 1. So j should be equal to j plus 1. So this cycle will keep on going until j is no longer greater than I, or j is no longer less than I. And then what we can do is say, if counter is equal to 1, right? If counter is equal to 1, then print I plus is a prime number, okay? And then we want to set counter equal to 0, all right? So I think this should work, and don't worry, I'll explain the code, but let's go ahead and run this. Let me take a look here. Looks like it wants an else statement. So else print, whoops, caps lock on. Else print hi, something random. I'll tell you something later, but right now so it looks like this isn't running. Alright, so I got the code to work, and I'm sorry I didn't show you what I was doing, but I was running into an error, and I fixed it, but your code should look something like this. And let me go ahead and explain what I'm doing. For I in range 2, 30, basically this is going to generate the numbers 2 to 29. Then I'm setting our divisor variable. This is j is equal to 2. So j is a divisor variable, and we're dividing I by j. So we have a counter variable called 0. While j is less than I, we never want our divisor to be equal to our main, what we're dividing. So just like with prime numbers, a prime number is a number which is divisible by itself and 1. If j becomes equal to I, then that fits the value of dividing it divisible by itself, which we don't want. That's why we've said while j is less than I. Then we're checking if I is divisible by j. Now if I is divisible by j, we're setting counter as 1. And when we set counter as 1, that means the number is not prime. It's a no-no. We don't want this number to be added to our list of primes. And in any case whatsoever, if it's divisible or if it's not, we want j to increase by 1 since we've already checked if it's divisible or not. Then we're checking over here if counter is equal to 0. So throughout this whole while statement, if the number wasn't divisible by any of the other numbers and it still remains 0, we're printing out string of I. So str is a function in which we can convert integers to strings, is a prime number, else counter is equal to 0. So this if and else statement basically checks if counter is equal to 0, we're printing that this is a prime number, else that means that counter is equal to 1, and we're setting counter back to 0. So if I run this, I get 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 are all prime numbers. Fantastic. So this was a very simple way to generate the first 10 prime numbers. We've used nested loops in this code. We have learned about the string function, which converts integers to strings, and we learned about nested if and else statements, stuff like that, but definitely a fun project. So you can go ahead and expand on this. You can make it go to 100, 200, whatever you want. I will be providing the source code for this, don't worry. So in case your code went wrong or you're doing a mistake, definitely download the source code in the next lecture and have a great day. So what we're going to do next is let's go ahead and discuss, let's take a look. What's next in our... Alright, fantastic. So great job on this project. I have the source code ready. In case you have an error or something, please definitely drop or download the source code and take a look at my code versus your code. If you have a question how things work, again, I agree I didn't explain it too well at the end. I got a little caught up in some error and then I fixed it myself. But if you have any questions on how this works or why that, definitely drop a question. I'll get back to you as soon as I can. And that's it. See you in the next lecture. Alright, so today we're going to be talking about loop control statements. And basically what they do is they deviate the loop from its normal sequence. Once these statements are used, then either the loop ends or something happens, but the whole loop doesn't run like it is, okay? So let's quickly talk about the three main loop control statements. So there's three of them, right? Break, continue, and pass. Break, continue, pass, BCP. So the first statement we're going to be talking about is break. And all break does is it terminates the loop statement and transfers the execution to whatever's next. So for example, I'm going to create a while loop over here. While counter, or actually let me create the counter variable first. So counter is going to be equal to counter is equal to 0. Alright, and then let's go ahead and create the while loop. So while counter is less than 100, print counter is equal to counter plus 1. So do this and we get all the numbers from 0 to 99. Fantastic. Now, what if I told you I want this loop to end after the fourth number is printed? How would that work? Well, let's go ahead and get our code back from up over here. And this is where the if and else statements come in, or actually the break statement here. So if counter is equal to 4, for example, then I want to break. So as you can see, as soon as we wrote break, it has now been highlighted in orange, which means that it's an inbuilt Python function. And now if we run this, counter right now is 100 still, so let's go ahead and set counter back to 0. And now if we run this program, we get 0, 1, 2, 3, and then as soon as counter hit the 4, the whole function broke, or the whole loop broke. So this is the nice thing about break. For example, wherever you're running this huge while loop, but somewhere in the middle, once your task is complete, you can break the loop to save yourself some time, some energy, etc. So the break command is actually quite useful, and we'll definitely be using it in the future. Now, the second one I want to talk about is pass. Many a times when you're writing Python code, especially with loops, you'll come to a point where you have this if and else statement, and you need an else, but you're not sure what to write in the else statement. For example, let's go ahead and get this code down over here. So if counter is equal to 4, break, else, else, pass. So all the pass statement does is when you use the pass statement when you don't want any code, anything to be run. So when we use the pass statement in this else part, all it's saying is I don't want you to do anything. Just continue along whatever you're doing. I don't care about this. Just let it be. So pass is basically what you'd call a filler statement. Doesn't do anything, but it acts as code. So right now, once we run this, we'll get, or let's set the counter back to 0. Sorry about that. Counter is equal to 0. And now if we run this code, so let's go ahead and run it, we'll get 0, 1, 2, 3. Because every time when it checked, is the counter equal to 4 and got no, it just got passed. So nothing really happened. So pass is quite useful whenever you're dealing with code that you don't have anything to write, or it's an if and else statement and you're just trying to filler up. Those filler up code pass is fantastic. Now last but not least, we're talking about the continue statement. So the continue statement rejects all the remaining statements in your loop and moves the control to wherever you want it. So the way this would work is, for example, let's go ahead and create a very simple for loop. Alright, so for I in, let's go ahead and iterate through a string. So for I in Python, okay, let's say if letter is equal to edge, so actually if I is equal to edge here, equal to edge. So I know I haven't talked about this before, but if you iterate through a string of some sort, I will be assigned each character of the string, so Python. So if I is equal to edge, then I'm going to say continue. And I'll explain this code, don't worry, but let's go ahead and take a look at what it does. So if I is equal to edge, continue. And then I want to print out I. All right, so a very simple, what would you say? A very simple for loop in which we're using continue. So print I. Let's go ahead and run this. We get Python. Wow. So let's see what just happened here. We used this for I in Python. Okay, we iterated through each character of Python, and then we said if I is equal to h, continue. And all continue did is it bypassed anything else that was written here. Okay, bypassed it. Didn't care about what was there. Just moved on, and then the loop started again. So continue is neat when you have code that you don't want to run, but it's there. So you're using that code for the beginning few letters, but then for maybe the sixth letter, you don't need that code to be run. That's where you'd use the continue function so that this all the other code would not be even considered. So let's go ahead and let's do one more example with continue. So I'm going to create another for loop for I in range 0, 5. And then I want to say if I is equal or if I is less than 2, then I want to continue, and then I want to print out I. So now if you notice, if you run this, we're only going to get 2, 3, and 4 because continue will bypass any statement that is underneath it. And I guess continue is actually quite a neat statement when you're dealing with codes of some sort. But yeah, these are the 3 main loop control statements. Let's quickly recap what we learned. There's break, there's pass, and there's continue. So what does break do? Break breaks out a loop. If you're in a for loop, it'll break out of it. If you're in a while loop, it'll break out of it. Just completely ends the execution of the code. Next, we have, let's go with pass. Pass is basically that filler statement. For example, if you have code, but you maybe have an if and else statement, and you have the if part done, but for else, you're using like those normal print statements that print out gibberish because you have nothing to do there. That's where you'd put a pass statement so that it would act as a filler code. And then last but not least, we have continue. For example, if you have an instance where you don't want the below code to run, you'd do an if statement for that specific instance and then write continue. And all continue would do is bypass any of the code written underneath it and make sure the loop iterates over once again. So definitely 3 very neat functions that we'll be using later on in the course. Make sure you mentally note these down or jot these down that there's break, pass, and continue. And I'll see you in the next lecture. Alright, so before we end this section about for loops, while loops, conditional statements, and so on, I actually want to end this with another part of Python that we haven't discussed, and it's called try and except. So sometimes when you're crawling the web for data or whenever you're using Python for web purposes, stuff like that, you may run into errors and you never know when that might happen. For example, you have a program and it's working the day when you have Wi-Fi, the next day it's not working because you don't have Wi-Fi. So instead of getting the error, how do you make it a better experience for the user and maybe show that error message when there's no Wi-Fi or when an error occurs? Right now, what will happen with your code is, for example, if we are trying to open up a web page using Python. So if we don't have Wi-Fi, our build will just crash. However, what we can do is, using the concept called try and except, we can try to access the website's data, and if it doesn't work, go to except and then print out a statement such as you have no internet connection, stuff like that. So the whole purpose of try and except is to make sure that in case any errors occur or in case something goes wrong, then we can go directly to the except and like maybe tell the user, hey, something went wrong. For example, I'm going to say over here, try if name is greater than 3, print hi. As you can see, I haven't initialized the name, so it will immediately go to my except statement. And I'm going to say print out over here, Python ran into an error. Please take a look at your code again. Okay? So as I run this, it now prints out Python ran into an error. Please take a look at your code again. So this is the whole concept of try and except. And this is why I love using it. Whenever in my Python code, if I know What if this variable won't be initialized? What if the user doesn't have internet? Stuff like that. Always use a try and except. That way, in case your Python build or Python script crashes, then what you can do, directly go to the except and say, print Python ran into an error, or something's wrong, please try again, stuff like that. So it's try and except. It's not in many languages, it's especially useful in Python. This is just something I wanted to show you guys. Again, play around with it. Basically, whenever an error occurs in the try portion, it'll go directly to except and follow through over there. So cool, and I'll see you in the next lecture. Alright, so before we head on to some more complex stuff like functions and object-oriented programming, I want to cover some of the basic problems you might be having with Python. The first is commenting. In any programming language that you'll ever deal with, commenting is must. Now, I don't do it, and that's something I should fix, something I should improve on, but whenever, or at least for you beginners, you should definitely start commenting the program that you write, or the code that you write. And if you don't know what commenting is basically when you write normal text, right? And that normal text tells you, I was doing this, then this happens, then this happens. For example, let's say you're learning Python right now, and then after this, you pick up Ruby, then you pick up Swift, then you pick up HTML, CSS, and then when you come back to Python, you'll be like, what is this code? I don't understand what I wrote. This is a problem I've had many times when I go from one code to another. This is where commenting comes in. So a comment is basically, in Python, using a hashtag. So if I use a hashtag, and now if I say something along the lines of, this is a comment, it's now taken as a comment. As you see, I have no errors, stuff like that. I can do it like this again, but it gives me an error, invalid syntax. Now, using the shell for comments is not the best thing. Using comments you should use comments in files. So I'm just going to quickly open a new file, and in this new file, you can now see I can put as many comments as I like. So if you're wondering where would I use comments, you would use comments when you're writing your code. For example, if you're creating an if statement, if var or if 3 is greater than 2, print AST. So here I would use the comment that the greater sign signifies or compares the first object to the second object, and if is a conditional statement. So as we go along in the course, make sure to take several comments in your code. Again, most of the programming will be done in the shell, so there's no need to do comments, but if ever you're creating a program in a new file of some sort or in a different IDLE of some sort, then definitely use comments because they're quite helpful. Now, before I end this lecture, what if you have multiple comments? Instead of writing these on 2 lines using several hashtags, adding more and more hashtags, wouldn't there be an easier way if I could open a comment, write as much as I wanted to, and then end the comment? Well, this is where the triple quotation mark comes in. So it's quite neat actually, and all you do is you write 3 quotation marks, and then you can add any comments that you want. It can be any gibberish, any of some sort. However, it can be as many lines as you want. This is the triple quotation mark, okay? You can also use single triple quotation mark, but it's easier if you just use a double. It's fine. So I can write any comment that I want to, and it can span multiple lines. And then when I want to end it, use the triple quotation marks again. One sec. Alright, so I use the triple quotation marks, and now as you can see, this has been created into a fantastic comment. So this is the whole gist of the lecture. I just wanted to introduce you how comments work. Again, quick recap. You use a hashtag symbol for a 1-line comment, and to do multiple line comments, you can use triple quotation marks. See you in the next lecture. Alright, so before we actually get to functions, I'm sorry, you're probably wondering when will we get to them? Well, I want to cover a few more basics of Python. So one of them is quotation marks. Right now, when we create a string, and set that equal to a string, I use AST, blah, blah, blah. String is created, right? And if I print it out, I get AST. However, you can also use single quotation marks. I know I haven't talked about this, but let's go ahead and try it out. I can say string is equal to single quotation marks, and then in that, anything I want. Print that out as string, you get AST, AST. And then, let's suppose you put double quotation marks in the beginning and single quotation marks at the end. It gives you a syntax error. So I just wanted to talk about how these quotation marks work in Python. Well, you have to use the exact same quotation mark you're using in the beginning at the end. So if you're starting with a single, you can use a single. If you're starting with a double, you use a double. Now, as we're talking about strings, let's go ahead and cover one more subject with them. And that is that over here, for example, let's say I wanted to create a statement called like this. So, one sec here. It's a nice day today. Or it's a nice day. Okay, a very simple English statement, it's a nice day. However, if we now print out string, it works. It's a nice day. And the reason this has worked is because you're probably wondering, well, we have a single quotation over here. Why didn't it pick up an error? Well, the reason is because the double quotation and the double quotation match. You can put as many single quotation marks you want in the middle, but since it's a string and you've put the double in front and the double in the end, it's okay. However, if we did the same thing, but instead we put a single quotation mark and a single quotation mark, we get invalid syntax. So this is where the concept of escape characters come in. Alright, let's go ahead and bring this line again. To make sure that Python doesn't consider an apostrophe as a string apostrophe and instead as an English wording apostrophe, what you can do is in front of the apostrophe, put a backslash. And all this backslash does is it says, hey Python, this is part of the statement. Don't count this as an apostrophe to the string statement. Now if we print out string, doesn't give us an error, it's a nice day. Isn't that cool? So this whole concept is called escape characters. Putting a backslash in front of the apostrophe so that it's counted as normal English text. Fantastic. So this is it to my basics of strings. I just want to talk about a few things. And before I go, or before I actually end this lecture, one last thing. Alright, so let me quickly open up a new ideally, just restarting the screen and stuff. But there's one last thing I want to show you, okay? And this is the concept of, suppose I'm writing a huge if statement. So I'm going to create two variables. I'm going to call mine blue oranges with cheese. I'm going to set that value equal to A. And I'm going to create another variable. Cheese fried dumplings with cherry sauce. Set that value equal to B. So many times in coding, or especially with Python, you'll notice that as you're typing, your screen will take up a lot of the text and it'll go to the next line and stuff. So how do we get rid of that? For example, if I say if blue oranges with cheese is equal to cheese fried... I have no clue what I write. I'm sorry. I have no clue what I wrote. Wait. Let me just copy paste. Command C. Command V. Alright? So this works, right? There's nothing wrong with it. But it's long and it's confusing and I have no clue what's written. So what I can do is using a backslash, or wait. I'm sorry. Alright, sorry about that, guys. Yes, it is a backslash. I'm not sure why it wasn't letting me do that, but now it is. So I can say something along the lines of if blue oranges is equal to, and then on a new line I can put in the two equals, and then on a new line I can say cheese fried whatever it is, and then put a colon. That would enable me to put all of this on 3 separate lines. So this is the whole concept of using these multi-line statements, right? Now, these multi-line statements can be used anywhere. For example, if I'm creating, like, for example, let me just bring this down over here, actually. So, one sec. Let me get the error going over here. Invalid syntax, fantastic. So, I want to, one sec, I'm sorry about that, guys. So, over here, let's go ahead and get this blue oranges with cheese and this fried dumpling sauce. So, I use a backslash, and it's getting, okay, fine, I got you. So, I delete all of this.
use the backslash, use the double equal to signs, use the backslash, and then I say this cheese fried dumpling with cherry sauce, Command C, Command V. And now what I can do is I can just say print hello, else print hiya. So all I wanted to show you here is how you can use multi-line statements in Python to your advantage. So if your statements are going way off the screen and you don't like that and you want it to be more consolidated, more appealing to the eye, what you can do is you can use these multi-line statements to break up your code into nice, simple pieces like I've done over here. So fantastic, we have talked about some different basics of Python, quotations, multi-line statements, and escape characters. Now, in the next lecture, hopefully we'll get to functions. I'm not completely sure what's set for the next lecture, but I'll see you then. Alright, so we're finally here at functions. Let's get started. First thing first, what are functions? Well, let me give you a quick example of how functions would work. Let's say you had, you were writing a Python script, okay? And what I want you to do is, I wanted you to print hi 5 times. So one way to do this would be for I in range 0,5, 0,5, my bad, print hi, right? And all this would do is it would print out hi 5 times. Now I wanted to print out hi 5 times in the beginning of my code, twice in the middle, and once at the bottom. Now, this would be a tedious process. I'd have to use these statements multiple times. Is there an easier way to do this? Yes, there is. This is where functions come in. What are functions? Functions are chunks of code that tell Python to do something. They basically reuse the code you have written. For example, I could create a function which has this in it, and then I can call that function wherever I want in my whole script to perform printing hi 5 times. So how do you create a function? Well, a function consists of 3 parts. A name, a parameter, and a body. So let me quickly show you how to create a very simple function. Any function you create has to start out with def. And def basically stands for define, or just creating a simple function. After that, you have to type in your function name. As you can see, my function name has been highlighted in blue. That's supposed to happen. So def function name. After that, what you specify is the parameter. So name, parameter, body. Right now we're on the second option, parameter. So the way you can specify parameters is via the normal round brackets. And in here, you can write any parameters that you want. For example, let's say, or actually for this purpose, let's not do anything right now. Def function name, parameters. All right. Once you've specified the parameters you want, and for example, if you didn't have any parameters, all you had to do was just leave this empty and then put a colon. So this is the initialization of a function. Now after this, you write the code. So all I'm going to do is I'm going to Command C this, my for statement, Command C, and Command V. For I in range 0,5, print hi. That's our simple basic function. So now what I can do is anywhere in my code, if I call function name, I get hi. Now is the bracket necessary? Yes, it is. The brackets specify if there are any parameters or not, and it's always good to put the brackets because you have to. So this is a very simple function that you can create in Python. Now let's go ahead and add some parameters. For example, let's say I was creating a very simple calculator. I wanted to take in 2 parameters, first number and second number, and then I wanted to print out the sum of both those numbers. So let's go ahead and do that. Def add num, that's my function name. What are my parameters? First num and second num, okay? And then all I have to do is say return. Now the return key, all it does is it basically prints out whatever you want. So returning a statement just gives it back to you, it prints it out to the console. So I can say return first num plus second num, and I can do this in brackets. I can do whatever I want, but this works. So def add num, first and second are our parameters, and then all we're doing is returning the sum. So hit enter, that works. Let's go ahead and try it out. Excuse me. Add num, and I'm gonna try it out with two simple numbers, 45 and 3. When you have the sum is 48, we get 48. So functions will simplify your life totally. I love functions. I love the whole capability that what you can do is, instead of having to repeatedly use code in your Python scripts in any language you're writing, you can create a function to do that for you. And as you can see, calling a function is a very simple task. All you do is type in the function name and then the parameters. So awesome job, guys. In this lecture, all we did is I gave you a brief introduction to how functions work. Now in the next lecture, we'll talk more about functions and what you can do with them. See you then. So today we're going to be talking about global and local variables. So this is something that all programmers should know, how global variables work, how local variables work, stuff like that. So follow me along. You don't have to type the code that I am, just understand what's happening. Just understand what's happening. So I'm going to create a variable, I'm going to call it total, and I'm going to set this equal to 10, okay? Then what I'm going to do is I'm going to create a new function, def multiply. Okay, takes in two numbers, caps lock, num1, num2, and all I'm going to say here is I want to set total equal to num1 into num2, and then return total. Okay, a very simple multiplication. A multiplication function. And what I want to do now is two things. First of all, I'm going to call multiply on two numbers. Let's call it maybe 10 and 23, so 230 exactly. But now if I print out total, I still get 10. So let's quickly go over what just happened. We initialized a global variable, total, which is equal to 10. Since it's not in a function, it's not in any other statement, this is a global variable. However, the total we initialized in our multiply function is a local variable. So we cannot call this variable, this total variable, outside of our multiply function. If we call it outside, then it's going to give us an error. Don't believe me? Let's go ahead and give it a try. I'm going to change total to 2else and return total. And if I call the multiply function again, get 230, and if I print out total, I get an error. Name total is not defined. The reason for this is because our initialization of the variable total is, well, it's local. It's only in the multiply function. So this is the whole concept of global and local variables. The local variables exist in functions. They only exist at that level. You can call total as many times as you want in a multiply function, but as soon as you try calling it outside of there, it gives us an error that it's not defined. However, if you define the variable outside of your function, you can call it wherever you want, whenever you want. So this is a simple concept of global and local variables that I just wanted to get down. Now in the next lecture, what we'll talk about is some built-in functions that we can use in Python. See you then. Alright, so this lecture and the following 5 or 6 lectures, I'm going to talk about one to two inbuilt functions in Python. So before, what I had done is I had done all the functions at once in one single lecture, and I realized that put a lot of information way too fast. So I've divided this down a little bit more so that it slowly sinks in about which functions we're dealing with. So as you know, we've learned that functions ease up our code, they help us a lot, they help us reuse our code, stuff like that. Python also has some inbuilt functions that we can use. So in this lecture, I'm going to talk about the first 1 or 2, and then for the following 4 or 5 lectures, we'll discuss more and more inbuilt functions. So the first 2 I want to talk about today are the abs function and the bool function. So the abs function, or ABS, if you were in 8th grade or 9th grade, you must have learned about the absolute value. Basically does that. It returns the absolute value of a number. So if you don't know what absolute value is, don't worry. I'll give you a quick explanation what absolute value does.
So if you have a negative number and if you do the absolute value of it, you'll always get positive. So the absolute value of any negative number or any number will always become positive. For example, if I did the absolute value of minus 10, I'll get 10. If I did the absolute value of minus 63, I'll get 63. However, if I did the absolute value of 2, I'll still get 2. So the way we can call the abs function is basically ABS, and then in 2 brackets, the number you want, minus 43, 43. Absolute value of 2 is 2. Basically, what the only thing absolute value does is, if you want to convert a negative number into a positive number instantaneously without having to maybe add or subtract or do whatever you want, absolute value does that pretty fast. So definitely recommend absolute value. It's a nice function to use. Now the second function we're talking about today is going to be the bool function. So we're going alphabetical order. A was for ABS, second is bool. Alright, the name bool is short for boolean like we've talked about, and the bool function, it takes in a single parameter and it either returns true or false based on its value. Okay, so let's go ahead and check it out. For example, if I called bool on the value 0, I'm going to get false. If I called bool on the value 1, I get true. However, if I call bool on anything else, for example 45, I will always get true. I can do bool ASD, I'll always get true. The only time the bool function returns false is when you're using 0. Okay, that's something key to remember, something you want to know. Actually, I correct myself, I'm sorry. The bool function returns false when it's 0 or when you're not passing, or when you're passing none. So none is basically, it's nil, zilch, nothing. When you do bool none, you'll also get false. So if you're writing some code and if you're trying to check what is the value returning, you can make the user return 0 or 1. If you can use the bool function, check if it's returning false or true, and then make your code run from there. Basically, the bool function is just nice to know if the value is false or true, stuff like that. So let's quickly recap what we've learned. It's ABS and bool. Absolute function converts a negative number into positive, and the bool function returns true on everything except for 0 and none. So you can slowly think about where you could use these functions in your code. I mean, if you have some experience with programming, definitely think, where can I use the bool, where can I use the ABS, stuff like that. Alright, so our next 2 functions are actually very, related, okay? And the second function greatly will help you when you're using the first function. So let's get started. The first function we're talking about today is called the dir function. Now what the dir function does, and it's short for directory, is it returns information about the value. So far, for example, lists, we've learned that there's the append function, the delete function, stuff like that. But what if you want to know, hey, what are all the functions, all the commands I can use with an array or a list? Well, what you could do is, for example, I can call dir and then the function on a list. So I can put any value in it, and when calling dir, it gives me every single function and command I can use. So I can use a copy, count, extend, index, insert. Don't worry about this double underscore, add, double underscore. All these is not really important to you. The single words are important. So append, clear, copy, count. All these functions you can use with a list. Now, suppose I created a string called tiger, and I set that to I am a tiger. Now I wanted to find out, hey, what functions can I use with the string? Well, the way I can do that, I call the dir function on tiger. So basically what the dir function does is it takes the data type you're using, string, list, dictionary, whatever it is, and then it'll return you the different functions you can use with that specific data type. So dir tiger, I get, wow, all these different functions, upper, format, is title. Now let's say you wanted to find out, well, what does this upper function do? So we've used the dir function, right? We realized that, hey, there's all these XYZ functions to my string tiger, but how do I use them? I mean, how do they work? Does uppercase the first letter of my sentence? Does it uppercase all the letters of my sentence? How do these functions work? Well, this is where the help function comes in. So this is what I think it's very neat, actually, using the dir and the help. So if I want to find out, hey, what does this upper function do? What I can say is call the help function, help, and then in brackets I can say the following, tiger.upper. So I know the function name, I put it dot, so tiger.upper, and I'm calling the help function, and what does it say? Upper method of built-in.string instance returns a copy of s converted to uppercase. Isn't that cool? So what I can do now is I can find out what each function does. For example, this replace function. Hey, that might be pretty cool for what I'm trying to do. Let's go ahead and find out what it does. Tiger.replace. It says return a copy of s with all occurrences of substring old replaced by new. Isn't that cool? So this help function and the dir function are closely related together. So definitely whenever you're trying to find out what functions I can use with this data type, use the help function too. You can find out what do these specific functions do, and then maybe you can use them in your code. Alright, so hopefully you understood what's going on. Again, if you have any questions whatsoever as I continue along through this course, please leave a comment or discussion and I'll get back to you as soon as I can. Other than that, in the next lecture, we'll move on with our inbuilt functions. Alright, so we're going to discuss two quite similar functions just like last lecture, and both of them are again interrelated. So they both do the same thing except they differ a bit. So the first function today is going to be the eval function. Now the eval function basically, if you haven't guessed already, stands for evaluate. So what you can do with it is evaluate simple Python expressions. For example, if I said eval and then print hello, okay? So I'm evaluating the statement, I get hello. So the parameter of an eval has to be a string. So I could do something like this, eval 23 into 5. So the eval statement can evaluate some simple Python expressions. Again, you can't do multi-line statements with eval. You cannot span multiple lines. However, simple operations, simple print statements, etc. can be done via eval. So they work on simple expressions, and again, I'm not sure where exactly you'd use this in your Python code, but if, for example, if you're getting some input from the user, you tell the user enter a calculation, and then using the eval function, you can return or print out the user the evaluation of that sum or equation the user gave you. So this is the eval function. Again, it's basic. It takes one line and it's simple Python expressions. However, the next function we're going to be talking about is called the exec function. So evaluate and execute. So again, the exec function is quite similar to eval, except you can use it to run more complicated programs. For example, I'm going to create a variable called program, for example, program, and I'm going to set that equal to something along the lines of this. So triple quotation mark. Basically, triple quotation mark means that this is going to span for a few lines. So print hi there, and then print my name is Bob, right? Let's go ahead and end our string or our program. So it gives me syntax error, EOL while scanning string literal. The reason is because I have 3 over here and I have 4 apostrophes over here. That was my bad. Sorry about that, guys. So let me go ahead and make that 3 and run that. There we go. So quickly, let's go ahead and execute this. So if I execute program, now you notice, hi there, my name is Bob. So you can use the exec function to run more complex, more serious code. But for example, if I tried running that using the eval, what happens? It gives me an invalid syntax. So these are the main differences between exec and eval. Both do the same thing. They both run the Python code. However, eval is for simple stuff. For example, simple operations, simple Python expressions. When you get to more complex code, multi-line code, that's where you'd use exec. Alright, so that's it for this lecture, and in the next lecture, we'll continue our inbuilt functions. Alright, so in these following few built-in functions, or at least for this lecture, we're going to be talking about numbers, especially conversion of strings to numbers per se. So in the future, actually, we're going to be talking about a function called input. And all this input function does is, for example, let's say I wanted the user to tell me what your age is. So what I could do is I could say input, enter your age, right? Now this would work, and I'd put in my age as 14, and it would return me 14. Except we want to store the value of input into a variable. So I create a variable called age, and I say input, enter your age. So this would then, I would put in 14, and now if I print out age, it's now 14, which is fantastic. But let's say I now want to use this age for a different purpose. Let's say I want to now see, hey, is this guy eligible for Facebook? So if I say if age is greater than 13, then print eligible for FB, then I get an error, and it says unorderable types string greater than int. So Python is actually quite nice when it comes to errors, and it basically tells you what's wrong. Right now it's saying you cannot compare a string to an int. What we have to do is we have to convert our string right now. As you can see, when we printed out age, it came as a string into an integer. So the function we use here is called the int function. So what I can do is in our age, before running this, convert the age into an integer. So right now our age is a string. It is basically an integer with quotation marks around it. The integer function removes those quotation marks. So now if I run this, eligible for FB. So the int function works on any string which is a number. For example, if I say int 26, I'll get 26. So it basically removes the quotation marks and converts that string number into a regular integer. Now just like the int function works, there's another function called float. Now the float function, what it does is, instead of converting a string into an integer, if you're already ahead of me here, it converts a string into a float. A float is basically a decimal. For example, if I say float 123.456 or 4356, it now gives me 123.4356. So using int and float, we can easily convert strings to integers and decimals. Now what if it's the opposite? I have this fantastic integer, but I need to convert it into a string. Well, if you remember back in our prime number .py file, what we had done is we'd call the string function, and basically all the string function does is it converts a number, an integer, a float into a string. So if I want to convert my age back to a string, all I have to do is say str age, and then I'll get it back as my normal string. So string, int, float, these three functions you can use to convert a data type from string to int to string, string to float, and float to string. Alright, so this is the last lecture in our series of built-in functions in Python. And I just want to cover up a few of the functions we already know to make sure you realize that they are functions, and just a quick recap of what we've covered so far, and then I'll show you one more new function. So the first function in this quick recap of the first 20 or so lectures is the len function. So like we've learned before, is in the len function you can put in any array of some sort, and it'll return you what is the length of that array. Let's try it for a string. If I say len my name, then I'll get 7. So len function is very useful when you want to know, hey, how many characters are in the string, how many objects are in this array, how many items are in this dictionary, and so on. So the len function is quite useful in that case. For example, if I want to create or know how many objects there are in some sort of specific data type, I can use a len function for that. Now after the len function, there is again the max and the min function. So I'm going to again create, or actually in this case, I'm going to create an array, and I'm going to call it, or a list in this case, and I'm going to put in some string values. So A, B, C. So if I call max array on this function or on this array, I get C. So right now, the way this works is lowercase z is the highest value. It's the highest value of the alphabets, and uppercase A is the lowest of all the values in the alphabet. So there's uppercase and lowercase. For example, if I initialize array again with A, B, and C,
A and D. Now, if I say min array, I'll get A. So think of it, capitalized or uppercase letters come first, so A to Z, and then lowercase letters come after that, then A to Z. So lowercase z is the best and uppercase A is the worst. So again, this is a quick example of max and min. We've already discussed how it works with numbers. If you do max array in which in an array which has numbers, it'll return you the maximum number and the minimum number. So there's max and min, there's len. Then after that, you have the range function like we've already talked about. We've seen it in for loops, but you can also talk about that for x or for I in range 0 to 5, 0 to 10, and then you can put the third parameter in range to skip that counter. So last but not least, and this is the last inbuilt function we'll talk about for a good 15 or so lectures, is the sum function. So let's go ahead and let me quickly copy this array, or at least part of this, and I'm gonna say list 1 and then set this as this. So 23, 25, 2, 34, 5, 35. Again, it's just random numbers. Basically, I just want to show you the sum function. So if I say sum list 1, it returns me the sum of all the numbers in a list. So it's quite useful. Instead of having to iterate through the list and then add it to another variable, you can quickly call the sum of list 1 and get the total sum of everything in your list. So that's it for inbuilt functions. I know you're probably thinking, finally, we're done with inbuilt functions, or built-in functions, however you want to say it. But I just wanted to show you all the different functions you can use with Python. So by now you probably have a clear idea of how functions work. How do you do things in Python? You're slowly understanding what a simple and easy language Python is to use, and it's quite versatile. You can get a lot of things done. So we're almost done with the basics of Python, I guess you could say. So we've learned about, we started off with variables, data types, moved on to loops, if statements, else statements. We learned about the basics, how to comment, pass, break, continue. Now we're finally on to functions. We learned how they work. Now the last part in this series will be classes, so object-oriented programming. Again, it's also quite simple. There's nothing too complex about it, but I'll give you a quick introduction on how those things work, and then after that we'll get on to file handling, so opening, closing files, stuff like that. See you then. Right, so we're almost done with the basics of Python. So we've covered everything, almost everything so far, and last topic I want to touch base on is actually object-oriented programming, or classes. So I want to give you a quick introduction on how they work. Alright, we're going to create some very cool and interesting classes. And after 2 or 3 lectures of object-oriented programming, you'll slowly get the hang of how things work with classes. So this is actually the new and updated course. In my previous course, I talked about classes quite little, and I realized that many students had problem understanding how classes work, or how the init function works, stuff like that. So I'm going to read you the definition of class. A user-defined prototype for an object that defines a set of attributes that characterize any object of the class. So basically, a class has a set of attributes that are set for each object of our class. For example, I'm going to create a class, and follow me here, and then I'll explain what's happening. So to create a class, you type in class and then the class name. So class name, and then you can put in whatever you want. I'm just going to put in pass for now. So we've created a very, very simple class. This doesn't do anything. It doesn't have anything in it, but it works. So to create an object of the class, an instance of the class, the way I would do it is by creating the variable name. So this is an instance, and it's part of our class name class. So now instance is an object of this class. So you're probably wondering, why classes? How does it make our life easier? Well, by creating classes, we can easily give attributes, give properties to different objects that are pertaining to the same category. Okay? So, for example, if I created a class of Candy, or maybe a class of students, right? Each student will have a name, an age, and a grade. And instead of trying to initialize those variables, call student1 and then student1 name, student1 age, student1 grade,
I can create a class which has all those properties in it, and it makes life a lot more easier, trust me. So let's go ahead and actually do that. Let's go ahead and create a class called students, okay? Class students. Now, in this class students, there is a function called init, right? Def init. So type with me here, def init, and then the parameters. So what parameters does our instance or our students class take? Well, the first one is going to be self. So it always takes itself as the first parameter. The second one is going to be, name, then age, and then grade, right? So these are the 4 parameters that our students class takes, okay? Now the reason we took self is because we need a way to reference this object. There is no way to call this object unless we say self. So what I can do now is self.name will be equal to name, self.age will be equal to age, and self.grade will be equal to grade. So I know this is quite confusing. You probably have no clue what's going on. Stick with me for a good 2 more minutes and then I'll explain everything that's happening. After this, what we want to do is create an instance of this class. So I'm going to call my student student1. Okay, it's of type students, and his name is Bob. He is 12 years old and he is in 8th grade. I think that makes sense. No, it doesn't. 7th grade. Okay, so student 1, students Bob 12, 7th. So we have now created a class. We have an init function to go with it, and we have initialized an object for our students class. So now what I can do is I can call student1.name, student1.age, and student1.grade. Okay? So let's explain what just happened. We created a class called students, and we put in an init function. So I have had questions on this, that what does this initialize function do? How does it work? Well, whenever you're initializing an object of your class, you want to give it some properties. For example, you have the cars class, okay? You have some fantastic cars, and you're initializing each object of your cars class. For example, Lamborghini. So what properties can you have of a Lamborghini? Maybe the engine, maybe the tires, maybe the color. So you add all those properties using this init function. Now all this init function does is it specifically says, hey, which parameters do you want to make it mandatory while initializing your object? So as you can see, when we initialize our student's object, we have to give a name, an age, and a grade. If I try creating my student 2, and if I say students, and I just give his name, let's say Avi, and if I just give him the age, I don't give him any grade, I get an error. Init missing one required positional argument grade. So what Python is telling me is, hey, the class that you have created requires 3 parameters, name, age, and grade. What you've given me is only 2 parameters, the name and the age. I need the 3rd parameter. So this first line just tells us that we want these 3 parameters. After that, what we're doing is we're setting those 3 parameters to our object. So we're saying our object.name should be equal to whatever name we passed in. Our object.age will be equal to whatever age we passed in, and our object.grade will be equal to whatever grade we passed in. So we have to specify that our object's values, or object.name, object.age, and object.grade have to be equal to, or give it some value. So if I did not put these 3 statements, if I go ahead and initialize this class again, and I delete all these 3 statements, and I just say pass, again, that filler word pass, and now if I initialize my student 1, right, and then that works, and if I now call give me my name, I get an error. Student's object has no attribute name. So once you've set the parameters for your class, you have to add the attributes, okay? You have to say self.name should be equal to whatever we've passed in, self.age should be equal to whatever age you passed in, and so on. So once you pass the parameters, you have to add the attributes. Alright, so this was a very basic introduction to classes. We learned how to initialize a class, we learned how to set attributes for a class. Now in the next lecture what I want to do is I'll show you how to create functions for a class and utilize them and run them. See you then. Alright, so we've learned how classes work, okay? We've understood that you need to put an initialize function if you want to initialize any parameters. We've learned how to call those attributes, and now we're on to adding functions for our class. So I'm going to go ahead and create our students class again, okay? Or don't need for the brackets there. And then I'm going to create our initialize function, and I'm just going to stick with 2 parameters this time, name and age. And then I want to say self.name should be equal to name, self.age should be equal to age. Alright, so this is our very basic students function. We can initialize objects from here, get their name, get their age. Now, wouldn't life be easier if we could use functions? For example, if I created a function called display student, and when I call display student, I can get their name and their age immediately without having to print out student1.name, student1.age. I can do it in one simple function. So bringing this class down, let's go ahead and add that. So our next function is going to be display student. Okay? Now the parameter takes a self because again you need a way to reference it. And over here now what we can do is return, and we're going to return a string. All the string is going to say is student name is, and then go ahead and add self.name, and then or actually in quotation marks over here, and age is, and then go ahead and convert this into a string, self.age. So let's quickly go over what we did. We created a function, display student, took the parameter self, and all we're doing is returning student name is, and then returning the student's name, and then its age is string of self.age. The reason we're using string is because our age is going to be an integer, and we have to convert it into a string. That looks good. Let's go ahead and initialize the student. So for simplicity, I'm just going to call my stu. I'm not going to write student1 and all that because that takes a little too long time, and I don't like spending so much time. As they say, the best programmers are those who are lazy, and I can definitely tell you I am a very, very lazy person. So stu is equal to students. His name is going to be Chad, and his age is going to be 15. So stu looks fantastic. And now what I can do is I can call stu.display students. So it gives me students object has no attribute display students, and that's because I put that extra s. I'm sorry, it's actually display student. If I hit enter, I get student name is Chad and age is 15. Isn't that cool? So what you can do now is after we've added the attributes to our object, initializing over here, I can use those attributes in different functions. So display student worked fantastic. If I have student 1 to 10 and I want the basic data of what's his name and what's his age, I can say student1.display student, student2.display student, and so on. And all that would do is it would return the name and the age. So again, that's pretty cool. I mean, this was a basic introduction on how we can use functions in our classes, how they work, and how we can call our attributes that we've created to put those values in strings and stuff. So in the next lecture, we're going to be talking about some attributes again, and we'll learn how to add, modify, delete, and set. Okay? Add, modify, delete, and there's one more. I'm not sure it's set, but there's one more function I'm missing here. We'll learn how to do those with attributes. See you then. Alright, so today we're going to be talking about attributes in classes, mainly 4 functions that will help us understand or getting values of attributes and updating them in our classes. So let's get started. First thing first, what I want to do is create my students class. As you can see, I no longer have it. So class students def init, and then pass in self, name, age. Go ahead and set the attributes. Self.name is equal to name. Oops. Name self.age is equal to age. So that's our init function. I'm not going to put any other function after that because I just want to show you some quick simple functions we can use with attributes, and functions don't really have to do with anything there. Now I'm going to initialize student1. I'm going to set that equal to students, and then let's go ahead and give it a name. I'm going to do what's a good name? Fred. Fred's a fantastic name. So Fred, and age, let's do 17. Okay. So this is our student1, and let's go ahead and make one more. Student2, just for the fun of it. I mean, you don't really have to, but for the purpose of this lecture, it's fine. So Fred and Mike, and his age is 12. So we have student1 and student2, and the four functions I want to talk about today is, well, the first function at least is called has attribute or has attr. And all this function does is if it checks to see does this attribute exist or not. For example, if I call the has attribute function on my student1 and I say, hey, does my student1 have the attribute age? Then it returns true. I can then check for my, so let's go ahead and check for grade. Does student1 have a property called grade? So if we do call this function, it gives us false. So you can use this has attribute function to find out what attributes do your students have. And you're probably wondering, well, that's sort of pointless, right? Because we already know, since we have initialized the class with these main parameters, there's nothing else you can initialize it with. However, you're wrong there, because what you can do is you can set specific attributes for specific objects. For example, let's say for Fred example, student1, Fred, let's say we also had to specify which grade he's in. So how do we do that? Right now, bringing student1 down here, if I try adding a grade value, it's going to give me an error. It'll say, hey, init takes 3 positional arguments but 4 were given. We don't have any argument for grade. So how do I add an attribute to my first object, grade? Or how do I add grade to my first object? Well, this is where our second function comes in. It's called set attribute, S-E-T-A-T-T-R. And all the set attribute does is it'll set an attribute to our class. So I can do is I can say set attribute student1, and then I can say age, or for this class, grade, whatever you want to say, grade, and then it takes in the third argument, hey, what do you want to set it? So we're going to set it as 8th. Hopefully this works. Yes, it does. So now if I say has attribute student1 grade, bring this down over here, whoops, it gives me true. Isn't that cool? So let's quickly recap what we just did. Has attribute checks to see does this object have a specific attribute. Set attribute, on the other hand, can give or set specific attributes to your students. For example, if you have a list of employees, right? For some of them you're giving vacations, for some of them you're not. So instead of having to add the property vacations to your init function up top, and then for those who don't have vacations putting 0 every single time, for those few that actually have vacations, what you can do is set those attributes by calling this function. So again, set attribute is quite interesting. When you have specific or special objects that have those extra attributes, you can set them by using this. Now, let's say you wanted to return the value. So just like set and has, there's also a function called get. So all get attribute does, and it's just like what we've talked about before, is I can get any attribute I want by calling this function. So do I want to get the grade of student1? I'll call get attribute student1 comma grade. I'll get 8th. If I want to get the age of student2, then I'll do student2 and age. So this get attribute, I guess it's the exact same thing as calling student2.age, but I mean, it's just a different function to do it. You can do it both ways, doesn't really matter. Now, the last function I want to talk about is called the delete attribute. So just like there's setting, there's has, there's get, there is delete. So what if we're talking about grades here and you're like, oh, I don't need to add his grade anymore. How do we delete student1's grade? Well, if you're a step ahead of me, it's going to be delete attribute and then student1 comma grade. So now if I try saying student1, or let's call the has attribute now to see if it still has it, we'll get false. So these are the four main functions that you use with attributes: set, has, get, delete. All of them are very important, and you can just go ahead and play around with them. Again, we won't be using too much of these functions. I just wanted to show you, hey, these are what you can do with classes, this is what you can do with attributes, and so on. If you have any questions on how these functions work, or how are you setting these values, what is this init, stuff like that, please leave a discussion and I'll get back to you as soon as I can. Now, in the next lecture, we'll again continue our sort of small tutorial with classes, and we'll just talk a little bit more about them. We'll slowly get to inheritance, parent class, child class, stuff like that. See you in the next lecture. Alright, so today we're going to be talking about inheritance, and the whole concept of inheritance, is that you have a child class and you have a parent class, and all the attributes in the parent class, the child class inherits, and then the child class can use them as if they were defined in the child class. So it's not as confusing as I said it to be, but it's actually quite interesting. So I'm going to go ahead and create a parent class, so just call it parent for now. And I'm going to have an initialize function where I don't do anything, just pass in self and just say print class initialized. Okay, and then over here I'm going to create a function, just a simple function. I'm just going to say parent func and pass in self again, and then what I want to do is I want to print out parent func being called. And now I'm going to create a function called, so actually before this, let me create a variable up top. So I'll show you what I'm doing, but stick with me here. So I'm going to create a variable called, let's say, counter for now, and I'm going to set this equal to 10. So in this new function, let's call it def set counter. Okay, in my def set counter, I'm passing in two parameters, self and counter. All I want to do is say parent dot counter should now be equal to, or counter should now be equal to, let me change this actually. So our set counter function, two parameters, self and the new number, whichever the new counter is. So I'm going to call this num, and we want to update our counter variable to become the new num that we've passed in. So def set counter self comma num, our counter variable will now be equal to num. So it might be a little bit confusing what I'm doing, but as soon as we create a child class, I'll show you why I'm doing it. Now, one last thing, let's go ahead and create our print counter, I guess. So def show counter. And all we want to do here is we pass in self, and alright, and in here we just want to print out our counter. So I'm just going to say print parent dot counter. Okay, something quite simple, and let's go ahead and convert this into a string, otherwise it'll give us an error. Okay, so this is our parent class, and now I'm going to create a child class. All this child class is going to have is two very simple statements, def init self, and all this will call is, it's going to say print child class being initialized. And last but not least, for our second function over here, I'm going to create a function called child method, okay, or child func. And all this is going to do is again take in self and just print out child func being called. So we've created two classes, okay, and I'm really sorry that it took so long. I guess I got a bit boring in the middle of that, but we've now finally created two classes, one parent and one child. So as you can see, I made one small mistake, and that is that I haven't made child class a child of parent. So what I can do over here is class child and then in brackets parent. And all that says is, hey, this class is now a child class of our parent class. So we probably shouldn't have named our class child because it becomes confusing when I'm talking about it. But basically, by putting our parent class over here, we're saying that this class is now a child of our parent class. So let's go ahead and create an instance of our child class. I'm gonna call mine C, I guess. So C is equal to child, and child class being initialized. Awesome. Now let's take a look at the functions we can call. So if I say c.childfunc, what happens? Child attribute has no, okay, that's because I spelled it with an H, my bad. So childfunc being called, there we go. And now the cool thing with child classes is that we can call any function we want of our parent class. So let's go ahead and call the parent func, for example, c.parentfunc. What happens? Parent func being called. So what we can do is, using our child class, we can get any attribute, any function from our parent class and use it in our function. For example, if I call c.counter, I get 10, because what we're doing is we're calling any variable, any function that exists in our parent class in our child class. Now let's go ahead and call our setCounter function. So c.setCounter, and it takes in one attribute and it says, hey, what's the new counter you want to set? Let's set it as 20. And now what I can do is, if I say c dot, what was our show counter, I believe? Yes, show counter, I get 20. So what we've done is we have modified the values in our child class or in our parent class via our child class. So we called the setCounter function in our parent class, changed the counter to 20, and then called our showCounter function to print out the new counter. So this is the whole, or a very basic example of child and parent class, where the child class inherits the attributes, it inherits the functions of the parent class, and then what you can do is call these functions, call these variables wherever you want in your child class. So very interesting, I guess. Play around with it. You can go ahead, create multiple child classes, multiple subclasses of a main class. For example, if you want your child class to be a child of parent and parent2, you can do that by just putting a comma over here. Anyways, I'm not going to go into too much detail about inheritance. This is just a very brief introduction on how things work. Now, in the next lecture, I want to show you one last thing, which is overriding methods. So right now, we've learned that you can call functions, call attributes of your parent class, but what if you have two of the same functions, one in child, one in parent? How do we make it so that the child function does something different? Alright, that's it for this lecture, and I hope to see you in the next lecture. Bye. Alright, so I guess I'll see you in the next lecture. Alright, so hopefully this is going to be the last lecture in our series of object-oriented programming. And by now you should have gotten a pretty good sense of how classes work, how child classes work, how functions and attributes of classes work, stuff like that. So now, lastly, I just want to talk about overriding methods. So I'm going to create, again, a class parent. And over here, I'm not going to put in any initialize function. I just want to call, I'm going to create a function called this is a function, or actually something simple. So I'm going to call this deffunc, and it's going to take in the parameter called self. Okay, and I just want to say print this is a parent function. Okay, very simple class, very simple function. Now I'm going to do the exact same thing with a child class. So instead of typing it all over again, I'm going to go to this line, hit enter, and then I'm going to change this to child, make it a subclass of parent, and then change this to this is a child function. Alright, so now what I'm going to do is I'm going to create a new instance of my child class, and now if I call my func, what do you think will happen? Will it print this is a child function or this is a parent function? Don't hit enter yet, just think about it. I'm going to give you a few seconds. Just think about what will happen if we hit enter right now. Alright, so we're probably wondering, well, why is this printing a child and why not parent? And the reason for this is the whole concept of overriding methods. You can always override your parent class methods. This is something that is set in Python, set in almost all classes, where if I create a same function as in my parent class, I can always override what it does. The whole concept of override means whatever was there will be removed and the new code will be run. So the reason for overriding might be that you want special or different functionality in your subclass, and that's exactly what we have done. Alright, so fantastic job. We have now covered some fantastic topics in Python. We started off with the basics, data types, variables. We then moved on to if and else statements. We learned about commenting, loops, functions, inbuilt functions in Python, and we finally ended with object-oriented programming. Awesome job, guys. So if you've had any questions throughout these first 30 or so lectures where you've been wondering, hey, what's this, what's that, how do classes work, why object-oriented programming, please don't hesitate to leave a discussion, leave a comment in the forums, and I'll get back to you pretty soon, hopefully, and I hope to see you in the next lecture. Alright, so this whole section is going to be about files, so manipulating files, adding data to files, reading off files, and so on. So I just want to touch base on the subject, and again, it won't take too long, hopefully max 5 or 6 lectures, and we'll just cover how you can use Python to manipulate such files. So the first thing we need to do before we even talk about all this Python stuff with files is we have to create a file. So most of you should know how to create a file, and if you do, just skip ahead, go ahead and create a very simple text file, and make sure you know what the file name is, and then you can just go ahead and see the next lecture. Otherwise, just stick with me and we'll create a very simple file. So if you're on a Mac, you need to open TextEdit. As you can see, I have TextEdit opened up right now. So what you can do is you can hit Command Tab on your keyboard and search for TextEdit, and then all you have to do is open it up, and it will open it up like this. Now if you're in a Windows machine, what you have to do is, well, on the left hand side of the screen, if you're using Windows 7, you're going to click the Windows icon and search for Notepad. Or if you're on Windows 8, you're going to say Command S, okay? Or it's not Command, I'm sorry. Windows key plus S, and what that will do is it'll open up the search bar on the right hand side. And that's where you can search for Notepad or whatever text editor you're using. And once you open it up, the procedure for creating the file will actually be quite similar. So I again am on my TextEdit, and over here, this is looking fantastic. So just go ahead and enter a few lines of text, anything you want. So this is a Python file. Okay. What else can you say? Python is a fantastic language. Fantastic language. And let's do one more sentence. Let's say anything you want. So Mac OS is a fantastic OS. Maybe if you're a Windows fan, you can do Windows. However, these are 3 lines that we've written in our file. I'm going to go ahead and save this. So Command S, if you're on a Windows, then it's File, Save As, or Control S. And it's going to ask me, hey, what do I want to save it as? So Windows people should be doing the exact same thing as I am. Save as, and then I'm going to save it as test file. And I'm saving it in my documents, and instead of file format, instead of rich text document, I want to save it as .txt. So right now, as you can see, I don't have the option as .txt. So the way we can change it into .txt is make plain text. Okay. So if you're on a Mac right now, please make sure you do this. Go to Format, Make Plain Text, and now we can save this as a text file. So as you can see, it's now Unicode UTF-8. Test file, and I'm saving it in my documents. For Windows, again, you'll do Control S, File, Save As, and then go ahead, give it a name of test file, and make sure the extension is .txt, and then save it. Fantastic. So now you've created your text file, and in the next lecture, we'll go ahead and learn about reading off files. Alright, so we've now created our text file, and now for this lecture, we're going to learn how to read off that text file. So we're going to be covering quite a few functions actually that you can use with files today. The first function is going to be the open function. So whenever you're creating a file, or at least getting it into Python, the way it works is you type in a variable name for that file. For example, I can call this file1. Then you put an equal sign and then use the open function to get that file opened. Excuse me. Now, the open function takes in 2 parameters. The first parameter is a file name. So we called our file testfile.txt, and then we have to put in an access method. So the second parameter of the open function basically says, hey, how do you want to open this file? Do you want to read off it? Do you want to write off it? Do you want to do both? Do you want to append off it? Etc, etc. So there's, I believe, 15 or 16 access methods. I'm not sure the total number, but we won't cover them all. We'll cover the main ones. So for the purpose of this lecture, since we are just reading off the file, go ahead and put an R. And all this R signifies is that, hey, we're not going to append to this file. We're not going to read off this file. All we're going to do, we're not going to append. We're not going to write. All we're going to do is read. So if this gave you an error, for example, you hit file1 is equal to open testfile.txt, R. If this gave you an error, message me in the forums and I'll tell you how. I don't want to deviate from the course right now since, well, it would be confusing to a lot of people. However, if you did get an error for this small piece of code, definitely put a question in the forums and I'll get back to you almost instantaneously. Again, it's a quick fix, but I don't want to deviate too much from what I'm trying to get to right now. Alright, cool. So this worked for you, fantastic. Now what I want to do is, well, I want to first of all read off this file. So if you open the file, file1 looks fantastic. How do we read off this file? Well, it's file1.read. Very simple. So look at that. This is a Python file. Python is a fantastic language. Mac OS is a fantastic OS. I missed an A over there. I'm sorry about that, but that's fine. So this is pretty cool, right? We read off the file. We got our text. Now, just for fun, I want you to read off this file again. What happens? You only got a quotation mark. Well, this is where things get interesting. Think about why this happened. Why did we get a quotation mark? Well, the best way to explain this to you would be in terms of a cursor. Think about when you're reading a file, your cursor starts at the beginning. As you go through each word, your cursor moves slowly across each word, right? For example, if this was a file, this simple line was a file, I started from the beginning, I slowly read through the whole file. At the end, when I read off everything I needed from my file, my cursor is now at the end of the file. Now when I try reading the file again, hey, where's my cursor? It's at the end of the file. There's nothing else to read. So this is where a slight problem can encounter. You may think, hey, why isn't it reading? Well, the real issue here is our cursor currently is at the end of the file. What we have to do is get this cursor to the beginning of the file. So if you're wondering, well, I don't believe you, how is that true? What I want you to do is go ahead and type in this function, file1.tell. Tell. So all this tell function does is, it asks Python, hey Python, tell me where am I in this file? Well, Python told us that you're at the 84th character. Now, I'm not going to count all these characters, but I can definitely tell you that the 84th character is either the N or the character after N. So right now, our cursor is at the end of the file, and our goal is to bring it back to the front so that we can read it. The way to do that is, well, create a variable called position. Position is equal to file.seek 0, 0. Alright. Looks like I forgot our file name was file1 and not file. So position is equal to file1.seek. Okay. Now I'm not even sure you had to assign it to a variable. Let's go ahead and try it out like this. Or actually, so file1.read, if you call this function again, you're now going to get the whole file. All I want to do here is I want to set this back to the beginning, just saying this 0, 0. So we get 0. And now if we say file1.read, yay, cool. So I was mistaken. You didn't have to set file1.seek's value to a position. I'm sorry if I went a little bit off track over there. That was just me testing a few things out. So let's quickly recap what just happened. Right now we had position is equal to file1.seek. You know what? Just forget this. You don't have to assign this to a variable. All you have to do is say file1.seek 0, 0. And all this means is I want you to move the cursor back to the beginning of the file, okay? And once that's done, we can now read it again. If we say file1.read, this is a Python file, blah, 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 blah. So as you can see now, we can now read the file.
So I'm setting this back to the beginning. And there's one last thing I want to show you, and this is that, let's say I just wanted, this is a Python file. I didn't care about what's after it. I only wanted the first 20 or so characters. Well, let's go ahead and try it out. So what you can do here is you can say file1.read and then in brackets the number of characters you want. So I know that this is a Python file is 21 characters. So if I hit enter, I get this is a Python file. But now, let's say I call this function again, file1.read21. What do you think happens? Well, it starts from the period. So this is very interesting. Wherever you let go from your cursor, if you read the first 10 characters, the next time you read anything, it'll start after the 10th character. That's something key. You must realize that whenever you're reading off files, remember where your cursor is so that you're not getting any gibberish or random text. Awesome. So let's do a quick recap of what we covered. In the beginning, we learned about the open function. We realized that you need to put in the file name and you have to put in an access mode. After that, the file1.read function gives us the entire text in our file. Now, what we realized is the cursor starts at the beginning and goes to the end. And then the cursor remains at the end, causing the next time we call file1.read to give us a quotation mark. We realized that again, or actually verified that by calling the function tell, which told us where our cursor is in the file. We got 84. So to reset the cursor back to the beginning, we call the function file1.seek 0, 0. And all this did is it reset our, It reset our cursor back to the beginning. Then we can we read the file again, we got the data, we set it back to 0, and then I also told you, hey, if you want the first 10, the first 21 characters, you can specify the number of characters in your read function. So by doing that, we got this is a Python file and nothing else. And then I also told you that once you read those first 21 characters, the cursor is now at the 22nd character, or yes, the 22nd character. So it'll start from there the next time you call the read function. Awesome. So this lecture we covered everything there is to reading off files. Now in the next lecture, let's learn how to write to files. See you then. Right, so last lecture we covered about reading. We learned how to read off files, and now what I want to talk about is writing to files. So again, it's going to be quite similar. Just like there was a read function, we're going to use a write function, but the access mode will be a little bit different. So, excuse me, let's go ahead and open up this file. I'm going to call my name file or F, it doesn't really matter, and go ahead and use the open function. Put in our file name, testfile.txt, and then it's going to ask us, hey, how do you want to open it? So this is where we can now decide how do you want to open it. So W, if you put the access mode as W, it only opens the file for writing, and that's something that we can definitely do. So let's go ahead and put in W. So test file W, and that works. So now let's go ahead and just do read and see what happens. So it gives me the operation not readable, and that's because we have just now used W, and W will not allow us to read off the file. That makes sense, I guess. So now using the write function, I'm going to go ahead and enter some text. I have entered some text into this file. Let's see if this works. Okay, 65, fantastic. Now, to see if our file has actually written, okay, what we can do is close the file. So f.close will close the file, and then we can reopen it using our, using our R access mode. So test file and R. Oh, I'm sorry, I forgot the .txt. My bad. So test file.txt and R. There we go. And now if I say f.read, I've entered some text in this file. Let's see if this works. Awesome. So let's quickly recap what just happened. We opened our file using the W access mode, and then we wrote to the file using the f.write command. Now it wrote to the file and then it returned how many characters long this sentence was, or where the position is now in the file. Then we closed the file and reopened it using the R access mode, enabling us to read off the file.
Now there are different modes which can do both. For example, WB plus opens a file for both writing and reading. So instead of using W, you could have done WB plus, but you can play around with it. Definitely search online for all the different access modes. There are tons and tons. Trust me when I say that. So this is it for writing. Again, it was a short lecture. Just wanted to show you how to write to files. And then in the next lecture, I'll show you how to append. So one key thing here, actually, before I end the lecture, writing will rewrite the file, okay? Whenever you use the W access mode, if the file already exists, the file will be rewritten. So as you remember, we had those random lines of code, Mac OS is a fantastic OS, stuff like that. Those lines were rewritten, and now what exists in that file is just this. So W is not good if you want to continuously append to a file and add more and more text. If you want to completely rewrite the file, you use W. If you want to append, if you want to add more to the file, you're going to use A. And we'll talk about A in the next lecture. Alright, so today we're going to be talking about appending to a file. So we've talked about reading, we've talked about writing, and we're almost done with this whole file concept. So appending to a file, basically all it does is, suppose we have XYZ already written into the file. Appending to a file won't delete that XYZ. Instead, we'll be able to add more to that XYZ. We can make it XYZ ABC. So let's go ahead and open up our text file again. I'm going to call my file again F. And F is going to be equal to open testfile.txt, comma, A. And all A will enable me to do is it will allow me to append to this file instead of rewriting. So now if I say f.write, and then I want to add to my file on a new line, this is my appending text to my test file, okay? So I now do f.write, and now I believe that my file has been appended with this new data. So to check, what I can do is I can now close my file. F.close will completely end anything that's going on with this file. And I'll reinitialize my file with my R. So F is equal to open testfile.txt R. And then F.read. I've entered some text into this file. Let's see if this works. This is my appending text to my test file. Awesome. So as you can see, the appendation has now worked. To append, all you have to do is set the access method to an A instead of an R or a W. Now again, there's features like A+, one sec, let me take a look at my reference over here. There's A+, AB+, AB, stuff like that. Definitely take a look. Again, I'll tell you a few actually over here. So A+ opens a file for both appending and reading. So what we could have done here is, let's bring this back down, or actually, let's go ahead and close this and then open this up again. But instead of A doing A+, let's see what happens. So I'm going to go ahead and write again some more text. This is some gibberish. Okay. And then if I say f.read, alright, so that's because my cursor right now is at the end. So let's do ahead and say f.seek 0, 0, and then f.read. Ta-da! So as you can see, using different access methods, we can specify or make our life a lot more easier. Using A+ enabled us to append and read both at the same time. A just allowed us to append. The same way, if you want to write and read both at the same time, I believe we can use WB+ or WB. So these are the different access methods you can use, and again, we're almost done with this whole file section. Now, last but not least, let's go ahead and learn about copying one file to another file, okay? See you in the next lecture. Alright, so today we're going to learn how to copy files, and this is not some function Python has created. This is actually going to be a program that we're going to create in which we take in a user's file name, for example, and then all we do is we open it up, get the data from their file name, and then write it on to a new file. So the concept is actually quite cool, and let's get started. The first thing we need is the user's file name. So I'm going to call this UFN or UFN, user's file name. And that's going to be equal to an input. And all we're going to say is, bro, enter your file name. Okay? So once we do that, hit enter. So what's our file name? Well, for this purpose, let's go ahead and use test file. So now that we've done this, UFN is now equal to test file. So what we have to do now is create file1, set this equal to open UFN, read, or actually R. What does it do? It gives an error. No such file or directory, test file found. So as you can see, this is our first error we've run into. We have to add that .txt to our UFN. So what we can say is UFN is now equal to UFN plus .txt. Okay, now let's go ahead and run this file again. File1 is equal to open UFN, R. There we go. Now let's go ahead and create file2. File2 is going to be the new file which will hold all the data of file1. So file1 is equal to open. Now we haven't created any file, so if you remember that I've talked about, if you don't have a file that's been created, Python will create one for you using the name given. So I'm going to call this copied file.txt, w. Okay? So now what I have to do is, well, think about the codes that are going to come next. We want to read off file1 and set all the data of file1 to file2. I'm going to pause this video here and give you a few seconds to try it out. Alright, hopefully you managed it. If you didn't, don't worry. So the code you want to write here is file2.write should be file1.read. Okay? So basically all we're saying is all the data in file1 should be written to file2. Okay? So as you can see, all the data in file1 has been written to file2. Now I'm going to go ahead and say close file1, file2.close because we don't need them anymore. And now I'm going to reopen our file2, except instead of W, I'm now going to say R. So file2 is equal to open, copied file.txt, R. And now if we go ahead and read off this file, well, if you're a step ahead of me, ta-da! We have now gotten all the text from the file name the user entered into a completely new file. So in this lecture, we learned how to copy files from, if a user gives you text, if a user gives you a string which contains the file name, what we did is we got all the data from that file name and then recreated a new file and set the data to that file. So again, a very cool program. If you want to save this and keep this for future references, what you can do is go ahead and say file, new file, and then in this new file, type in the whole code and save it. Again, I'm not going to do that right now. Probably in the future when we get to more complex programming, I'll start using the file. But for now, fantastic job. Again, if you've had any questions throughout this whole file IO, how does the read work, write work, what does a seek mean, tell mean, stuff like that, any doubts whatsoever, definitely leave a comment or question and I'll get back to you as soon as I can. Now, in the next lecture or in the next section, we're going to cover some modules in Python. So we learned about OS this section, and in the next section, we'll cover quite a few different modules such as the random module, OS module, and so on that will greatly benefit us in the future whenever we're doing Python programming. See you then. Alright, so in the last section we talked about files, right? Reading files, creating a file, how to write to files, append, etc. And we basically got a very good understanding of how files work. Now this whole section is going to be about modules. Now we discussed modules quite briefly in our file section when we were talking about the OS module. But this whole section will now talk about many different modules that are in Python right now. So again, what are modules? Well, modules are libraries that hold functions. And what we can do is we can call those functions in our program. It's much easier to import modules and use their functions rather than creating our own functions, which will take up a lot of time, a lot of space, and a lot of code. So modules, right? The first module I want to discuss is the random module. So again, just like last time, you have to always use the import statement to get that module inside of your program. Now import random imports the random module. Now what do we want? Well, let's talk about the different functions there are in the random module. Alright, so the first function I want to talk about is the randint function. Okay, so in every programming language that I've dealt with so far, at least the main ones, they always have some sort of random module in which you can generate a random number. For example, in Swift, it's arg4random. In Python, it's randint. So the way this works is, for example, what I can do is I can say print, and then in the print I say random.randint, and all this says is, hey, I want to generate a random number between x and y. So right now it says you haven't specified anything, so let's go ahead and add the range. Where do we want a random number from? So let's do 0 to 100. Okay, and we get 79. Let's go ahead and do this again. What do we get? 91, again 87, and it goes on. So what does this random.randint function do? It generates a random number, any random number between your initial value and your end value. So this was a very basic lecture on how the random.randint function works. And in the next lecture, using this knowledge and using our knowledge with if-else statements, we're going to create a very simple guessing game. See you then. Alright, so in the last lecture we talked about the randint. We realized that if we call the function random.randint and putting the initial and final value, we can generate a random number. So that's pretty cool, right? Now, the next thing we're going to talk about is a very simple guessing game. And to do this, I'm going to create a file, okay? Or file and, no, sorry, one sec. I have to select ideally first, file, new file. And I'm going to be doing the majority of my coding in this file. And the reason for that is, well, it's a little bit difficult to write big program statements inside of the IDLE, because if you make a mistake and hit enter, it gives you an error, then you have to, go back to that line, hit enter, get that code back, and then reformat it. So instead of doing all of that, all I'm going to do is put all my code into this file. Okay, so we're thinking of a guessing game, right? And how is this guessing game supposed to work? Well, what I think is that the computer will guess a number, and we then are gonna, enter a number. If that number is lower than the computer's guess number, the computer prints out guess higher. And if the number is higher than the guess number, then the computer prints out guess lower. And if it's equal to the guess number, then the computer prints out you're correct. So again, a very simple guessing game. And think of it as a small challenge. I mean, we've learned about the random module, we've learned about the if-else statements. So using this knowledge, I'm going to pause this video here, and I'm going to give you a few minutes to try and figure out if you can create this program. So here I go, I pause the video. Alright, so if you did create your guessing game, that's fantastic. I mean, I'm definitely proud of you. If you haven't and if you're still wondering how to do it, don't worry, I'm there for you. So the first thing we want to do is let's talk about what's needed. So we're using the random.randint statement, right? So to do that, we need to import our random module. That's the first thing. Now the second thing is we need a variable to hold the computer's guess initially. So I'm going to create a variable called compGuess or comGuess. I'm going to set that equal to random.randint, and then let's say we're guessing between 0 to 100. Okay, there we go. So the computer has now guessed the number. What instructions should be given to the user? I'm going to say user guess is equal to one sec, let me think about this. So user guess is equal to input, enter guess a number between 0 to 100. Okay? So I think what we should do is we're gonna put all of this in a while loop. Or not really a while loop. Let's take a look. Yeah, you know what? Let's do a while loop. So the way this is gonna work is the while loop will run every single time until the user guesses the correct number. So while true, and again, the true statement basically makes it run forever, and the way we'll break out of this while loop is by using the break statement. Okay? So while true, we're saying user guess is equal to input guess a number between 0 to 100. So this is our main input statement. Okay? Now we want to say if user guess, and actually, you know what? We actually have to add the spaces over here. Remember the 4 indentations of Python? So user guess is equal to input. If user guess is greater than com guess, okay? So if the user guessed higher than the computer's guess, we're gonna tell him, hey, you got to print guess lower. Okay? Now, what if the user guessed lower than computer guess? So elif user guess less than computer guess. What then? Then we're gonna say print guess higher. Okay? And last but not least, else. So if it's not higher, if it's not lower, then that means what? You got to well, it's a correct answer then, right? So if the guess is not higher than the computer guess, if it's not lower than the computer guess, then we know the user has guessed the computer guess, right? So else print, congrats, you have guessed the correct number. And then all we have to do is break out. So break. Alright. So this is our very simple guessing game. So I'm going to go ahead and save this. If you are on a Mac, Command S. If you're on a Windows machine, Control S. So save as, and I'm going to save this as my guessing game Python. So go ahead and save. Alright, and I'm going to go ahead and run this. So what happens? Nothing actually, that's odd. So let's go ahead, get this back. Run module. Alright, there we go. So guess a number between 0 to 100. I'm gonna guess 50. Unorderable type string is greater than it. Alright, so this is our first error, something I should have known about, but I didn't, so that was my mistake. Our first error is that when we're checking if user guess is greater than com guess, remember, when we use the input statement, it'll always take in a string. It won't take in an integer, it'll always take a string. So what we have to do is we have to convert this, or actually, instead, we have to convert our input into an integer. So if you remember back 30 or so lectures ago, we were talking about the int and the str functions. The int function converts our string, which is a number, into a normal integer. The string function, on the other hand, converts any integer into a string. So by converting our input into an integer, we won't get this error anymore. So run, again, it's just F5, so let's just go ahead and hit F5. It says source must be safe, okay? Guess a number between 0 to 100, I say 50. So it says guess higher, okay? I'm gonna say 75 or 76. It says guess lower, so 60 maybe. Guess a number, guess higher, so 65. Higher, 67. Higher, 70. Higher, 73. Lower, so it's between 70 and 73. 71. Yay, we guessed the correct number. Awesome. So this is a very basic guessing game we created through Python, and this is a lot of fun. So if you were able to create this guessing game by yourself, fantastic job. I mean, that's truly amazing. Otherwise, hopefully you had fun creating this very simple guessing game. Now, I have a quick challenge for you, okay? Actually, even before the challenge, let's quickly talk about one thing you might fix in this guessing game. Currently, right now, let me just go ahead and run this again. So getting this back and F5. If I say 150, for example, it allows the guess. If I say negative 2000, it allows the guess. So one thing you might want to consider while creating this application is that limit the user's guesses to between 0 to 100. For example, if I guess 150, I should see a message saying, hey, you need to guess between 0 to 100. And if I guess minus 2000, then I should again see a message saying you need to guess between 0 to 100. But that's something you can work on later. Again, that was just one piece of advice I could have given. Now comes the challenge. So I always like giving out challenges to my students. I've done that in my Apple Watch course. I'm doing that in this course. And the challenge for today, or at least for this section, is that I want you to create a computer-based guessing game. And the way this will work is you will guess the number, or I'm sorry, no, wait. Yes. So you will have a number in mind, okay? You will have a number in mind, you'll store it in your memory, and then the computer will guess the number, okay? And the way this will work is, for example, the computer will initially print out, let's say 50. And then you'll either say higher or lower, and then based on that, the computer will either guess higher or lower. For example, if I guess the number 60, my initial guess of the computer was 50, I printed out higher, the computer realized, hey, I now need to search from 100 to 50. So suppose he searches 75. Then we say lower. And now the computer realizes I need to search from 50 to 75. So it continuously decreases the range it's searching through. Again, this might be a little bit over your head. I will be adding the code for this computer guessing game in the next lecture. But if you understood what I'm trying to say, definitely try it out and compare your code to mine. See you in the next lecture. Alright, so in the last lecture we talked about creating a very cool guessing game, and we did that. And I thought it was pretty fun, and we definitely learned a lot. And if you were able to get that computer guessing game that I was talking about where you thought of a number and the computer guessed it, awesome. You may have verified your code with my code, and if you got the same results, fantastic. Now we're not gonna move on to a different module. Actually, we're gonna stay with random module for another lecture or two. And I want to talk about some other functions that are there with the random module. So for this, we won't need to create a new file. There'll just be simple functions. So go ahead and import random into your IDLE or into your shell. And the first function I want to talk about is called a choice function. Okay? Random.choice. And the way this works is, for example, the random.randint picked a random number out of a set of numbers from 0 to 100, 100 to 150, whatever. The random.choice picks a random object from a list. So again, concept is very cool. Let's go ahead and check it out. So I'm going to go ahead and create a list. Actually, I'm going to call this, let's say, food. And in my food array, I'm going to put in some good stuff. Ravioli, I had that yesterday. I had pasta, pizza, and let's do one more. Let's go ahead with cheesecake. Again, random stuff. You can do whatever you want. I believe there's an E there. Cheesecake. So now using the random.choice function, what we can do is, let's say we need to generate a random object. We didn't want to get the first object all the time, but we wanted a random item from this list every single time. How would that work? Well, we'd use the random.choice. So what we can say is print random.choice, and then in brackets food. So basically the choice function takes in one parameter, which is the list. If we do that, we get cheesecake. Let's go ahead and do this one or two more times. Cheesecake again, and ravioli. Awesome. So the choice function can be used to generate random items from a list, which again is very useful. Now to finish off our random module, we're going to talk about one last function, and that is the shuffle function. So the random.choice gave us a random item from our list. What if you didn't want to use a random.choice and instead shuffle your whole list in the first place? So instead of getting ravioli, pasta, pizza, cheesecake, what if you got pizza, ravioli, cheesecake, pasta? And then it switched around every single time. Well, that's where our shuffle function comes in. So what we can do is, let's go ahead and just print shuffle.function. What happened? I'm sorry. Brain freeze. I'm sorry, guys. Random.shuffle, And in parameters, we're going to put in food, hit enter. So again, we get none, but now if we print out food, as you can see, it's been shuffled. If you do random.shuffle food again and print out food, you'll get a different set of items every single time. So again, both the random.choice and the random.shuffle are very interesting functions whenever you're creating Python scripts. One gives you a random item out of your array every single time, and the shuffle will shuffle up your array to make it a different order. So definitely cool. This is the end for our random module. And in the next lecture, I'm not sure which module we're going to be talking about, but I believe we'll talk with the sys and the os module again. So see you then. Alright, so today we're talking about the sys module. And the sys module stands for system, and it allows us to perform some system-based functions. For example, checking for the version, stuff like that. So the first function, or actually before that, let's go ahead and import sys into our module or into our shell. And once we do that, we now have all the sys functions handy. So if you want to view the different functions, what you can do is you can type in sys dot, and then using your down arrow key, you can now take a look at all the different functions there are with the sys. There's this sys.exit that exits out of the module. There's sys. Let's take a look. Sys.version. Sys.version will give you the version of your machine and so on. So we're going to be talking about three functions with the sys module today. The first one is the stdin, okay? And that's short for standard input. That's basically like the input, except with the stdin, you can specify how many characters you want to read in. So I'm going to show you quickly how this works. First thing you have to do is you have to create a variable. So I'm going to call this our input statement. And this is going to be equal to sys.stdin.readLine, okay? And all readLine says is it's a function which is used to read a line of text typed on the keyboard, okay? And once we hit enter, it's now reading whatever we type. So this sentence is going to be read by the function we just entered. Alright, so now if we print out input statement, okay, what happens? This sentence is going to be read by the function we just entered. So you're probably wondering, well, what's the difference between this and our input statement? Well, there's not much to it, I guess. I mean, both of them do the exact same function, except with the sys.stdin.readLine, what you can do is you can also specify how many characters you want to read. So let's say you were asking the guy to enter his password, okay? And you have a limit for the number of characters that can be a password. So let's say this guy entered 11 characters, and the limit for yours is 10. So instead of reading all 11, what you can do is you can just take in the first 10. Again, that's sort of pointless, but I'm just giving you an example over here. So what you can do is, let's go back to our input statement and, oh, whoops. So, can I change this? Yes, we can. Okay. So in our read line over here, go ahead and specify to be the first 10 characters. So we're only going to get part of sentence and full this, but if we just hit enter, it gives me an error, multiple statements found. Okay, that's probably because I had just done that. So I'm just going to go ahead and write this again. Input statement is equal to sys.stdin.readLine, and then in the brackets, I want to put in, let's say, the first 10 characters. So now if I just type in, this is a password, okay, and hit enter, and if I now print out input statement, what happens? We get this is a. So everything after the first 10 characters wasn't even considered. All this did is it read the first 10 characters. So again, it's pretty cool if you just want a specific amount of characters. Otherwise, stick to input. There's no need to write all this random long line stuff and also having to import the sys module. Okay? Now, the next function, and again, it's quite similar to this, is the stdout. So just like there was a standard input, there's a standard output. And all the standard output does is it's basically the same as print, it just prints out the line. Okay? So let's go ahead and talk about it. It's just going to be sys.stdout sys.write, okay? And again, remember this write function, we've used it before in files. So sys.stdout.write, this statement is awesome, okay? So this is basically just like the print. Again, this returns a number of characters as well in case you wanted that. But look, don't use system for that much. It doesn't have much of a purpose currently. Again, print and input, both of them do the exact same functions as sys. I'm just telling you some modules and some functions that you can use with them just to get your basics cleared out. Now, the last function we're going to cover for the sys module, and trust me, this is the last one, is the version, okay? So we've imported sys and go ahead and just call sys.version, okay? And it gives me, hey, the version of Python I'm using is 3.4.2. It tells me the date. Trust me, it's not October 5th, 2014. I have to change that. And it gives me some 4.2.1 stuff and my Apple Inc. and stuff like that. But yeah, so this can tell me what version of Python I'm using and some other detailed information. Awesome. So let's do a quick recap of what we covered in this small lecture. We talked about 3 functions with the sys module. We learned how to read, how to write, and how to get the version of your computer. Cool. See you in the next lecture. Alright, so our next amazing Python module is going to be our time module. So let's go ahead and first thing first, import time into our shell. Okay? So let's now talk what time is, how it works. So there's a function, okay? And the first function I want to talk about is called time.time. So just go ahead and type in time.time and then 2 brackets. So it returns me 143587446 point something. And all this is it's showing me the number of seconds that have passed since January 1st, 1970 at, what would you say, 0 a.m. So as soon as the new year started on 1970, that's the number of seconds have passed since then, okay? So you're probably wondering, well, what do we do with this information? I mean, time.time, yay, that's fantastic, but how does that help me, okay? So think about it like this. Let's say I had a number, or I'm sorry, not a number, a program, and I wanted to find out how long this program is taking me. Well, what we can do is, for suppose, let's say a function, we can first get the time value right now, let the program run, and then get the time value after the program has completely ran. So the code for that would be somewhat in a function. So I guess that might have been a bit confusing, but just stick with me here. So I'm going to call this function numbers, okay? And it takes in one value, which is how many numbers do you want to write. So the first thing we do is we set the time. What is the current time right now? So I'm going to call this time1 is equal to time.time. Then what we're doing is we're just going to print out a for loop which runs through all the numbers from 0 to max. So for I in range 0 to max, print I. And then as soon as that's done, I want to know what time 2 is. Alright, so think about it like this. Let's say we ran this function. What would happen? Time 1 would get maybe 1,400,3857, or let's say this was at 0, okay? Time 1 would get 0, then after this whole program ran, maybe time 2 will get 15, okay? So then we can get the actual time by subtracting time 2 minus time 1. So print out string of time 2 minus time 1, okay? That looks good. Let's go ahead and call numbers and take a look at what happens. So I want to print out the first 100 numbers. What happens? Alright, it's running. Ta-da! So based on my data, it says that it's taken 3.4 seconds to run this entire program. Now let's go ahead and try this out with maybe 300 numbers. Numbers 300. Alright, so let it run. This might take some time, so we will wait. Alright, almost there. Cool. So as you can see, it's now taken 10 seconds. So this is a very nifty function that you can check to see how long is your program taking. The basic concept is you know what the time is right now.
And you know that in 10 seconds or in 20 seconds, the time will be 20 seconds more than the time is right now. So what you can do is get the time right now, let the program run, and then get the time after the program is run. So by doing that and subtracting the new one from the old one, you can get how long the program has run. Awesome. So this is our first function in our time module. Now the second function that we want to talk about is called the askTime function. So the function askTime takes a date as a tuple and converts it into something more readable. Okay, so let's go ahead and take a look at what it does. If I call time.askTime, okay, what happens? You get Thursday, July 2nd, 15/5/4/2015. Pretty neat, right? So using this function, what you can do is you can create your own date. So you can get what's the current date right now. Okay. Now you can also call this time.askTime with a parameter. Suppose you want to get this format of a date, right? The way you can do that is by passing a tuple through askTime. Okay. And the tuple that we need to create will be on the basis of year, month, day, hours, minutes, seconds, day of the week, and day of the, there's one more parameter actually, day of the year, I believe. And then daylight savings time as well. So it's a bit complicated, but let's go ahead and take a look at it. So time.askTime, all it does is it gives us the current date. Now let's say you wanted this format, but with different values, okay? So that's what I'm trying to show you over here. So create a tuple, let's call it tup, and go ahead and enter the following values. So the first three is the basic ones, year, month, and day. So the current year is 2015. Let's say we're talking about April, so that's month 4, and the day, let's do 5th. Actually, no, let's do my birthday. So 2010-15, okay? Then it's gonna ask you hours, minutes, seconds. So I'm not sure what were the hours, minutes, seconds I was born, but let's go ahead and give it a try at least. So let's say 8 minutes, maybe 45 minutes and 12 seconds. Now day of the week. So basically how you write the day of the week is by numbers. 0 is Monday, 1 is Tuesday, 2 is Wednesday, and so on. I believe I was born on a Sunday, so that would be 6 for me. Okay. Then it asks for day of the year. So just put 0 as a placeholder. Nothing much to that. And then last but not least, it checks to see is there daylight savings time or not. So 0 if it isn't, 1 if it is. I believe there was no daylight savings time when I was born. So let's go ahead and do this. Now all we have to do is call our tuple using the askTime function. So time.askTime tup, and you get Sunday, October 15th, 8/45/12/2000. So this is pretty neat, okay? The askTime function basically does two things. Either it returns you the current date right now, or you can get the date and the time by passing in some few numbers, okay? Again, very neat function. If ever you want the date printed out like this on the console or somewhere, you can always use this time.askTime function. Awesome. So let's go ahead and talk about one last function. Now, this function is called the local time function, and it returns the current date and time as an object. And the value is in roughly the same order as askTime. However, if you print it, you'll get it class-wise, month-wise, stuff like that. So, take a look at this. I'm going to go ahead and call this function time.localTime. Okay? And it gives me time.struct time, TM year 2015, TM month 7, TM day 2, hour 15, minute 8, seconds 19, and so on. Alright? And this is probably a little bit confusing to you. I mean, how do we access these values? How does it work? Well, what we can do is go ahead and set time.localTime to a new variable. I'm going to say time.localTime is equal to t, okay? And now what we can do is we can now set variables of this, okay? So again, a little bit confusing, I agree, but stick with me here. Let's say I wanted to get the year of today. The way I can do that is by saying year is equal to t0, okay? Let's say I wanted the day. So right now, as you can see, our first value is 2015, then the month, then the day. So go ahead and do day is equal to t2, and month is equal to T1. All right. So year, day, month, or actually year, month, day. Now what we can do is if you go ahead and print out year, day, and month, you can now access those values. For example, if you were creating a Python application where you wanted the date to be displayed up top, instead of doing this whole sun, October 15th, 8:45, 12, 2000, if you just wanted to get their date, right, what you can do is you can call the time.localTime function, get the year, day, month values, and then do whatever you want. You can just show the year, just show the day, show everything. You can maybe show it properly like this. You can say print, how does it work? It's what, day, month, year, I guess. I believe, I'm not sure. So day plus the slash plus the month plus the slash, right? How normal people write the date. So using the slashes and stuff plus day, month, and year. So if you hit enter, it gives me an error, unsupported operand type, so I have to convert that to string. My bad. Let me go ahead and do that. So str, this whole thing. Nope, unsupported operand type, so I have to do it individually. My bad, guys. So over here, remove this, remove that, convert str day, str month, and str year. And by doing so, what you'll notice is we'll now get our date in that normal function or that normal way that everyone writes, 2/7/2015. So there's many different ways to get the date, to get the time of the user. If you want to display it using your own special way, you're going to use the time.localTime, access the values in it, and then display the date however you want. If you want it in the normal Python way, which is this sort of way, just call the time.asktime, and that'll return you the current date of the user today. Then we also talked about the time.time way up over here, which basically returns you the number of seconds since 1970 January 1st. Awesome. So we've talked a lot about the time module, and I think that's enough for, a long time. But before we go, there's, I think, one last function you should probably know. You're probably bored of time by now, but one last thing, and that's called the sleep function. So let's say I gave you, so for I in range 0,5, 0,5, I wanted you to print I. However, you didn't want the numbers to come so fast. Right now, zup, 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 zup. I mean, you can't really understand what's happening. What if you slowly wanted each number to come? This is where the time.sleep function comes. And all sleep does is it pauses the program you're running for how many seconds you want. Let's say I wanted it every second. So 0, 1, 2. You can see how it slowed down the program and made it easier for us to understand. So again, time.sleep is a very, very interesting function. And when we get onto animations and more graphical interface objects, this is where the time.sleep comes really handy. Awesome. So I'm now done with the time module. If you have any questions on how things work, why is it 1970? I'm actually not sure about that. But if you have any questions, definitely get back to me on the forums, and I'll see you in the next lecture. Alright, so for our last main module, we're going to talk about the turtle module. And this is going to be the introduction to GUI, or I'm not sure how you're going to pronounce it, but GUI, so Graphical User Interface. So mainly all our GUI is going to be happening with the Tkinter module, okay? And I have a whole section for that, which is probably the next section. But before we get to the Tkinter, there's another basic module that I just want to explore and give you guys a chance to maybe get the hang of how things work. So this module is called the Turtle module, and it's fantastic for small sketches, small drawings, creating very basic shapes and animation, okay? And the way this works is, well, first thing first, import turtle onto your shell, okay? Import turtle. Now, to draw simple shapes with the turtle module, you first have to initialize a pen, okay? So to initialize a pen, you use the command t.turtle, t is equal to turtle.pen, okay? Note the capital P. And as soon as you do that, you now notice on your bottom right screen, you can't see that because I'm only recording part of my screen, but this Python launcher has now appeared. So what I'm going to do is I'm going to minimize this,
And for most of you, this should have worked. You're now going to see the small black arrow on your screen. Pretty neat, right? And what you can do now is you can make that black thing move. So what I'm going to do is I'm going to minimize my screen over here. And I'm going to bring this up over here so that it doesn't become too cluttered for you. And one sec. So let me just, I'm sorry about that. Let me just do this. Alright, so the way we can move this, make this turtle pen move is via some simple commands. The commands are forward, left, right, forward, whatever you want. But think of it like this. So I'm sure you must have used degrees, or maybe in 8th, 9th grade in geometry you learned about degrees, right? So you know what a 90-degree angle is, you know what a 180-degree angle is, you know what a 30-degree angle is, and so on. So that we're going to be using angles or degrees to make this object move. So the first command you might want to write is t.forward, let's say 50, okay? What does that do? Immediately you can see on the right-hand side of your screen, this arrow or this object has now moved 50 pixels, I believe, to the right or to forward. So let's say we want to move it up. Let's try to make a square here. So we want to now turn him to the left, make him go up. So what is up here? Up is 90 degrees to the left. So we write that command, t.left 90, okay? And as you can see, now our pointer or our object is now moving upwards. So t.forward 50 again. We now have half our square done. Let's go ahead and do t.left 90 again. And now it's turned again, t.forward 50. And to finish it off, t.left, whoops, 90. And then t.forward 50. So this is a very simple and easy square to make in our turtle module. So again, very interesting. The whole concept of the turtle module is you initialize the pen, and then using commands like t.forward, t.left, t.right, you can create some very, very simple shapes, right? Awesome. So the next thing I want to talk about is reset. So let's go ahead and quickly cover how to reset the screen. Awesome, fantastic. So we've now created a very simple square, I guess you'd say, in our turtle module. We've learned how to initialize turtle, how to create the pen, how to move our object, make it turn and such. And in the next few lectures, we'll be covering more and more functions that deal with this turtle module. Right, so in the last lecture we left off where we had learned the basics of the turtle module at least. We created a very simple square. Now let's say I told you, hey, I want you to create an octagon. So let's go ahead and take a look at how that would work. I'm going to go ahead and import turtle. T is equal to turtle.pen. Oh my god. Turtle.pen. And then once we do that, our rocket launcher icon appears, and I'm going to go ahead and minimize this. This has come. Let me go ahead and make it suitable for your screen. So this goes over here, and we get this. Cool. So let's say I wanted to create an octagon. Alright, so you're probably thinking about, hey, what's the angle going to be? And the angle for that's going to be 45. 45 into 8 is 360. Now, what are we doing? Well, the basic concept would be, again, do that 50, then left 45, 50, left 45, 50, left 45, 50, left 45, 8 times. Think about it. 16 lines of code. Wouldn't it be easier if there could be some other way where we could repeat those 2 lines of code over and over again? If you thought loops, guess what? You're becoming a Python programmer. So loops is our answer to most of the turtle graphics, or any of the turtle graphics in this whole section. So what we can do is for I in range 0, 4, or since it's an octagon 0, 8, what do we want? Well, it's going to be those 2 commands over and over again. So t.forward 50, t.left 45, right? So t.forward 50, t.left 45. What happens? Ta-da! We have now created a very cool stop sign, or a very cool octagon, whatever you want to call it. So this is where for loops can greatly help us out. they can reduce the amount of time we spend and the amount of code that we write. So let's say you wanted to create a star of some sort, right? What we can do is to create maybe a spiraling star or any sort of star. T.reset, first of all. T.reset basically removes any lines that were there before and sets it back to the beginning. For I in range, let's say 1, 40 or 38. We want T.forward 100 and T.left 175. And by doing so, if you notice, we'll now create a very intricate star. So you can definitely play around with the turtle module using for loops. Again, switch some angles out, move some angles in, increase the size, decrease the size, do whatever you want. But you'll notice there's a lot of capabilities that you can use with the turtle module. So we've just now created a very spiky looking star. I think that looks amazing. And you can just go ahead and play it around. So let's do one more right now, just for the fun of it. T.reset, and for I in range, let's say 1, 20. Okay, T.forward 100 and T.left, let's say 95, I guess. So by doing so, now what happens? Look, you get this, again, a very spirally intricate looking star. So what I highly suggest is play around with this Tkinter module, play around with for loops, change some of the values that we've used, and show me your intricate figures that you create. Because at the end of the day, again, this whole turtle module is just to have fun, create new and cool designs. Now, once we're done with this for loops and stuff, but what's next? So let's say you wanted to make 2 objects, right? We created a circle, and I wanted to create another circle over here. Or not even a circle actually, but let's say 2 squares, right? So how do I make it so that I create one square over here, and then maybe the other square 100 pixels to the right? Right now, if I try to do that, it'll create a line between one square to the other square, which I don't want. So in the next lecture, what I'll show you is some different functions which will enable us to create some separate objects. Alright, so in the last lecture, we left off where we learned how we can use for loops in our turtle module. So the next thing we want to talk about, or I want to talk about, is called lifting up our pen, okay? So the way this works is it uses the function called begin fill, end fill, up and down. Okay? So begin fill and end fill are actually a separate entity. We'll talk about that in the next lecture. This lecture, I just want to talk about the concept of up and down. Okay? So we have this fantastic looking star, and let's say I want to create one more star right underneath it. So I'll say T.right 90. And I'll get it now downwards. I'll say something along the lines of T.forward 100. And then I'll go ahead and create my star. So I'll copy this function again. It'll run, and I'll get this cool looking star. Except the problem is right now, both these stars are connected. You have this ugly looking line. How do I remove this line from sight? Well, this is where the T.up and T.down function comes in. So I'm going to go ahead and reset this, okay? I'm now going to say or actually, right over here, you know what, let's just go T.left 180. So I'm going to move back a bit. Alright, T.forward, let's say, let's do 100, okay? And then let's go ahead and turn back the exact same way. T.right 180. Again, you just don't do this. I'm just creating some space on the right hand side, and now I'm going to go ahead and call this function again. So I call this function, nothing really happens, but we now get this star a little more to the left. So after this is run, we now have this awesome looking star. And now what we can call is the T.up function. And all this T.up does is now if I call a function like T.forward 100, guess what happens? Our cursor moves, or our pointer moves, however, no line is drawn. So I'm going to go ahead and move this 40 pixels more, I guess. So get it out in the open. And now, let's go ahead and run this star again. So I run this, and what happens? Ha ha ha. Nothing happens. Why? Because I never put the pen down. So now that our pen is in the right position, go ahead, put the T.down function. So now it's going to write.
and then call this function one last time to get our second amazing square, or star, whatever you want to call it. Alright, so let create. Awesome. So we've now created two cool looking stars, and we've made them separate from each other by learning the theta up and theta down functions. Now the next thing, or the last thing we're going to talk about, is filling up these colors, or filling up an object. For example, if I create a circle, right, and I want to give that circle some color, how does that work? Well, what I can do is, there's a function called begin fill and end fill. And we'll get to those in the next lecture, but I just want to give you a brief introduction that you can use those functions to add color to your objects. If you create a square and you want to give that square a blue color, you can use those begin fill and end fill colors to color up your objects. So we'll talk about those in the next lecture, and I'll see you then. Alright, so we're now going to talk about coloring of our objects, okay? So the whole concept of color begins with the t.color function, and then we'll move on to the begin fill and end fill. So the way this is going to work is, let's go ahead and import turtle. Let's go ahead and get our module there. So t is equal to, t is equal to turtle.pen, okay? So, turtle, okay? So t.turtle.pen, okay? So my rocket launcher icon has now appeared. Let me go ahead and make some space for our thing. So this moves over here. Let's get this over here and minimize the size. Okay, so this works. Now the next thing I want to talk about is the color, right? So while filling up an object, it takes in two commands. The first is to specify which color you want to fill it up with, and that works on the basis of RGB. So what's the color for red, what's the color for green, and what's the color for blue? So since we're creating a blue car, let's go ahead and create a very simple blue hull or blue shape of the car. So the whole purpose of this lecture is to create a very simple car, okay? Not some Lamborghini or not some Ferrari, but a very simple box car, okay? The very primitive kind of car. So the way this is going to work is two black wheels and then one blue mainframe. So let's specify that we're now creating a blue car, and immediately, as soon as we do that, we now see that our arrow has now become blue, okay? So the next thing I want to do is begin fill. So t.begin fill, begin and underscore fill, okay? And now that we do that, it'll now fill up any object that we create. So thinking of a boxcar, how is that going to work? Well, let's say our base is 150. So t.forward 150. Okay. Then t.left 90. T.forward 30. T.left 90. T.forward, let's say 40. T.right 90. T.forward, let's do 40. T.left 90. T.forward, so if we did 40 there and 40 here, 80, 70. So 70. T.left 90. T.forward, what did we do? We did 40, I believe. Yes. T.right 90. T.forward 40. T.right or left 90, and then T.forward 30 to finish it off. Wow, so we've now created a very simple boxcar, and you can see how much work it took us. It's tedious, it's not fun, but this is just a quick example of how to create a boxcar, alright? So now to get that filling in, to make it colored, what you can do is you can now call t.endfill, okay? And all that does is it now, whatever object we've created, it'll be colored through and through. So very interesting concept. Now the next thing we want is to add our two wheels, okay? So I'm going to go ahead and call t.up. Then I'm going to move this, so t.right 90, Okay, or actually, I'm sorry, t dot right 180. We want to face it the other way now. Okay, and I'm gonna move this a little forward. So let's say t dot forward 40. Okay, this is a good place to make our wheel. So we want to make our color back to black. So t dot color 0, 0, 0. That's the signature for black. And now what we want to do, let's go ahead and make this down, and t dot begin fill. So to create a circle, there's actually no need for any complex code. It's one line, and I'm actually pretty happy about this. It's called t dot color and then the radius of your circle. So let's go ahead and do maybe 15. I'm sorry, not t dot color, t dot circle 15. And if you do that, it will now create a circle. However, it has created it in the wrong place. So what we can do now is, now we've learned where it's going to create it, let's do t dot right 90. Okay, t dot forward 15. T dot forward 15. T dot right or t dot left 90. Okay, and now if you call the function circle again, t dot circle 15. Oh, whoops. T dot circle 15. We now get an awesome looking circle. So let's go ahead and end fill. So t dot end fill should be just like that. So think that this other circle is not there. Again, I'm sorry about that. I should have realized that the circle we created up top. However, we now have what looks like a very interesting looking wheel. All right. So let's do it this exact same thing for the other side. T dot up, so that we don't get any of those random lines. T dot forward, move it, let's say, well, what would it be? So 40, 80, 70. So t dot forward 70. And now just go ahead and call that circle function. Oh, actually, before that, t dot begin fill to make sure that we actually get the color inside of the circle. T dot circle should be 15 again. And whoops, looks like we didn't put our pen down. So t dot down, t dot circle 15. And after some time, this typing actually gets quite tedious. So you're probably bored by now. But we'll be ending this turtle lecture soon enough. These will be one of the last actually. So t dot circle 15 creates a very interesting looking circle. And then let's go ahead and end fill. Alright, so it looks like our thing did not get colored. I'm not sure why, but let's go ahead and try this one last time. So there is a function called set heading, and put that as 0, and all that does is, well, take a look for yourself. So let's go ahead, do the begin fill function again. Then t dot down, it's already down, and then t dot circle as 15. Does that again. T dot end fill. Alright, now it's worked. So forget the set heading. It's not something we needed. I thought we might require that, but leave that for now. So we've created two cool looking circles. I'm gonna go move that pointer up out of the way. T dot up, t dot forward 50. Alright. So this is a very interesting looking car. I mean, it's a nice blue body, a random black circle on it, and two wheels. So interesting enough, it doesn't look too bad. And we learned quite a lot in this lecture. So we learned that Turtle is a very tedious model. We've learned that it takes a lot of code to create a very simple object. And we've also learned about a few functions like begin fill, end fill, and our color function. Alright, so very cool, guys. Hopefully this is the last lecture in Turtles. I myself am not a huge fan of Turtle module because of how tedious it is. But I'm definitely sure there'll be 1 or 2 more lectures dealing with functions in the Turtle module and talking about some other interesting looking objects. Alright, so see you then. Alright, so the last few lectures we've learned quite a lot dealing with the Turtle module. We've learned how to first of all create some basic shapes. We learned about the forward, the left, the right. We then learned about the up and the down, how to fill in colors, how to choose a color, and how to reset the whole frame. Now the next thing I want to talk about today is functions. So just like we learned how to use loops with our Turtle code, I also want to show you guys how we can use functions as well.
So it's going to be very interesting. Now, the first function that we should create is a simple function that creates a square based on the number you provide. For example, if I pass in 50 into the function, I should get a square of side 50 in length and width. Okay, so let's go ahead and create it. First thing first, I need to import turtle. Then t is equal to turtle.pen. Alright, and as soon as I do that, my Python launcher comes, and again, just like the previous few lectures, I'll be minimizing this and bringing up my Python launcher. So here it is. Let me just put it side by side. There we go. And here. Awesome. So the next thing I want to do is create this function. So the way this function will work is just like any other function. We'll use the def key. Then let's call this a square function, for example. Square. And it takes in the parameter side. Okay. And all the side does is it tells us, hey, how big do we want our square to be? And all we're now going to say is for I in range, 0, 5, we want to say, oh my god, 0, 5, all we want to say is t dot forward. So t dot forward side and t dot left 90. Alright, so again, a very simple function, and let's go ahead and give it a try. So square 10. Let's do a small one. Fantastic. Let's go ahead and try another one. Square 20. Alright, let's do one more. Square 50. Alright, so this is a very cool function in which we just talked about how we can use, our function skills we learned a few sections ago into our turtle module. So let's go ahead and create a circle one now. Again, it's going to be the exact same thing. We'll pass in the radius, except now what we can do is, actually, let's just do radius. Let's keep things simple. So for there's nothing to it. All we have to do is say t dot circle and then radius. Alright, so if I circle 10, okay, pretty cool. Circle 50 and circle 100. Very neat. So as you can see, we've now just basically touched base on functions with Turtle module. Again, it's a very broad subject. You can do tons and tons of things. So what I want you to do now is just play around with this whole Turtle module. Hopefully you've got the hang of it. Again, we won't be coming back to this Turtle module. This is basically just to show you, hey, this exists. I want you guys to know. But after this, all our GUI, all our graphics will be done via the Tkinter module. So fantastic job. If you have any questions on any of the inbuilt modules we've discussed so far, what does asTime do? What is sys.exit? Or how does this Turtle module work? Why is it there? Stuff like that. Please don't hesitate to ask. I'll definitely reply to you. And other than that, I hope to see you in the next section, which will be about the Tkinter module. Hi there. In the previous lectures, we talked about the sys module, the time module, and the random module. In this lecture, we'll be talking about the re module. But before we get there, I want to show you a cool feature about strings and what we can do with them. So open your PIDLE, expand it, and type with me. So let's create a new string. String is equal to a random word, ubiquitous. And now let's say if we wanted the first 3 letters of the string, how would we do that? We'd say string, or let's print this, print string, and then in the square brackets, we're going to say 0, 3, 0:3. We got ubi. Now let me explain what we did here. So we did string. So we wrote the string name, and then in the square brackets, we did 0 to 3. All this means is start from the first letter, that is 0, and then take the first, the second, and the third letter. So 0, 1, 2. It does not include the third, which would be Q, but it'll take 0, 1, 2. If we said string 0 to 4, what will we get? ubik. If we said string 0 to 6, ubiqui. So this is how we can get part of a string by using a square bracket and specifying our range. Now let's say we wanted quitis and we didn't want the ubi. How would we do that? We'd say string 3 0. String 3. So what this does is we say here that take all the letters except the beginning 3. So we don't want the first, the second, or the third, but after that take the rest. We could say something like string 3 to 5 QU. We could say string 1. That would be ubiquitous. So this is the main concept of getting part of a string. You can use these square brackets and specify our range. We'll be doing that in the next lecture. Alright, re module. Re basically stands for regular expression operations. So first, let's import re. Alright. Now, there's a lot of functions you can do with re. If you want to find out, just do dir re. Remember the function we did a few lectures ago? The directory of re will give us all the different types of functions. So you can do a search function, a split function, you can do a compile function, a parse function, sys function, all sorts of functions. Alright. In our app, we'll be using, in our stock app, we'll only be using a few of them. Let's get to it. The first one will be the search. We'll be using re.search. So the re.search takes in 2 parameters. The first parameter is what are we searching for? For example, let's first create a string. The night was cold and dark and there was no one there. Alright, this is any sentence. Oh, whoops. String is equal to the night was cold and dark. Fine. Now, what we want to do is let's say we want to find out if there was NIG. We're searching for the term NIG. So we'd say re.search. What are we searching for? Let's just search for night. And then comma, what are we searching in? We'll be searching in string. Click enter. Alright, match found, span 4,9, match night. That means there's a match. But we want to store this in a variable. So we'll say anything. I'm just going to call it M. M is equal to re.search night, comma, string. Alright, now let's print M. Let's see what we get. We get the same thing. But with this M, we can do stuff. We now know the placement for where night is. So let's say we wanted to get just this. What will we do? Let's create a new variable. Let's call this start. Start should be equal to m.start. Stay with me here. I'll explain everything. And we know that night is 5 characters long. So we'll say n is equal to m start plus 5. So if I print start, what do I get? I get 4. If I print n, what do I get? I get 9. Now what I can do is I can say string in brackets start to end. Awesome. Now let's explain what just happened. We had a string. Our string was the night was cold and dark. We used the re.search operator or the function to find if there's a night in our string. Now it's always good to use the search option if you know it's there. That's the whole point of it. So re.search night in string. We save that into a variable called m. Now when you print m, you will get this. But using the function m.start, you can save the value the span value for m.start is equal to start. And you could have also done something like this. m.end. If you print m.end, let's print this. Print m.end. Click enter. 9. So basically, m is our variable that we got from re.search in the string while searching for night. And m.start and m.end correlate to the 4 and the 9. m.start correlates to where it is in the beginning, the first letter, the position of the first letter, and m.end correlates to the position of the last letter. I hope you got that. Let's go over one more example. Let's create another string. String 2 is equal to some random stuff, cheese, and some random stuff, cake, random stuff, pizza. Alright, now we want to search in this for cheese. So what do? It's quite simple. Re.search, then in brackets, cheese. What are we searching in? String 2. That should be easy enough, right? It gives us the span 27 to 33. Now, if you want to get the span, what do? We do .start and .end. So first, let's save it into a variable. Let's just call it position is equal to re.search, then in brackets, cheese, comma, string 2. Awesome. Okay, whoops. All right. Click enter. Nice. Now we have position.start and position.end. There we go. So if we just want to get the cheese out of the string, all we have to do now is say string 2 in brackets position.start colon position position.end cheese. Alright, I hope you're getting it now. We've gone through 2 examples. You should be getting the hang of it. First, we search, store it into a variable. Then we use the m.start and .end functions to get the beginning letter's position, the final letter's position, and then using what I taught you over here by putting a colon to getting part of a string out, we'll use the exact same function here and then get out cheese. Awesome. So this is mainly the whole concept of regular expressions. Now, there's a lot more to it, but for the next lecture, all we're going to need is this. In the next lecture, I plan to make a stock app, which when entered a stock, for example, FB, will return the stock value. See you in the next lecture. To use it, we learned its functions, and we also learned the re.search. In this video, we'll be talking about our stock program, how to code it, and how to crawl the web for data. Well, what are we waiting for? Let's get started. Open up your IDLE, expand. All right, we'll be using 2 modules in this program. The first one is the import re, and the second one will be the URL lib. But I won't be using the whole library. I'll just be importing URL lib.request because that's the only function I want. Awesome. Now, we have to first get a URL to parse data from, because without a URL, there's no point. So let's go to our browser. Let's search Google Finance. And let's click it and search for a random stock. Awesome. Now, I hope you noticed, but above, you can see in the URL itself, the stock name has appeared. And that's what we want, because we can change that via our code. So let's delete this stuff, the stuff after the goog. Delete that. And now let's try changing it. So let's make it FB. Awesome. That came up. Our URL. Let's go back to our code. And one thing I want to teach you here is how to add a comment in Python. Commenting is simple. All you do is you hit the sharp sign and then enter all the text you want. A comment in Python basically means text that will not be counted as code. It is just for general knowledge to understand what's happening or to load some data or anything, but it won't be counted as real code. Awesome. So we now have our URL. Let's create this thing. Let's create a variable. Start with the quotation mark, Command V, end with the quotation mark. So this is our URL, https www.google.com finance question q equal. Now whatever stock name the user wants will come after the equal sign. So quick challenge, can you do that? And a hint here is to add two strings together, all you need is a plus sign. So the challenge is to create an input, get the user stock, and add it to the end of URL. Start. All right, let's do this. So let's first create an input. Stock is equal to input. And then in brackets, enter your stock. Awesome. Now enter your stock. Let's just go with FB for now. Great. Now what we have to do is make the stock go to the end of URL. So URL is equal to URL plus stock. This is known as concatenation of strings. So you can add two or more strings together by just using the plus sign. Great. So if we try printing out URL now, what do we get? https www.google.com finance question q equal to FB. Awesome. Now we're going to use our URL lib.request. So we want to store that link or our URL's data into a variable. So let's create a variable called data is equal to, now I'm going to write a bit of code and I'll explain it as soon as I'm done. URL lib.request URL lib open URL open, sorry. And then URL open, what URL do we want to open? It's going to be our URL.read. Awesome. So what we did here was we said data, our variable, is equal to URL lib module dot request. It's going to send a request and opens up URL open our URL. What's our URL? Our URL was http Google Finance FB. So once it's opened, whatever data is in there, it's going to be read and it's going to be printed out. Alright, before we go further, the first thing we need to do is to decode the data. So upon calling a request, opening it and reading it, we got our data in bits and bytes. So create a new variable, data1 is equal to data.decode in brackets UTF-8. And this should be in quotation marks. All right. So all we did is we decoded our data using the UTF-8 parameter, and it converted those bits and bytes into words and normal strings. Now, if you had printed data, you would have seen a normal result, but it would have caused errors later on while doing our re-parsing. All right. So now let's search for our re.search function. So let's first find out what we're going to search for. Let's print data1. And we got this. So this is now much more easier to use. If we had printed out data, you must have seen that data is all clumped up together and it doesn't look nice. This is a much more visually pleasing way of printing out our data. So Command F and let's search the value of the stock. So wait, go to Chrome. Let's do this. Yeah, I'm gonna leave this page and I want to search for what is FB right now. FB stock 76.45. okay, so let's search 76.45. Find next until we find the one we're looking for. Here we go. Meta item prop is equal to price. Content is equal to 76.45. Great. So let's close this. Close. Now, we're going to be searching for this. Meta item prop is equal to price. In any Google Finance link, you will find this meta item prop equal to price, and underneath that, the value of the stock. So Command C this, close this, go to your IDLE, scroll back down, and do Command V. So that's what we're going to search for. So say M is equal to re.search. Just remember our research search function like we did last time. Now don't use double quotation marks in the beginning, use single quotation marks because of the price. So single, close this, and now we're gonna say comma, what are we gonna search in? Data or data 1? Data 1 obviously. So let's just recap. M is equal to re.search. What are we searching for? Meta item prop is equal to price in data 1. Click enter. Now if we print M, what do we get? Awesome. So we now know where the location is. 79549 to 79570. So let's create a starting variable. Start is equal to m.start. And let's make end 50. So end is equal to start plus 50. Great. So now we're going to use what we learned in the previous lecture. So data 2, or let's just call this new string, is equal to data 1, and then in square brackets, start colon end. Click enter. Awesome. Print new string. What do we get? Meta item prop price content is equal to 76.45. Great. Now what we have to do is get the content out. So content, i.e. 76.45. So we don't want the quotation marks, we don't want the content, we don't want any of this. So what we're going to do, let's create another search. M is equal to re.search. And what are we going to search for this time? It's going to be content equal to, and then double quotation mark. So we're going to be searching for this, the content equal to double quotation mark. And what are we searching in? We'll be searching in our new string. Awesome. So click enter. We got this. Now what we want to do is we want to take the end of this, i.e. the colon, and up till this. So first what we're going to do is get the end. So end is now going to be equal to, or the beginning, start should be equal to m.end. I hope you got that. Basically all we're doing is we want from here onwards. So m.end is equal to here, and the start should be that. So let's update our new string. New string 1 should be equal to start colon. Hit enter. Invalid syntax. Alright, that's because I forgot to put our data 1 or our new string here. New string, and then in square brackets start colon. Great. Let's print out new string 1. See what we get. We get 76.45 and then double quotation mark, space, and a slash. So all we want now is to get it up till 76.45 and then end. So it's quite simple. All we're going to do is do another re.search. M is equal to re.search. We'll be searching for search for the slash, because you never know, you might get some more stuff over here. So we're going to be searching for slash in this, and we'll be searching in what? New string 1. Great. So now what we want to do is we want to say start will be equal to 0. So we don't even need that, but that's fine. And end should be equal to m.end minus 2. So I hope you got what we did there. M.end will give us this, but what we want is minus 2. So we want up till here. So we'll get rid of the quotation mark, we'll get rid of the extra space, and we'll just have 76.45. So then we're just going to say final is equal to, and then we'll be doing this with what? New string 1. And in the brackets, we're going to say 0 to end. Print final, and what do we get? 76.45. Okay, so it looks like the quotation mark didn't go away. So let's do end is equal to m dot end minus 3. My bad. Final is now equal to same thing, new string 1, 0 to end. Print final. There we go, 76.45. You have now successfully crawled your web and you have created a running stock program. Congrats. Now to make this a little better, let's do print and then in quotation marks the value of, and then we're gonna say plus stock, put a space over here, plus the value of FB. So remember in the beginning, our stock, the value of FB is, and then a space, plus final. So this is concatenation. We did this earlier above. So a string, then plus another string, etc. So print, the value of FB is this. Whoops, we missed a space. Let's get that space in there. Alright. The value of FB is 76.45. Great. This is a huge accomplishment. Amazing. We now have a running stock program that gives us the value of the stock back. Now, I have done this program in the shell, so doing this again and again might be tough. So let's quickly make file, new file. If you don't mind, I'm just going to quickly write it in here so that, you can copy off and you can save this file because this is a pretty huge accomplishment. So let's quickly start. Import import URL lib dot request. What did we do after that? We first had to create a URL. So all I'm going to do is I'm just going to go up and copy paste because that's what I think is going to be the easiest right now. So yep, that was a lot of data right there. So I'm going to minimize this. Whoops, not minimize, but we have to make this less. Alright, so URL should be equal to https whack. So you can follow me, just copy the code into this file. Awesome. So in just 5, 10, 15, 20 lines, you have created a running stock program. Great. I hope you learned a lot in this lecture. This was actually quite a detailed lecture and we learned a lot. So we learned about parsing through the web. We learned about getting a string out of a huge random jumble of information. And then we learned breaking down that string even further to get the value that we want. Now, a neat feature you could do here is we could say something like, we could create a for loop. So you could have an array of stocks is equal to, I don't know, it could have FB, Goog, Data, Baba, I don't know. You could have any amount of stocks that you want. And one more thing over here that we can do is stock.upper. If you remember what that function does, it makes the string, the string's letters capitalized. So let's run this before I move on. So run module, source must be saved. Okay, let's save it. Let's call it stock quotes, save in documents, great. Invalid syntax, 0 to end, right? Because we forgot the new string. New string 1, 0 to end. So run this, Python module, run module, save source, enter stock, FP. The value of FP is 76.45. Great. Now, as I was talking over here, we could have done array of stocks is equal to these four. And then as a simple challenge before I end this lecture, just do it so that a for loop is created, and every time that for loop runs, so we will do something like for I in array of stocks, then I want you to put the stock over here, so we wouldn't be inputting anymore. It'll just be this name. We're using these stock names, and I want you to return the result. So quite easy. Using these stocks, it should be a for loop running through each stock and returning its value. Alright, so we learned a lot in this lecture. See you then. Hi there. In this lecture, we will be creating a weather program, i.e., the user will enter a city and our program will return the weather of that place. Well, let's get started. Open up your IDLE. Let it load and expand it. So I won't be doing it in the shell anymore. So create a new file, untitled. We'll be doing it in here. Great. So let's start. So like we did in the stocks program, let's import re and import url.request. Great. So first thing first, we need a link. So let's open up our Chrome or any browser that you have for that matter. Let's open it up. Let it load. All right. So here we have Chrome. So the website we're going to use today is called weatherforecast.com. So WATHER forecast.com. Just click it. Here we go. So in the title, / locations / the city name. So right now I'm just going to do Seattle / well, actually, sure. So Seattle / forecasts / latest. Okay, sorry. So weatherforecast.com, my bad. That was a mistake here. So just copy this. Locations / Dublin / forecasts / latest. So click that. Now, if you see in this website, as you might notice, they have given this Dublin 1-3 day weather forecast summary, light rain, blah blah blah, mild temperatures, all this stuff. So this is what we want to collect. Now, as you might have noticed in the URL itself, this can change. So if I put Seattle in here, I'll get what I want. If I put maybe Paris in here, I'll get that city's weather. So just like in the stock app, we concatenated our stock to the end of the URL. In this case, we'll be adding it in the middle. So Command C this, and let's close this up. So let's quickly create a comment with this stuff. Great. Now we first want to create a URL. So first let's create our input. So city should be equal to input. Enter your city, : space. Great. Now we want to say URL should be equal to this, but we want to remove Paris. So let's remove Paris, delete Paris, +, city, +, forecasts, latest. Great. So this is now our URL. All we did is remove the city part, or the city part which was Paris, and we put our variable city. So it'll act as the same thing. Now what we want to do is we want to get the data. So if you remember in the stocks, all we did was data is equal to URL lib.request.URL open. Which URL are we opening? URL.read. Great. Now we have our data. We have to decode it. So it's UTF-8 like last time. Data 1 is equal to data.decode and then UTF-8. Great. So now we've decoded our data. So I'm going to pause the video here and see if you can try it yourself. Remember, when you start writing code, you can always run it. So write one line, click run, save your stuff, click run, click run. It's always good to test. Because if you write all your code and then click run, you'll be confused and have to rewrite that code all over again. So after every line, try running it and see if it works. Great. So I'm going to stop the video here for now, for a few seconds, to see if you can create it yourself. If you can, great. If not, then just try. Alright, let's get started. So first thing first, let's print out our data1 to see what it is or what exactly is happening. So let's run this, run module. It's going to prompt to save. Say, okay, let's save. I'm going to call this weather. You can call it whatever you want, but make sure you know what it's called. Great. So enter your city. I'm going to say Seattle. And we got all this. So we want to search for, let's try to find it. Something 1 to 3 day. Okay, wait. I'm just going to go to there and search. So weatherforecast.com/Seattle, and then this is what we want. So let's just copy this, moderate rain, whatnot, Command C, Command F, Command V, find next, whole word. So it's not finding it. Let's try to find it ourselves. Alright, if you found it, good job. Let me try to find it. Alright, yeah, here it is. So try to find span class is equal to phrase. Actually, you know what? Let's actually do that. So Command F, if this works. Seems to be frozen, but yeah. If you notice, span class is equal to phrase and moderate rain has been highlighted. This is what we want. So moderate rain, heaviest on Thursday afternoon, very mild, something, winds increasing, blah, 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 all the way up till here, Thursday night. Great. So if this works, it should. It's not working. All right, but we know what we want. Span class should be equal to phrase. So let's go back to our file. Weather. All right. So we'll be searching. Oh, we can close this now. Span class should be equal to phrase. So M is equal to re.search. We're going to be searching for span class equal to phrase. So make sure you use the single quotes and not the double quotes. I made that mistake. I'm fixing it right now. All right. So span class should be equal to phrase. Great. So let's do m.start should be equal to m.start, and end should be equal to start plus I'm going to go with 100. Great. And let's make our new string. So new string is equal to it's going to be data1 and then in brackets start to end. All right, Command S, and let's run this. So run module. Enter city, Seattle, not moderate rain, just Seattle. It's gonna give me an error message. I know. Yeah. Okay, let's try that one more time. I'm not sure what happened, but something happened. Wait. So Command S, F5. It runs this. I'm gonna say Seattle. It says search missing one required positional argument string. So let's go back to see the error we've done, or I've done. You might have not have. Right. So we're missing the search in. Sorry, my bad. Re.search takes in 2 parameters. One is what we're searching for, and the second is what we're searching in. So we're searching in data1. Save that. Let's run this again. Enter city, Seattle. And we have, well, it printed data1 again, but okay, wait. So let's actually remove the print data1 because I'm not able to understand anything. So let's run this one more time. Sorry about that. Enter city, Seattle. All right, it's not printing anything. So let's see what went wrong in our code. So we're saying start is equal to m.start, n should equal to start plus 100. We should actually make this start m.end because we don't want any of that. So m.end,
Data is equal to URL lib, URL open, read, data.decode, m is equal to read.search. We're not even printing it, duh. Sorry. Print new string, Command S, F5, there we go. Enter city, Seattle, and we have this. Moderate rain, total 13 mm, heaviest on Thursday afternoon, very mild, max 11, and it gets cut. So, the first thing we need to do is make this longer, so start plus 200, and if you notice in the beginning, we got that small alligator sign. We can get rid of that by putting it in our phrase, so span class is equal to quotation mark phrase quotation mark and then the alligator sign. Command S this, F5, it runs, enter a city Seattle, and we get this. Great. Moderate rain, total 13 mm, heaviest on Thursday afternoon, very mild, blah blah blah, increasing, blah blah blah. So it's still getting cut, I don't know, but just to verify, let's increase it by another 100, because for some cities it might be a lot of weather and that means more lines. So F5 this again, enter your city, Seattle. Okay, so Thursday night was the end, and as you can see, now we've gone on to a completely different thing. So I think what we can search for now is this bracket. So if you see, okay, no, we have another instance of the brackets everywhere, so we can't search for that. Let's search for the span. So we'll do a mre.search on the span. Alright, we'll be searching for the span here. So open up your IDLE back. Let's get back to the weather. Alright, and now let's do this. So m is equal to re.search. We'll be searching for the span. So span. Alright, comma, what are we searching in? We're searching in new string. Great. Now we want to say that m.start, so start, and actually end should be equal to m.start. But as you can see here, the start will get you here. We want to get rid of the dot and this. So what we're going to do is -2. So let's go back there and let's say m.start -2. And now let's do final is equal to, and then new string 0 to end. Great, let's print final, see what we get. Awesome. Run this, F5, Seattle, whoops, enter. Moderate rain, total 13 mm, blah blah blah, blah blah blah, by Thursday night. Awesome. So now we've created 2 successful programs that parse the web. The first one was the stocks, and the second one is weather. Great. So I can now say that we've accomplished a lot. This is huge. Parsing the web is no small thing, and this is great. In the next few lectures, we'll move on with some more complex stuff. See you then. Hi there. This is a third part in our web scraping course. So we did the first, which was getting stocks. The second was weather, and now we'll be creating a definition. So the user will enter a word and we'll give its definition. It's quite simple and it's along the same lines. So open up your IDLE. Let it bounce. Alright, expand and click on File, New File. So we'll be doing all our coding in this. Cool. So let's import the modules that we've used before. Import re and import urllib.request. Great. So first of all, we need a URL, like always. From where are we going to get the definition? So open up your browser. I'm just going to use dictionary.com for now because that's the one I like the best and it gives us good results. So dictionaryreference.com/browse/ So /browse, it's going to give us this. And if you search in this dictionary, let's say car. What does car mean? I have no clue. So we get this.
Now we can delete the question mark, the S is equal to T, all that stuff, and we have this. So like our stock application, we will be adding the input from the user to the end. So we can remove car and search anything we want. Let's search guillotine. Guillotine. There we go. So just like that, copy the URL. So from browse up till here, Command C. Let's create a new variable as URL is equal to, and then in this. Cool. All right. The next step we need to do is take input from the user. So we're going to say input or word is equal to input in brackets, enter your word. Simple. Do a space. All right. Now what we have to do, let's make our URL up to date. So URL is equal to URL plus word. Then let's get the data. So data is equal to URL lib dot request dot URL open, and then open our URL dot read. So I know I haven't explained much, but I hope we're getting the hang of it. In the first 2 lectures, we did quite a lot of this. So in the third one, I'm just going and telling you how it should be done. So now we have our data. We should now decode our data. So data1 is equal to data.decode. And what do we use? It's UTF-8. Great. So now what we can do, whoops. All right. Now what we have to do is we have to find out what we're going to be searching for. So let's print out our data. So print data1. Missed the bracket, sorry. All right. So Command S. Let's save this as definition. Great, save. And now let's run this. So run module. All right. Enter a word. I'm gonna go with gaudy. It's a random word. All right. Now we get this. So let's see if we can find out the definition. How big is this? Okay, this is pretty big. So instead what I'm gonna do is I'm just gonna go to Chrome, search gaudy and brilliant or excessively showy. So let's search for this. Command C, Command F, Command V, and we found it. There we go. Meta name is equal to description, content equal to, and then we get the definition. Great. Now what we have to do is use our search and get it out. So let's do this. All right. So close this and let's remove this. So close. Oh, not close, sorry. Ideally, definition. There we go. So we'll be searching for meta name description equal to there. So let's just do that. M is equal to re.search, and then in brackets, what are we searching for? Meta name is equal to description, and let's use a single quotes again. My bad, I keep on forgetting that, but you should be able to fix me right now. Description, content equal to, and then we start. Great. So this is what we want to search for. Just this. And what are we searching in? We're going to be searching in data1. So now let's create a line. It'll be m.end should be equal to what? It should be equal to start. That's where we're going to start from. So start should be equal to, m.end, like always. And then our end should be equal to start plus 300. Let's start off big since we never know how long a definition may be. Now all we have to do is create new string is equal to, what is it equal to? It's equal to data1 and then in square brackets start to end. Let's print out new string to see what we get. New string. All right, Command S and run module F5. Enter your word. I'm just gonna go with gaudy again. Brilliantly or excessively showy. All right. I'm not sure why it printed it on that same line, but let's take a look here. All right. So let's get rid of our print data1. We don't need that anymore. So remove this. Command S, Meta name is equal to description, content equal to this. Now, I'm pretty sure it's going to give us errors for this. So I'm going to use a slash here to remove the escape character, make it normal. Or I don't think we even need to use that. So Command S, let's try running it. F5. Enter your word. Gaudi. None type has no attribute end. Start is equal to m.end. It has an error. So let's try fixing that. Let's go back over here. Meta name is equal to description again. Command C. Command F. Command V. Find next. Alright. Content equal to, alright, so this should work. Let's try running this one last time. If not, then we'll have to troubleshoot. F5, gaudy definition, brilliantly or excessively showy gaudy plumage. See more. Awesome. So now we're getting the definition, and now then we're getting a lot more random stuff. So we want to end at the see more. So we don't even want to see the see more. We want to get rid of that. Alright, so let me just make sure it's running properly without that strange message coming up. So F5, enter your word, gaudy. There we go, working perfectly. So let's go back to here. And now we're going to be using the re.search to get, so m is going to be equal to re.search. And then in brackets, we're going to be searching for the see more. So we don't want the see more to come. So see more dot. We're going to be searching in new string. All right. And we want to do m is equal to re.search, see more, new string. So the starting -1. So we don't even want the extra space. So start should be equal to, or in this case, end should be equal to m.start -1. Alright, and let's create a new string. Oh, I'll just call this final, or definition is equal to new string in square brackets 0 to end. Alright, Command S, print definition. We forgot that line. Alright, Command S, F5, does this work? Let's see. Gaudy definition, brilliantly or excessively showy, gaudy plumage. Amazing. So we've now created 3 great programs, applications, whatever you want to call it. But now we've created 3 programs that parse the web. The first one was stocks. We called the stock data. Second one was getting the weather. And the third one is definition. Awesome. Now let's make a few edits to our program. Number 1, let's get rid of the print new string. We don't need that. Number 2, let's try something here. So let's click F5. And I'm going to enter a random word. AST blah blah blah. Click enter. And we get an error. So what we can do now is, if you remember in the previous lectures, we discussed about the try and except. So it was try and except. Basically, in the try part, you could enter your code. If it works, great. But if it doesn't work, then you can have an except part where we can say that an error showed up, please try again. So what we have to do is create a try. So just type try and then colon. Let's put all of this under try. Just hit tab, except for the try. Cool. And if all of this doesn't work, then we need an except case. Except will print, I'm sorry, your word is not in the dictionary. Great. Command S, F5, let's try this now. So I'm going to enter ASD, click enter. Oh wow, ASD is actually a word. So let's run this one more time. F5, enter your word. Let's do ASD, that can't be a word. So I'm sorry, your word is not in the dictionary. Great. So now we've also added a try and except case to our program. Awesome. Now we could have done this for each program, but I forgot to. You can if you want. There's nothing wrong in it. It's quite easy. Just tab your content, put a try, and then put an except case in case your content or in case your code doesn't work. Print, I'm sorry, the value entered doesn't work. Awesome. So we've now created 3 fully functional programs. The first stock, second was weather, and third is definition. Now we'll be moving on to some more fun and complex programming. See you in the next lecture. Alright, so this section and the following few sections are going to be all about advanced Python programming. By now you should have had a very basic introduction to Python. You must have understood, hey, this is how Python works, this is how we do GUI programming, this is how we do some other basics. But by now you should have a very good understanding of the core fundamentals of Python. I mean, if I ask you to give me a list of Fibonacci numbers, you're going to be able to do that. If I tell you, hey, I want you to move this red ball 5 feet up and 5 feet to the right, you can do that, okay? So by now, you're actually a pretty skilled Python programmer. But trust me, there's a lot more to Python that meets the eye. And this is where we go on to the concept of modules, okay? So this lecture, just listen to me. We're not going to do anything. I just want to talk about what's happening. So modules. We talked about the OS module. We've talked about the random module. But what's different between the modules? What's different about the modules that we're gonna be talking about today and the ones that we've used is that the modules we're gonna be talking about today have to be downloaded. Okay, so these modules are external. They're not inbuilt in Python. And by downloading these external modules, we'll be able to do a lot more with Python. All right. So that's pretty much it for this lecture. I just wanted to tell you guys, hey, this is what's going to happen in the following few sections, and let's get started. So in the next lecture, we're going to be talking about pip. See you then. All right. So in the last lecture, I left off saying the word pip. Okay. And you're probably wondering, well, what is this pip? I mean, I don't think I've talked about pip before, but basically what pip is, it allows us to install Python packages or Python modules, okay? And by install, I mean really simply in one line, we can install any package or module that we want. So to verify, you're like, hey, how do I get this pip? This pip seems really cool. And I agree, pip is an amazing tool. And I'll be showing you how we can check to see if we have it. So if you remember, I believe in the beginning of this course, I talked about how the whole course is based on Python 3.4. And in the latest update in Python 3.4, pip is now being packaged with the Python. So you don't have to download any pip externally. There's no need for downloading some random .py file and running it, all that manual trouble. There's no need for that anymore, okay? And it's great. It makes our life a lot more easier. So what I want you to do is go into your Macintosh HD, all right? If you're not sure what that is, just search that up. Or if you're on a Mac at least, I want you to go to your Macintosh HD. For Windows users, stay put. I'll tell you what you need to do. In your Macintosh HD, go to your library. All right. From library, go to frameworks. From frameworks, the Python.framework. From here, versions, and from versions 3.4. That's the version we're using. And then over here, I want you to go to lib. So lib is short form for library. From lib, I want you to go to Python 3.4. And then from Python 3.4, scroll all the way down to site packages. And you're not going to notice pip. Yay. That was complex, huh? Backtrack. So if you're in a Windows, all right, you should probably have a folder somewhere in your machine. Again, it should be in your C drive called Python 34. If you might be using 2.7, I'm not sure why you'd be using that, but you might have a file called Python 27. I want you to go to your Python 34, and then I believe it's the exact same steps. I'm not completely sure, again, since I'm not using a Windows machine. If it's not the same steps, don't worry. Trust me, if you have Python 3.4, that means that you have pip downloaded. So just listen to me as I show Mac users. So now you should be in this folder and it has pip and everything. So this basically means that, hey, we have pip. That's fantastic. So you're probably wondering, well, how do we use this pip? Okay, this is how we're gonna do it. If you're on a Windows machine, it's pretty straightforward. You're gonna do something like pip 3.4 install and then the module name. Okay. If you're in a Mac, however, you have to use the command sudo. So when installing any module with pip, it's done via the command line or the terminal. Okay. And the way this works is you have to specify, well, for a Mac at least, you want to make sure that there's no error for overwriting or stuff. You know, you've bypassed all the security reasons. So you write sudo for that. For Windows, I'm not sure you have to write sudo. Again, I'll double check and I'll probably update this lecture in the future, but for now, just let it go. Sudo, and then you want to type in pip 3.4. So this whole time when I was creating these lectures, I had a lot of trouble with pip. So back in 2.7, there was a completely different concept of doing this. You wouldn't write the pip 3.4. You had to download pip externally, stuff like that. But now it's become a lot more simple. Right now, actually, just go ahead and do this. Instead of writing anything, just type in pip 3.4. All right. And if something returns, okay, as you can see, something has returned, this means that pip has been downloaded to your machine. All right. So if you type in pip 3.4 into your terminal or command line, and if you see this result, then that means that pip is installed. Fantastic. And you can see the commands. All right. Install installs packages, uninstall uninstalls packages, show will show all the installed packages, stuff like that. Yeah. So let's go ahead and understand how to install a simple module. Okay. So this following section is going to be about, or actually this section is going to be about parsing. So we learned about the re module, all right, and that was fantastic. That had some great concepts. We learned how to drill down our data, search for specific keywords and move on from there. However, that was time consuming, all right? You had to search for this, then drill down, add another 200 characters, drill down even further. And at the end of the day, you don't want to do that, right? You want a simple and easy HTML parser, okay? And this is what Beautiful Soup is. So again, the name is a bit intriguing. I mean, Beautiful Soup, what kind of package is that? But the core concept here is that Beautiful Soup will save our day. And it is, I believe, the #1 HTML parser in Python right now. And I'll be teaching you how to use it. So go ahead and type the following line if you're on a Mac. Sudo pip 3.4 Beautiful Soup 4. So Beautiful Soup 4, that's the version name. It's 4.0 right now. So sudo pip 3.4 Beautiful Soup 4 install. Again, if you're in a Windows, I believe, and I'm not completely sure here, I believe it's pip 3.4 Beautiful Soup 4 install. If you have any errors with the Windows, please leave a discussion, and then based on what you guys are saying, I'll definitely update this lecture to fix those issues. However, it should hopefully work. Sudo pip 3.4 Beautiful Soup 4 install. Hit enter and it now asks you what's your password. The reason why it's asking you what your password is because we use a sudo, and what sudo means is bypassing all those security issues. So go ahead, enter your password, and it gives me unknown command Beautiful Soup 4. So let's bring this back down. Let's try this one more time. That's odd, actually. Hit enter. Unknown command. Oh, I'm sorry. I'm terribly sorry. We're actually doing it opposite. Sudo pip 3.4 install and then the module name. Okay. So I'm sorry about that, guys. Bit of a brain freeze there. Sudo pip 3.4 install Beautiful Soup 4. Okay. And again, for the Windows, pip 3.4 install and then the module name. Hit enter, and it gives me some green text. Forget about that. But it says over here, requirement already satisfied. Beautiful Soup in library frameworks, Python frameworks, blah, blah, blah. It's there. Now, if this is your first time downloading it, it should be successfully download Beautiful Soup 4, and that's fantastic. As you can see, I've already downloaded it because, well, I had to test it out in case it does work, and it's telling me that, hey, I've already downloaded it. And you can easily verify, again, going back to the same folder, just see what it's saying. Library, frameworks, Python.framework versions 3.4, lib, Python 3.4 site packages, that's exactly where we were. And as you can see, we have Beautiful Soup installed over here. So again, pretty cool, all right? We basically just installed a Python module. Again, this is our first module that we've installed, so fantastic job. If it worked, awesome. If it didn't, show me a picture of your code or show me a picture of what's happening, and I'll definitely search on Stack Overflow. Again, most of the issues with pip have been solved on Stack Overflow online. So definitely, if you're running into an issue, search it online, and in the end, worst case scenario, if it doesn't work, then I will personally look into your problem. Now, before I end this lecture, let's go ahead and install one more module that we'll require. And the reason why I'm installing this is because it will greatly simplify our lives. So go ahead, Mac Mini. What I want you to do is, again, bring our above code up, okay? So we have sudo pip 3.4 install, and then instead of Beautiful Soup 4, I want you to install requests, okay? So sudo pip 3.4 install requests. Ta-da! And you should now see successfully installed request 2.7. So requests will be the way we're gonna get the HTML of the website. Basically, it's a request to get the website's data, etc., etc. We'll talk about that more in the future lectures. Again, I think I've gone way too long this lecture, so I'm gonna cut it now. But I'll see you in the next lecture. Alright, so in this lecture, we're gonna get started with our Beautiful Soup module, okay? And hopefully you guys have a basic understanding of HTML, alright? Again, what is HTML? Well, HTML is basically code that you use to create websites, to create browsers, stuff like that. And any website you see in today's world has been created in HTML or using HTML and then some other programming languages. So what I want to do today is we're going to be talking about the first function of Beautiful Soup, and that's called Prettify. So what Prettify does is you pass in some HTML code and then it spits it back out, except it's more readable. It fixes any HTML mistakes you have, and it makes life a lot more easier, okay? It's called Prettify, again, and it basically fixes any HTML code you have. So our goal for today is we have this forecast.weather.gov. You don't need the link right now. We'll use the link later. And we have this 87 degrees. So again, we're going to be doing the weather again. You're probably wondering, why the weather? We already did it. Reason is, this is just like a challenge. So as you can see, our weather is being stored in this class, myForecast/current LRG. You actually can't see that because my screen's going off. So there you go. Now you can see it. P class myForecast/current/LRG. If we were using the re module, we'd first get the data, then drill down. So we do something like find class equal to myForecast, blah, blah, blah. Then we find the /p, and then we get 87 degrees. Now, instead of doing all of that drilling down, we're going to be using the Beautiful Soup module, and we'll get the answer, okay? Much faster, much quicker. That's our goal for at least the next 2 or 3 lectures. So I'm going to minimize this, and let's talk about Prettify. First thing first, what is HTML code? Can you write some? Basically, you should now be able to write a simple HTML doc. Again, you need the HTML tags, you need the header tags, title tags, body tags, p tags, a tags, whatever you want. Just write an HTML script. And the way I want you to write this is say soup is equal to beautiful. I'm sorry. I forgot to import BS4 first. So go ahead and write from BS4 import Beautiful Soup. Okay, and you could have just done from BS4 import asterisk or whatever you want, but we only need Beautiful Soup for now, so that's fine. From BS4 import Beautiful Soup, that gives us all the commands. Go ahead and now type soup is equal to Beautiful Soup, and then in brackets, it takes in 2 parameters. The first parameter is your HTML code. All right. This code, again, we'll be getting it from our website, but for now, just go ahead and type in some random code. What I'm going to be doing is I'll be typing some very interesting code. And if you do know HTML, you're going to notice some mistakes. Again, please, just note them. Don't say anything about them. We'll get to them later on. Okay. And I'm purposely doing mistakes for a reason, because I want to show you guys how the prettify function works. For you guys, you can put mistakes, you cannot put mistakes, doesn't really matter. I'm just writing some random HTML code. Alright, and let's go ahead and put in an A there. No href, we don't need href for now. Hello, and then close. So as you can see, this is some horrible HTML. We've opened and closed the HTML tags, but we haven't closed any of the other tags, right? So now if you run this, well, nothing happens except it gives us an error saying we haven't added our HTML parser, okay? It's giving you a warning basically. It's saying that specify your code to include the HTML parser so that, you know, Beautiful Soup knows that we're parsing HTML and not anything else. So go ahead and as a second parameter, put in HTML.parser. So hit enter and now let's work, and go ahead and call soup.prettify and take a look. So this works, but it's confusing. So print out soup.prettify. We got the results we wanted, but it's not looking good. So take a look now. What's happening? Let's take a look. So we had our HTML P and then ASD. We still have that. We got our strong tag, we still have that. We have our hello over here, we still have that. And then we have our A tag and hello, we still have that. But as you can see, soup or the prettify function has now added this slash A, the slash strong, and then the slash P to fix up our HTML code. Okay, so if you now type in soup, see, as you can see, the tags have now been added. So it's actually quite neat. I mean, if you're ever writing some HTML code and you're way too lazy to add the tags, just go ahead, open up your Python, import Beautiful Soup, and call the function soup.prettify. Pretty neat, right? So awesome job, guys. In this lecture, I just wanted to talk about the soup.prettify function. Again, that's something basic, something that we're probably not going to be using, but it's always good to have a base to where we get started. Now, in the next lecture, I'll talk about how we can parse, or at least some basic parsing with our Beautiful Soup module. Alright, so today we're going to be talking about actually parsing with the Beautiful Soup module. And it's going to be a lot of fun. So the concept I want you to get is the concept of navigating a tree, okay? And the way this works is you keep on branching down. So I'm pretty sure you might have used Reddit, okay? You might have, you might not have, that's fine. But the whole concept of Reddit is you have Reddit and then subreddits, and then you can keep on branching down. The same way a URL works. You write facebook.com and then you say facebook.com/user and then maybe facebook.com/user/pictures. So you keep on drilling down into a website. The same way we're going to drill down into our HTML code, except in one line. Okay, that's the key difference between what we're doing and what the remodule did. With the remodule, we had to search, it took effort, it took time. This is lickety split fast. So let's get started. There's just some code, okay? HTML/doc, the dormouse's story, blah, blah, blah. And we're gonna be parsing this code. Again, I'll give you a lecture, I'm pretty sure. I'll add a lecture probably in the previous, take a look at the previous lecture, I think. I might have added a HTML file there, or maybe in the download section, but you're going to require this code, okay? And no, I'm not going to make you write it. I'll provide it somewhere. I'll tell you where. So this is our HTML doc. We have these 3 quotation marks, and if you remember back in the commenting section, what do those 3 quotation marks mean? Basically, it allows us to write multi-line statements, okay? So this is some fantastic HTML. There's nothing wrong except it's ugly. It's horribly ugly and I don't like it. So the first thing we have to do is import BS4. So from BS4, import Beautiful Soup. Okay, now we've done that. So the second thing is, if you remember, we have to create our soup. So soup is equal to Beautiful Soup. And like I talked about last lecture, the first parameter is your HTML. So we're going to put over here HTML doc. And our second parameter is, hey, what are you parsing? Well, we're doing an HTML parser. So HTML parser. Hit enter. Ta-da, we have our soup. So soup gives us this. Soup is this nice looking or horribly looking HTML. So obviously, we gotta prettify. So we've prettified this, and now if we print out soup.prettify, I mean, it actually looks pretty nice now, right? It's not that confusing, it makes sense, and it looks good, right? So taking a look at this, I don't think we actually require our comma over here and our semicolon over here. That's just something I'm taking a look at with my code. So I'm gonna reinitialize my HTML doc and delete that because we actually don't need that. Or actually, no, I see why. Nothing. Never mind. It's part of the English sentence. Cool. So we got our HTML code. All right. We have our HTML head. We have our title. We have our body. We have our whole A tags. These are anchor tags. If you don't know, these anchor tags are links. And our goal is today navigating. So understanding how can I access each part of this HTML doc. Let's get started. First thing first, tags. So always a beautiful soup, you can always navigate any HTML doc using tags. And if you're wondering how, the concept is quite simple. For example, if I want to find out, hey, what's the code I've written in the title of my doc? I do something like soup.title. So as you can see, it's returned me title, the Dormouse's story / title. So that's exactly what I wanted, right? I searched for the title tag, I got that. What if I search for soup.head, if I want to get the header tag? That returns me basically the exact same thing as above, except with the header tag. Cool. What if I wanted, maybe the body? What's in my body? So soup.body, and I can get whatever is in my body tag. So I think you're slowly understanding, hey, this is how Beautiful Soup works. What you can do is you can drill down by accessing these tags, right? Soup.title returns me the title of the doc. And you might be thinking now, can I drill down even further? Absolutely. So if you're wondering, well, looking at this, I want to get, let's see over here. Give me a sec. I want to get this bold text, okay? So this B tag over here means it's bold. If I want to say, hey, what's the bold text in my body? I can say soup.body, and then, soup.body, and then I use the B tag. So again, it's a whole concept of tags, subtags, and then, it continues. Subtags, subtags, and so on. So soup.body.b returns me all the bold tags in the body of my soup. So the Dormouse's story. All right. Using a tag name as an attribute will give you only the first tag by that name. All right. What that means is, for example, if I say soup.body.a, what do I get? I get the first link or the first A. I get Elsie. I don't get Lacey. I don't get Tilly. I'm only going to get Elsie. Why is that? Well, that's how it works. That's how it works. So if you call, if you're drilling down, if you call even soup.a, what does soup.a return us? It returns us the first link, okay? It won't return you all of them. So if you need to get all the A tags or something even more complicated, what if you want to get all the P tags, all the W, it's not even W tag, but all of X kind of tags? Then what you do is you call the find all function. I believe we might have talked about this in the remodule, but find all basically returns you all the circumstances where A can be found. So as you can see, it has returned us an array with all three of our A tags. Isn't that cool? So you can say maybe array is equal to soup.findAll A, and then you can say array 0, array 1, and array 2. So by doing so, what we've done is we've gotten all the links or all the A tags in our body, and then we've put that into an array, and we can access each one of them individually. So I think by now, you're slowly understanding, hey, Beautiful Soup is actually really powerful. So instead of all that, cut and paste, trying to find how many characters ahead, characters behind, cutting sentences, stuff like that, all we have to do is drill down into our HTML code using tags, using specific search terms, stuff like that. Now, if you have any questions on this HTML code, what I'm doing, what's happening, please leave a comment, leave a question. Again, we're now on the advanced section, so definitely some things might not be too clear to you, and that's why I'm always there to help. So I'll see you in the next lecture, and have a fantastic day. Alright, so in this lecture, we're going to be talking about the concept of .content, .children, .descendants, okay? So first thing first, get your HTML doc in there, and then go ahead and import BS4, from BS4, import beautiful soup, okay? And then, you know what we have to do, go ahead and say soup is equal to beautiful soup, and then we say over here, HTML doc, comma, HTML dot parser. Okay, cool. So we got our soup now, and you can take a look, we have our soup. So the first concept I want to talk about is the .contents. And what the .contents function does is it returns everything that's there inside of your tag. For example, I'm going to call this my head tag. Head tag is equal to soup.head. So if I print out my head tag, I'm going to get head title, the Dormouse story, /title/head. Now, if I say head tag dot contents, I get whatever's inside the first tag. So when I say soup.head, I get the head portion. So everything that's in from head to /head. The head tag dot contents basically drills down one step further. So it gives me everything inside of head, leaving out the /head and the head. So it's pretty neat when you want to get basically the contents of a specific tag. Now, the second function I'm going to talk about is the child. So what we can do is, for example, if I want to get every single object in my body, for example, I have this P over here, I have this next big P tag over here, and then I have this P tag over here. If I want to get each one separately, I use maybe the children's function. So what I can do is, first of all, let's go ahead and create one called body tag. Set this equal to soup.body. Okay, and then I can say for I in body tag, for I in bodies tag dot children, print I. So by doing that, I get each of my objects inside of the body tag separately. So each one of these P and P tags are child of the body tag, okay? For example, if I had a simple, a body tag, and I had one paragraph, an anchor tag, and another paragraph, that would mean I have these three children inside of my body, okay? But right now, you're probably noticing, well, hey, there's also this B tag. There's also this href. There's this text over here. Why isn't it giving it out separately? So the reason for this is the child only goes down directly. Right now, this P tag is a direct child of my body tag. However, this B tag is part of the paragraph tag. It's not part of the body tag. That's why it's not being printed out separately. That's where the descendants come in, okay? So this is our third function, descendants. What descendants does is it goes through every single tag no matter what. So it's gonna give me the P tag, then the B tag, then the text, and it's gonna be pretty cool. So let's go ahead and bring this down. So for I in body underscore tag dot children, instead of children, change this to descendants, okay? If you enter, you get this. So like I said, we have our P over here, then we get the B, and then we get the text. So each individual piece of tag or each individual tag is now separate, okay? So instead of the child function in which it was direct, so from body, whichever tag was next inside of the body, that would be printed out. Descendants goes through every single tag. So again, pretty neat, right? Cool. So in this lecture, we covered quite a lot. We talked about the dot children, the dot contents, and the dot descendant. The dot contents returns you basically everything inside of the tag. No strings attached, nothing like that. Basically everything. The dot children returns you the direct tags. So if I have a body and I have maybe an image source, I have a p tag. Inside of the p tag, I have some text. And maybe I have an anchor tag, the dot children will return me each one of those tags, not the content inside of it. However, with the dot descendants, it returns me each one separately. So it goes through the p tag. It then notices, hey, there's also a tag inside of the b tag. So it gives me this, and then it realizes, hey, there's some text inside of the b tag. So it returns me the text. So the dot descendants is pretty neat when you're trying to drill down fast. You know, you don't want to type all that dot p, dot b, and then the dot text. What you can do is basically use the descendants and get the information you need. Cool. So awesome job, guys, and I'll see you in the next lecture. Alright, so in the last lecture we left off where we talked about the dot children, the dot descendants, and then the dot contents. So there's a few more concepts that again I want to talk about. It won't take too much of your time, okay? So the first one is going to be our dot string function, okay? So the dot string function basically says that, hey, if you have a tag and the tag's only child is text, then the dot string function is going to return you whatever text is there, okay? So let's go ahead and again, we're using the same example. So to make things clear, let me create the head tag again. Head tag is equal to soup.head, okay? And we know that head tag dot title, does that return us anything? Yes. The head tag dot title is this, the dormouse's story, okay? I mean, in the title text. So if we say head tag dot title dot string, we get the dormouse's story. Basically what I'm trying to say is, if you have a tag, okay, and the tag's child, okay, we've talked about the child in the previous lecture. If the tag's child is this text, then the dot string function will return you whatever text is inside of the tag. Now another key thing you want to know. If we print out the head tag right now, we get head title, the dormouse's story slash title slash head, right? Now, another thing that works with the dot string function is that if you have a tag and the tag's child is another tag, and then that tag's child is text, then the parent tag, which is our head, that's dot string is going to return you this. Again, it's a bit confusing. With practice, you'll slowly understand. But basically, if you say head tag dot string, you get the dormouse's story. The reason for that is because the head's only child is title, and the title's only child is the text. So basically, the heads can correlate to the dormouse's story, and by calling head tag dot string, you get the dormouse's story. Okay, so this was the dot string function. And quickly, let's go ahead and talk about the dot parent function. The way the dot parent function works is it goes one up instead of going one down. For example, if I say head tag dot title dot parent, I get the whole thing, right? If I say head tag dot parent, I'm gonna get what was before the head. If I say soup dot parent, I don't really get anything. That's fine. If I say beautiful soup dot parent, do I get something over here? No, you can't really call parent on beautiful soup. So the way the parent function works is instead of going one down, instead of drilling down, you're going up. So let's say I was at the dormouse's story, right? How are we getting the dormouse's story? Head, or actually, you know what? Let's just go back to head tag dot string. Now if I call parent over here, I get whatever was before the dormouse's story. So we knew the text was head tag dot string. What was before head tag dot string? It was the title tags. So again, a short lecture. I covered two concepts here. The dot string. The dot string again returns you the text if it's, you know, right there, or if it's one tag ahead. and the dot parent, where instead of going down, you're moving up. So you can basically see, hey, where was this tag inside of? Again, some pretty interesting concepts, and I'll see you in the next lecture. Alright, so if you haven't realized by now, you're probably thinking, oh my god, Beautiful Soup is vast. And trust me, that's true. There are tons of ways you can filter down through that tree. There's concepts like siblings, next elements, previous elements, going back and forth, stuff like that. Except I won't be covering everything because, there are things that you don't really need to know, things that are way too complicated. So I'll stick with, stuff that we've already covered. So the next concept and the next item in the list of Beautiful Soup is searching, okay? So how do we search through this module? By now we have learned that, hey, we can drill down stuff like that, except why even drill down? Why not directly search and find for the specific HTML tag we're looking for, right? It's gonna save us a ton of time and we don't have to drill down. So this is the concept of filtering, right? So the find all. I think we've talked about it in a previous lecture, but let's go ahead and cover some use cases with the find all function. So the first one, again, would be soup.findAll, and then you pass in what do you want to find. So let's say I want to find all the p tags. Okay, hit enter, you get all these different p tags, right? So this p tag over here, this p tag over here, and another one over here. We have 3 p tags, right? And it returned us an array in which we can iterate through that. That's pretty cool. Let's go ahead and try one more. Soup.findAll. Let's do a tags. What do we get? We have a class sister, ID link 1, a class sister, ID link 2, and ID link 3. So pretty neat. Now let's say I told you, hey, I don't want you to find me all these different A tags. I want you to find me the one which has the ID of link 2. Okay? And you're like, okay, sure, that makes sense. How do I do that? Well, what you can do is you can easily say soup.findAll, and then you can pass in the parameter ID is equal to whatever the ID was. So our ID, let's say we're searching for link 2, right? All we have to do is say ID is equal to link 2. And we get empty. That's because I made a mistake here. It's actually supposed to be, you're not supposed to put ID and the equal sign in the quotation marks. So ID is equal to link 2. If you hit enter, we get, ta-da, the link 2. Now let's say you had a p tag which had the ID of link 2. So you had a paragraph which had the ID of a link 2, and you had an anchor tag which had the ID of a link 2. And I told you, I don't want any paragraph tags, I only want the anchor tag. So the way you can do that is using our function up top, ID is equal to link 2, and you're searching for an A tag, okay? So A comma ID is equal to link 2, and what does that do? It returns us the only match which has an anchor tag and the ID of link 2. So by now I think you're realizing, hey, there are a lot of different ways to search in the Beautiful Soup module. Now, other things you can do, suppose we want to find all the tags that start with B, okay? To do that, we need to import the re module again. And the way this is going to work is, let's say, right, so all the tags that start with B. So for tag in soup.findAll, and now we're going to use a re function here, re.compile. And basically what re.compile does is searches for everything that starts with B. To do that, re.compile the arrow key, the alligator mark, and B. So for tag in soup.findAll re.compile B, all we have to do now is just say print tag.name. Okay? Put that in quotation marks, not quotation marks, but brackets, and hit enter. What happens? We get body and B. So take a look at how this code worked. For tag in soup.findAll, again, it's going to search through the whole Beautiful Soup. We're searching for any sentences, or we're compiling through that whole document to search for anything that starts with the letter B. So this signifies that we're searching for the starting of B, okay? And then all we're doing is we're printing the tag.name. We got body and we got B. So pretty cool, right? Now, let's say you wanted to search for anything that had the letter T in it, okay? So go ahead and bring this down. And if you want to search for any tag which starts or has the letter T, what you do is you remove the alligator sign and you just type in T. So for tag in soup.findAll, v.compile T, print tag.name, hit enter, we get HTML and title. As you can see, the T in HTML is in the middle, whereas the two T's in title are in the beginning and the middle. So it basically searches for any word which has the letter T in it. Okay, so again, there are many different ways that you can search through a Beautiful Soup document, right? We've talked about a few. Let's go ahead and cover maybe one or two more. Again, like we have done before, let's say you want to search for the title, right? So soup.findAll, and then you can just search for the title. So again, a very simple usage like we've talked about. You can get the title as well. Again, let's see. So we've learned about searching via an ID. You can search via a class again. So soup.findAll. Let's say I want to get the class equal to sister. Okay, hit enter. Does that work? No, it doesn't. So I guess you can only search by ID. You can also search by href. So soup.findAll. Over here, you can say href is equal to re.compile, and let's say we want to search for LC. Okay, hit enter. There we go. We get the first one. A class is equal to sister. href is equal to blah 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 / LC. Okay, and you can also then specify the ID as well. So you can say soup.findAll this, and then comma ID is equal to link1. So that will completely make sure that it's the first A. Okay, so I'm gonna end this lecture here. Again, there's quite a lot of ways you can search through a Beautiful Soup module. Let's go ahead and recap. We learned about the findAll function. We learned how to search with IDs. We can specify what the ID is equal to. We learned about the re.compile function that searches through the whole document for either a word or a sentence starting with the letter B. And then we can search the whole document for any word that starts with the letter T. Okay, actually, you know what? Let's go ahead and bring this down. Bring this down. And instead of saying print tag.name, let's go ahead and print out tag and see what happens. If you hit enter, it returns you the whole thing. And why is that? Because the body. Okay. I'm sorry, guys. So take a look at this. We did for tag in soup.findAll, re.compile, and then the uppercase B. And what that did is we got the whole tag. Okay, I'm sorry, it wasn't the specific word. Tag.name gave us the specific word, but by calling this re.compile uppercase B, we can get the entire tag. So if we did re.compile body, we would get the body tag, stuff like that. But anyways, awesome job. We talked about using the href as well, so we can search for specific things in the link. And again, we did another example of ID. So awesome job, guys. This again was a quick way or quick ways to search through a Beautiful Soup document and get the specific things you require. I think by now you should have a good idea of this is how Beautiful Soup module works. This is how I search through it. This is how I drill down. And I think we're ready to drill down now or actually get some information out. So in the next lecture, we'll work with a weather website. I know we've already done weather in the re-module, but let's go ahead and do it again and see if we can get the data that we require. See you in the next lecture. Alright, so in this lecture, we're actually going to use all the knowledge that we've talked about with the Beautiful Soup module, and we're going to be putting it to use, okay? So first thing first, like I talked about in the previous lecture, we're going to be parsing for weather again. But instead of that simple HTML website that we had parsed in the re-module, we're actually going to be parsing some complex websites. So, this is all, a lot of CSS, a lot of JS and stuff. So it's going to be a lot more interesting. First thing first, we have to find out what we're searching for, okay? I mean, we have to search to find out, hey, where is this weather going to be? So the website I'm using is accuweather.com. Basically, all you have to do is go to www.accuweather.com, okay? and it gives you all of this stuff. And currently I'm in San Jose, so go ahead, put your location wherever you are. If you're in maybe Florida, maybe Miami, you're gonna put in Miami. And once it does, it's gonna say, hey, is it this one? Yeah, it is. And you should be on this screen, okay? Obviously, I'm gonna go back to my normal San Jose one, but you should now see this main screen, okay? Again, AccuWeather, A-C-C-U, weather.com. Go ahead, search for your location, and then you should see the screen. Then what I want you to do is right-click and view page source. Once you do that, you're taken to this page. And this is basically the HTML, CSS, whatever code that was there to create the website. Again, we talked about this in the remodule. So we're going to be doing the same searching as we did in the previous section or whenever the remodule was. Go ahead and search for 93. All right, so we have this 93. Nope, that's not the one. No. So there's going to be the one, this one, I think, yes. So div class info, span class cond, sunny, and then strong class temp, 93, the degree symbol, and then some other random stuff. Okay, so this is the div class that we're going to be parsing for. All right, so take a look, guys. Make sure you know what you're searching for. Awesome. Let's get to the coding part. I'm opening up my IDLE right now. It might take me a few seconds, but here it comes. Give it a few moments. All right, and whoops, and like I talked about, I think in the section where we were downloading pip and stuff. For this, we're going to be using a module called requests, okay? And you're probably wondering, why are we using this module? What's the purpose? Well, what requests enable us to do is we can get all this HTML content, right? Without using that URL lib, .read, .open, all that stuff we don't need anymore. What we're going to be doing is using the request module. In one line, we'll get all this HTML and CSS and whatever there is. So going back to my IDLE, this should be readable for you. Go ahead and import requests. If you don't have requests imported, again, I believe while I was importing Beautiful Soup, I did import requests as well. If you don't know how, go ahead and over here, just search for request module or just do pip install requests. I'll save you a lot of time. Okay, import requests. The second I want to do is from BS4 import everything. Okay, so import request from BS4 import everything. Now what I want to do is say data is equal to requests dot get and then command V. So I forgot the quotation marks. Okay, so basically what you want to do is you want to say data, this is your variable name, is equal to request.get. This is a function which basically gets you all the HTML from the website and the website name. Again, just go ahead, copy paste whatever's there. Okay, back over here. And you can try printing out data, but trust me, because I'm running Camtasia and everything, my computer is a bit slow. When I printed out data, IDLE kept on crashing for me. So you can try it out, but it's probably gonna crash, so just stick with me here. Now, it's gonna be the simple or the same Beautiful Soup functions that we've been using throughout the course. I mean, here's a challenge actually. If you can do it by yourself, take a look at where it is. You might need a little help with the class parsing, but if you can get this 93 degrees by yourself, that would be amazing. Take it as a challenge. Pause the video here if you want to, but there's one key thing that I haven't talked about that you might want to listen to. So if you did, fantastic. If you're still listening and you want to continue with me as I do this, that sounds good as well. So let's call our soup again. Soup is equal to data, or I'm sorry, it's Beautiful Soup, and then we use the normal things, except here, look, we have our data, okay? And what I want you to do is go ahead and command X this, or never mind, just delete this. If you print out data right now, you get this response 200. And right now, it makes no sense to us, right? You might have tried printing out data, but you're not getting anything, you're getting response 200. So to get the actual text of the data, it's data.text. Again, don't try it out because it will make your IDLE either crash or go super slow. So now it's going to be the same thing like I was typing. Soup is equal to Beautiful Soup. Then over here we have data.text as our HTML, and then specify HTML.parser, that we're parsing HTML. So there we go, we have our soup. again, if you print out your soup, your IDLE is going to crash most likely. If it doesn't, good job. If it does, I told you so. So the next thing is we want to start drilling down, okay? Taking a look at this, what do we have? We have the span class cond. I actually don't think it was this. It was something else. Wait. Taking a look over here. Let me see. Something's wrong here. Wait. Yeah, it was this. The one that had div class info. So if you remember the previous lecture, I was a little unsure on how to search with classes, right? I did ID is equal to this, that worked. However, when I tried doing class is equal to something, it didn't work. So in this lecture, I'm going to fix that. I actually went online and found out how to search via class, and I'll be showing it to you right now. Opening up your IDLE, the way you want to search is, first thing first, we're searching for a div, okay? So soup.find, and what the find function does is it only returns the first instance, okay? If you do find all will return you an array with all the instances. Soup.find will return you the first and foremost instance. So it's good if you only have one instance. That way you don't have to, get the index position in your array and then get the value out there. Soup.find, and then over here, first thing first, it's a div. Okay, if we did soup.find div, we're gonna get the first div tag, which is this. But that's no use to us. We want to get the correct div tag. So soup.find div, and then what's our second parameter? Well, our second parameter over here is going to be our class. And the way this works is we want to type, curly brackets or braces, then class in quotation marks, a colon, and then the class name, okay? So taking a look at this, what's our class name? Div class info. So class is equal to info. That's basically all we have to say. Going back to IDLE, div, comma, and then in curly braces, class, colon, info. Okay, hit enter, and ta-da, we get div class is equal to info, span class cond, and then we have our 93 over here, which at the end of the day, we want to parse, okay? So what I want to do now is go ahead and save this as a variable. So I'm going to call this data2, okay? Data2 is equal to that. Now we have this line, all right? And I think there are many different ways where you could parse through this. But one simple way is we're just going to search for the strong class is equal to temp. So the exact same way we search for the div class is info, we want to do class is temp. So go ahead and do that. Data3, I guess you could say, is equal to data2 dot find, and then over here, what are we searching for? We're searching for a tag which is strong, and then the class involved over here is actually going to be our temp class, okay? So temp. So hit enter, and now if we print out data3, we get strong class temp, 93, span strong. So pretty cool, right? Now, I think 2 lectures ago, we talked about the dot contents, okay? If you do data3 dot contents, you get 93 comma span degree span. So we're almost there. Again, we got this line, right? Strong class is equal to temp, 93 span slash strong. And you know that if we do data3.contents, we're gonna get whatever's inside the tag. So from 93 span degree span, which is exactly what we got. Now it did treat 93 and span differently, which is what we wanted. And then what you can do is say data3.contents 0. So that'll give us the 93. So awesome job, guys. In this lecture, we utilized all our beautiful soup knowledge and we parsed a pretty complex HTML page and got the weather, okay? So looks like, I mean, you got the main concept now. This is exactly how all our parsing lessons are gonna go. I'll do one more. I'm not sure how many I have planned. I haven't actually thought this out yet. But I think I'll do one more parsing in which we'll, again, parse another website for new data. If you want to do a quick recap, let's go ahead and do that. We use the request function to get the HTML code of our website. We then use data.text to get the actual text of the website and created a soup out of it. We first searched for div and we realized, hey, you can get the div. We searched for the specific class, which was info, and got the div info class. Then we drilled down further and further using soup.find, data2.find, using these find functions until we finally got this. And then using our contents function, we were able to drill down and we got data3.contents. The 0th position is 93. So awesome job, guys, and I'll see you in the next lecture. Alright, so this might be the final lecture in our Beautiful Soup series, and basically I just want to give you some practice. So by now you should have understood how Beautiful Soup works. You can now parse through an HTML document. You know everything that you need to know about the Beautiful Soup module. So again, this lecture is just going to be some practice, and I thought about doing stocks, but since we already did stocks in the module, we're just going to stick with something basic like antonyms, okay? The way this is going to work is I went to this site, let me bring this up over here, synonym.com/antonyms. Again, it's synonym.com/antonyms, and then basically I search for an antonym. For example, if I search maybe what's an adjective? Cold, I guess. I mean, doesn't really matter here. And then I get all these results. So let me minimize this so that you can see it. I get baking, baking hot, blistering, calorific, heatable, scorching, stuff like that. So if I view page source and if I search, Command F, if I search for blistering, as you can see, all of these words are in the span class is equal to equals. If you go ahead and search for this, let's see how many occurrences there are and where are the occurrences. You can see that the first occurrence of this is actually where we need it to be. So if you want to get baking and baking hot, all we have to do is search for span class equal to equals. So, I'm sorry. Excuse me there. Basically, all I want you to do is get this HTML document, search for span class is equal to equals, and then get whatever text is there. And this is going to be a challenge actually. It's actually very, very simple. Go ahead, try this out yourself. So again, all you have to do is go to synonym.com/antonyms, search for an antonym, and then I want you to get search for a word, and then get the antonyms of that word. Okay, so again, you're going to be searching for span, class is equal to equals. Not too difficult, it's probably max 3 or 4 lines, but go ahead, give it a go. Alright, so if you managed that, fantastic. Again, I'll be quickly doing it myself. So import requests, import from VS4, import Beautiful Soup. I'm not sure what that was. Beautiful Soup. Again, request enables us to get the HTML data. So data is equal to request.get and then the link. So going back to my Chrome, go ahead and copy this. Command C. Get this over here. Command V. Okay. There we go. We have now soup is equal to beautiful soup. Go ahead, pass in data.text, comma, HTML.parser, okay? And now what I want you to do is, well, let's take a look. So we have from BS4, blah, 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 okay? Now we have to drill down. So again, this is a very, very simple process actually. We're gonna be just saying soup, let's store this actually. So data1 or data2 is equal to soup.find, and we are searching for, I believe it was a span. No, I don't think so. Let's check. Where did it go? Let me open this up. Nope. No. I'm sorry, guys. Let me bring this over here. Looks like I got closed. I'm not sure why. Let me minimize. Okay. So find again. Go back to cold because that was the link we used. And then search for blistering. Okay, so we're searching for span and whose class is equal to equals. Again, that might be a bit confusing, but basically we need to search for the span tag. So go ahead, put span over here, and then use what I taught in the last lecture, curly braces, oops, I'm sorry, class, and then colon, equals, right? Yes. So go ahead and enter and now print out data 2 and we should hopefully see baking, comma, baking hot. Awesome. So I think it's pretty simple from here. Let's go ahead and print out data2.string. Does that give us something? Exactly. Data2.string returns us the text of our, the tag. Again, you could have done something like data2.contents. Contents, I believe, should have worked over here as well, except it would have returned us in an array. Anyways, we got the job done, baking, baking hot. So I have a quick challenge for you. Basically, all I want you to do is we're going to be using files in this as well. I won't be doing this, but here's a quick challenge. What you're going to be doing is you're going to ask for an input from the user. The user will input any word, okay? And what you're going to do is you're going to run this program, but instead of using the find function, you're going to use find all. And you're going to get all the antonyms of the word that the user inputs, okay? And then what I want you to do is once you have all the antonyms, upload all of those antonyms to a file and call that file antonyms.txt. Again, if you're not sure how to do that, please do check out the file input and output section. That will clear things up for you and how we can create a file, how we can append and write to a file, stuff like that. Again, let me repeat what I want to do. I want you guys to, first of all, take input from the user, get the word that he's looking for, then get all the antonyms. Again, the way you're going to do that is using the find all function instead of the find. And once you do that, store all of the antonyms inside of a file. Anyways, this is going to be it for Beautiful Soup. I hope you've had a fantastic time parsing through HTML documents. Hopefully by now you can see how much more simple it is from the V module, okay? A lot more simple, a lot more easy. Again, if you have any questions whatsoever on how Beautiful Soup works, any questions on how does a find all work, how is, anything we've talked about, .contents, .children, .parents, how are we drilling down each document? If you have any questions whatsoever, please do leave something in the discussions forum and I'll get back to you again as soon as I can. Alright, so this is going to be it from my side and I'll see you in the next section. Alright, welcome to this section on matplotlib, okay? And first thing first, before I even get on with this lecture, I just want to talk about what matplotlib is. So this module that Python's created, basically what it does is it's used to create graphs and charts. And by graphs and charts, if you ever did those in 8th grade, maybe 9th grade, you know that there may be line charts, there are bar graphs, there are pie charts, scatter plots, stuff like that, right? And these graphs can be used anywhere in your Python program and they're quite useful. So to create them, we're going to be using the module matplotlib, alright? Now there is quite a lot of material in the matplotlib module. Again, it goes into advanced trigonometry and stuff while creating those sin cos lines, but for now we'll just talk about some basic charts and basic plots, and by the end of the section, the goal is for you to have fully understood how you can use the matplotlib for whatever purpose you might have, okay? So first thing first, as you can see, I have my terminal open. Again, you should have the same thing open as well because if you're thinking what I'm thinking, we have to download the matplotlib first of all, okay? So what I want you to do is go ahead and open your terminal or open, I believe, I'm not sure what it's called in Windows, BrainFuse over here. But go ahead and open it, and just like we installed Beautiful Soup, I want you to install matplotlib. However, you're not going to be installing matplotlib. Actually, you're going to be installing something called Pylab, okay? So go ahead and you know what to do. Pip install Pylab. If this gives you an error, try using sudo. I'm just going to use the normal pip install Pylab, and it's going to say for me that it's already been installed. So it already says requirement already satisfied, blah blah blah. But as you can see, there's a lot. There's Pylab, Panda, Seaboard, NumPy, IPython. IPythons are basically a framework in which you can write Python itself. There's matplotlib. This is the one we're going to be using. There's Tornado, PySMQ, JSON schema. So basically, when you do import this, you're gonna see a lot of files you're gonna be seeing a lot of files that are downloading. Okay, so don't worry about that. It's gonna take its own grand time. Took me about 2 or 3 minutes, but as soon as it's downloaded, you should see, yay, it succeeded. And to try it out, just go ahead, open up your IDLE. Whoops, let me open up my IDLE. And then over here, if you try importing Pylab or importing something from Pylab, like importing matplotlib, it should work. Okay, so let's go ahead and try it out. Import matplotlib, and it worked. Okay, so in this lecture, I'm not going to be showing you, hey, how to use this this module, but I just want to show you how you can download it. Again, installing pip and what's going to happen. So awesome job, guys. In this lecture, we just covered how to install Pylab or matplotlib, and in the next few lectures, I'm not sure how many we're going to create, but we'll learn how to create some awesome looking graphs. See you then. Alright, so in this lecture, we're going to be creating a very simple plot graph, and I just want to show you how things happen in this module, and it's going to be very simple, very easy, and it shouldn't take up too much time. So first thing first, what I want to do is import something a bit more specific. So import matplotlib.pyplot as, let's call it as PT, okay? So it's happened, and basically all we did is we called this function matplotlib.pyplot as PT. It's sort of, simple English. So instead of writing this whole big function, all we're just now saying is PT. So the function you want to write here is pt.plot, okay? And pt.plot, since we're creating a very simple line graph, will take x and y values. So if you know how a graph works, if you've ever dealt with graphs in your life before, let me go ahead and show you what I'm talking about. So let me open Paintbrush. Give me a sec over here. Okay, here we have it. And let me just go ahead and bring this onto your screen. So 300 by 300, that's good. Okay. So a Cartesian plane, all right? Cartesian plane looks something like, I should use straight lines actually. Let me get the toolbox. Where's my toolbox? One sec, guys, sorry about that. Okay, here we have. So a Cartesian plane looks something like this, okay? If this is your first time dealing with graphs, not to worry. Again, it's just something quite simple. This is a graph, okay? There are 4 quarters, 4 panes. You call each pane 1, 2, 3, and 4. I know it's a bit odd, but that's how it works. This is the y-axis. Y is vertical, and x is horizontal. So I believe we did deal a little bit with this in our Tkinter, but for now, this is fine. So take a look, guys. This is the y, this is the x, this is positive x, this is negative x, and this is positive y, this is negative y, okay? This is your Cartesian plane. So when I say plot points, by that I mean, suppose I told you, hey, I want to make a point right here. If you make a point right here, I need to know the x and the y coordinates. So this might be 1, and this might be, let's say this is 1, then this is 2, okay? So the coordinate of this point is 1, 2. Okay, let's do one more. Let's say I made one more point over here. So that might be 2, 3, 4. Again, it's not totally correct, but that's fine. 3, 4, 5, 6, 7. So this might be 4, 7. Now what you can also do is you can go negative. You might say a point over here. This might be negative 3, negative 1, whatever you want to do. But this is the whole concept of graphing. Plotting points, connecting the lines, stuff like that. So when we're plotting a graph, let's do a simple one. Taking a look back here, we'll use the x coordinate to be 1, 2, 3, 4. Okay? 1, 2, 3, oh, I'm sorry. It's going to be 1, 2, 3, 4. And then you specify the y coordinates. So our first point, let's say, is 1, 3, okay? Our second point is going to be 2, 8. Our third point is going to be 3, 10. And our fourth point is going to be 4, 25, okay? Some big numbers, but hopefully you understand what's happening. Sorry, I wasn't supposed to save that. I was actually supposed to run that. But hopefully you're slowly understanding maybe how this graph concept works. Again, it's not too complicated, but it sure isn't that easy. If you are getting it, that's fantastic. So we have one more line to go, and that line is actually going to be pt.save or pt.show. And immediately, as you can see, we have our figure popping up. So guys, this is how you're gonna view all your graphs from now on. As you can see, here are points 1, 3, 2, 8, 3, I believe it was 10, 4, 25. As you can see, this huge line gap. So awesome job. We have created our first graph. This is huge if you're getting this far. Right now at the bottom of my screen, you can't see these icons, but in the next lecture, I'll go ahead and slowly discuss what these icons do and how this graphic interface works. Okay, so see you in the next lecture. Alright, so in the previous lecture we created a very interesting looking graph, okay? And it's very basic. It took us 2 or 3 lines of code, but it works, alright? And by now I think you're slowly getting the hang of, so we're gonna plot points and we're gonna create the graph. You know, that slowly you're understanding how we're gonna create these graphs. So we got this graph to show up, and right now we have these buttons at the top. So let's go ahead and see what they do. Right now, the neat feature about this is I can zoom in. For example, if there were maybe 50 points, all right, and all of them were bunched up together, what I can do is I can zoom in. It's not letting me, but if I select this, no, whatever. So this move, so let's go ahead, start from the beginning. The home button allows you to go back to the original position of the graph, okay? If I move the graph all the way over here, and if I hit home, I'm back to the center, okay? This left and right basically zooms out and in. So as you can see, as I hit the left and the right, it goes to the left and the right of the graph. I mean, as I go left, I go back to the normal setting, and as I hit right, I slowly move further along the X and the Y axis, okay? Again, the 2 arrow signs, this is for panning and zooming. I select this, I can move around the graph, okay? Here it goes. I can move around, hit the home to get back. Now this is basically a zoom. Sorry, this is what I was talking about. And here what you can do is you can zoom in. So let's say I want to zoom in on this particular part of the graph. Awesome. I zoomed in. Let's zoom in further. Ooh, this point looks interesting. Awesome. Awesome. And then what you can do is with the arrow keys, these left and right arrow keys, I can go back. So I can zoom in further. I can zoom in back and then go back to the normal settings. All right. This is basically the subplot configuration tool. Again, this is quite useful, all right? Let me quickly explain what's happening. So I'm gonna minimize this so that everything fits on your small screen, or my small screen actually. And whoops. All right, this works for now. So left, as you can see, it gives us more or less white space on the left hand side, increase or decrease how you go on the graph to look. The bottom does the exact same thing. The right and the top, if you haven't already guessed, also does the exact same thing. Basically, they're used to position or adjust the plot, okay? So you can change the plot space and stuff. White space and horizontal space, sorry, width and height space, this basically changes that. But right now you're not seeing anything, that's fine. So reset this, that's all good stuff. And last but not least, you can save this graph. So let's go ahead and try saving this. It says save this figure. Yeah, sure, I'll just save it there, save. And if you open it up, so let me go in my documents, and into the thing I just saved, it's been saved as a PNG. So my preview is right now opening, and you should hopefully see, ta-da, it's now saved the graph as something that we can show to people, or you can use it in maybe running your business documents, whatever, but it's saved it as a PNG. So it's pretty neat. Something if you ever wanted to talk about, if you had an interest in with graphs and stuff, this is definitely a very, very useful tool, okay? So in this lecture, we basically talked about the whole plotting interface, what the different buttons did, how to save your graph, and so on. Now, in the next lecture, let's go ahead and talk about more of the graph. So what other features can we add to our graph? See you in the next lecture. Alright, so right now we discussed about the whole plotting GUI, so what the buttons did. We've created our first graph, and that's fantastic. But I'm sure you probably know that there's more to the graph, right? You have the concept of a title. You have the concept of putting a word for the x-axis, putting a word for the y-axis. How do we do that? So for the next few lectures, at least for the end of this module, I'm going to be creating all of my code, or typing all my code inside of a file. And the reason I'm doing this is because it saves us time, easy to edit. We don't have to type all our code back. So here it is. Let me just go ahead and get my 3 lines of code there. For import matplotlib dot pyplot as plt, I guess. Doesn't really matter what you call it. Just know what you're calling it. And then we said plt.plot. We did the x coordinates first, so 1, 2, 3, 4 are our x coordinates, comma the next 4. So the y coordinates, let's go ahead and do the same ones, 3, 8, 10, 25, right? So we plotted the graph, that was fantastic, and then we did plt or pt.show. So now before doing show, let's go ahead and discuss what other things there are to a graph. I'm gonna go ahead and open Paintbrush again because I love the tool. Since there is no Paint in Apple or in a Mac, so I'll just be using this. Okay. So we've discussed, hey, how a graph looks. We've created a very simple graph. Currently, our graph looks something like this. So this is positive x, the one I'm making right now, x, this is y, and this is negative. We don't really care about that, but our graph currently looks something like this. It's pretty close actually, where this is 1, this is 2, this is 3, and this was 4. Okay, so pretty neat graph right now, but there is still a lot more that we can do. Now, if you've ever used graphs, and I'm pretty sure you have, there's a concept of a title, right? So in the title, usually add something up top. This is a graph of rain. Whoa, that was horrible. This was a graph of rain in December. So on December 1st, we had 3 inches. On December 2nd, we had 5. On December 3rd, we had 8. And on December 4th, we had 25 inches of rain. Can you believe that, guys? 2 feet. That's pretty impressive. So we've added this title. Now we also have to label, hey, what's the x-axis and what's the y-axis? Because that is key in any graph. So go ahead and add some text as well. The bottom, the x-axis is what? The days. So days in December, I guess. In December, hit place. Okay, we place this over here. And what's the right-hand side? The right-hand side is inches. Let me capitalize that. Inches, what? Inches, there we go. Inches of rain. Okay, so it's not realistic, but it's fine for now. So the y-axis is inches of rain. The x-axis is days in December. And we have a title, rain in December. So we want to replicate that inside of the graph that we've created right now. And the way we can do that is by using some straightforward functions. Let me get that over here. Okay. What you want to do is say plt.title, and the title is going to be rain in December. Okay. That will give us the title of the graph. Next thing you want to write is plt.xlabel. So xlabel will give you the label of the x-axis, so you can specify what is it. Well, we decided it's going to be days in December, and our y is going to be plt.ylabel inches of rain. Okay, so that looks pretty good. And last but not least, we have to say plt.show. Okay, save this. I'm going to save mine as matplotlib example. Hit enter. Okay, save this, F5, and let's take a look. So it's now running. As you can see, it's been restarted, and my Python launcher's appeared. Awesome. So now if you take a look, let me minimize this for you guys. We have rain in December, we have inches of rain, and we have days in December. So at the end of the day, this is actually pretty darn cool. I mean, we've now added a title, we've added the X label, we've added the Y label. So now it's looking like a more complete graph. I'm pretty sure you agree with me here. So the next thing that I want to talk about is reading off from a file. In the next lecture, we'll discuss how you can get data from a data source and create a graph from those points. See you then. Alright, so in the previous lecture, we discussed how we can add some labels to our graph. Okay, we added a title, we added an X label, we added a Y label, and our graph's looking pretty good now. So what I want to talk about today is the concept of reading off a file. Okay, that file will have the coordinates that we require, and actually creating a graph from those coordinates. So here's a challenge for you. Go ahead and create a file with coordinates, and using the knowledge you have from file input output that we discussed, try doing that. So open up a file, or actually create a file, save that, and then in your Python, read through that file, split the x and the y values, and then use those specific x and y values in your pt.plot. So that's the challenge for you guys. If you can do that, that's fantastic. I'll pause the video right here. Alright, so if you manage to do that, that is amazing. If you don't, or if you haven't and you don't want to and just want to stick with me, that's absolutely fine. So first thing first, I'm going to go ahead and open up my text edit, and it's in my text edit where I'm going to create my points. Okay, so this program is going to be quite simple actually, don't worry. Here is my text edit. Let me just open up a new document. Okay, here it is. And let me change my format to make plain text. So guys, if you're on a Windows, we discussed how to create a file. All you have to do is open up your notepad and open up, just open up notepad, write some text, any coordinates you want. The way you're gonna write them though is x comma y. So you're gonna do something like 3 comma 22. 5 comma 16, negative 2 comma 8, 10 comma 43, and let's do one more, 4 comma 17. Okay, no, not 17. Let's do 4 comma 0 or 5 0. I don't know, guys. So this is our 5 coordinates: 4, 0, 10, 43, minus 2, 8, 5, 16, 3, 22. And all we want to do now is read off this file, use the coordinates, and create our own graph from these 5 coordinates. So I'm going to save this as coordinates.txt, coordinates.txt in my documents. Okay, close this. All right. So let me open up my file. Where's here we go, matplotlib example. All those are fine. So the way this is going to work is we're going to be creating an X array, and we're going to be creating a Y array. Okay, and we learned about how to open a file. So read file is equal to open coordinates.txt. Was it capital? I really don't know, but that's fine. And we're opening it with just with R. Okay, and then we can just say data is equal to read file dot read. Okay, and right now we'll just go ahead and print data. Okay, so something simple, and I'm gonna just get rid of this so we don't need the title, the plot, all that stuff. Let me just remove it. Okay, so save this, F5, and let's see the data we get, or let's see if it even works. So, okay, we got 3, 22, 5, 16, minus 2, 8, 10, 43, and 4, 0. Pretty good. So the first thing we want to do now is we want to separate these out. And the way we can do that is by searching for this thing. So let's go back to our file. And over here, so we got our data. Our data looks good. What we want to do now is split the data. So just do this here, .read.split, and then we're splitting it by /n. And you guys probably know that the /n stands for new line, and by doing that, we have split each one of these coordinates individually. Or by individually, I mean we have separated each one of these pair of coordinates out. So we now get 3, 22, 5, 16, minus 2, 8, 10, 43, 4, 0 as 5 distinct objects in an array. The reason I use /n is because at the end of each of the coordinates is a /n saying to go to the next line. Okay, the /n is at the end of every coordinate or pair of coordinates, so it doesn't really show up there, but we know that it's there. That's why it's going to the next line. So we now have our coordinates, okay? And the next thing we need to do is split each individual object by the comma, okay? So I agree we haven't talked about the split function yet, but basically all the split function does is it searches for the string or the object that you're passing in, and every time it finds an occurrence of the object, it will split it. So it'll take that occurrence out and then put it into an array. All right, so that's exactly what it's done over here. Now all we have to do is go inside each object of the array and split for the comma. So let's go ahead and open up the IDLE again, or my file. And what we're gonna do is, so for I in data, okay, we wanna say, alright, so we have for I in data, and now what we have to do is basically split I and store each one of those individual values in X and Y. So I'm going to say val is equal to I.split for the comma, okay? Oh, I'm sorry, not the square brackets with the circular brackets, normal brackets. And then what we want to do is say x.append, and we're appending the first value of val, so val 0. And then we're going to say y.append the first or second value of val, okay? So val 1. So save this, and now let's go ahead and just print out x and print out y. So save this, F5, let's take a look. And we get 3, 5, minus 2, 10, 4, 22, 16, 8, 43, 0. So, pretty cool, right? Going back to our code, let's see what just happened. If in case you're a bit confused, all we did is we have appended each value of the, so we had data, okay, data had all our different coordinates, and we split the data based on the comma. We got each of these individual numbers, and then we knew the first number was X, the second number was Y, so we split it just like that. Alright, so one more thing actually over here is we have to convert the string into an integer. So go ahead and say x.append and then convert that into an int, okay? And same thing with y.append. So y.append int and then val1. Taking a look over here, let me make sure everything is good. So we don't need this extra array. That's the problem that we were running into over here. That's why we're getting this extra array over here. So we have, it looks pretty good. So x.append int val0 and y.append int val1. And by doing that, basically all we're saying is, hey, append all the x values to our x array and all the y values to our y array. Just to make sure one last time, let's go ahead and print out x and print out y. Save that, F5. What do we get? We get 3, 5, minus 2, 10, 4. Looks like it's all good. So it's all integers, it's all in the proper array. So last but not least, we have to add this to our plot function. Okay, we're almost done. So let's go ahead and do that. We basically have to say plt, I believe that's how we saved it, yes. Yes, plt.plot, whoops, x and y. So plt.plot x comma y, all right, and that's basically the x coordinates and the y coordinates, and then plt.save or plt.show. Command S, F5, and we get, wow, guys, this is the true definition of a graph. Wow. I think we might have messed up. Let's take a look. So minus 2 comma 8, 3 comma what is it, 22, that's correct. 4, we had 4 comma 0, that's also correct. And then we had 10 comma 43, that's good. And then we had 5 comma 16. So it is a bit different, I guess that's what you say. It's a little odd looking. I guess it got confused on how to join the lines. But this is our graph. Awesome job. In this lecture, we basically learned how to read off a file, how to split the terms, and how to create a graph based on data. Awesome job, guys, and I'll see you in the next lecture. Alright, so in the previous lecture, we created a simple graph, okay, and we learned about a few things, reading from a file, and understanding how we can read off data and create a simple graph. So in the following few lectures, we're going to be learning how to create multiple graphs, how to color our graphs, and basically the concept of subplots. Okay, so let's get started. First thing first, right now what's happening is we're just plotting some points and we're showing those points. However, what we can do is we can create something called a figure. And what that figure will have is multiple plots. You can have maybe 3 plots, 4 plots. You can have whatever you can do whatever you want, except you do it inside of a figure. All right. So let's go ahead and create a figure, and I'll show you what I'm talking about. Currently, we have these 2 lines: import matplotlib.pyplot as PLT, and we have plt.show. So these are the 2 basic lines that we require currently. Let's get started. So what I want you to type is fig is equal to plt.figure. Okay, and what this will do is basically it'll initialize this figure that we see over here. This was some data that I was testing out, so let this be. But this figure 1 that you see, that's what we're creating. Okay. Now the next thing is when we're creating a rectangle. Okay. These next 2 lines basically change the color of the background. So currently, as you see this light gray color at the back, this is what you can change using the following code. So rect is equal to fig.patch, okay? And then you can say rect.set face color as any color you want it to be. You know, you can do maybe red, you can do green, you can do blue. I am going to do, let's do green, okay? So, whoops, I had an extra apostrophe there. All right, so these first 2 lines, this line over here creates a figure. The next 2 lines help us change the background color. All right, so that's one thing that we're doing. Now, we want to change this main color. We want to get this graph. How do we do that? So what you want to do is you want to create something, any variable name. I'm going to call mine as graph1. And you say this is equal to fig.add_subplot. Okay? And basically what a subplot is it's another graph on your figure. So you can have as many graphs as you want, but you just have to keep on adding those subplots, those graphs. Okay? So we have add subplot, and then just take in some parameters. So the first 2 parameters it takes in is the dimension of your figure. Okay? Suppose I'm creating just one graph. The way I do it is 1, 1, where this first one stands for the height, and the second one stands for the width. In case I did 2, 1, this figure would then become 2 graphs, or it'll give me space for 2 graphs. Okay, so by specifying 2, 1, you're saying that it's a 2 by 1 dimension, so 2 graphs in height and 1 graph in width. Since we're only creating 1 graph, let's go ahead and do 1, 1. Then the third parameter is basically saying, hey, what graph are we talking about? Is it the first graph? Is it the second graph? Is it the third graph? Because right now, our module doesn't know which graph we're talking about. So you have to specify, hey, this is our first graph. All right. Now the next parameter, and then there are actually several parameters, but one parameter that we're going to be talking about is the access background. Okay. So right now you see this dark gray color. That you can set via the access background parameter. So basically just type in access background and set this equal to any color you want. Since we did green over here, let's try doing, let's do black. Yeah, let's do black. Black. Okay. And last but not least, we have to add plot. Okay. So you're gonna say graph1 dot plot is equal to, or actually no equal to there. So graph1.plot, and then in brackets specify the 2 arrays. So I'm going to go ahead and create my x and y arrays over here. So in the previous lecture, you must have seen that the graph that we created was actually really weird looking. And later on, I realized that it's because of the way we added our points. So in the previous lecture, I done something like 3, 7, 5, 8. And that was wrong on my part because what the graph did is it then created a point at 3, then went forward, then went backward, and then it went forward again. So it got a bit confused as to what's happening. So quick tip, guys, whenever you're creating a graph, make sure your points are in order. So if you have 3, next one should be greater than it, the next one should be greater than it, and next one after that, it should be in an increasing order, okay? So So I'm gonna do 3, 7, 8, and 12. And for my y, I'm gonna do 5, 13. So the y doesn't really matter. You can do y whatever you want. So 2 and 8, but the x values do matter. Okay, that's x and that's y. And let's go ahead and add these two parameters, x comma y. So last but not least, take a look at this graph. What's different? We've changed the background. We've changed the light background over here, except these line colors. How do we change these line colors? Well, to do that, that's another parameter over here. All you have to specify is the color. So what color do you want this line to be? Since we've done green and black, let's do a color that pops up on black, which is going to be red. And then what you can do is you can specify how wide the line is. Right now, this line is pretty wide. So what you can do is something like line width is equal to, I believe the starting one is either 1 or 2. I'm not completely sure. Let's go ahead and try out 4. Okay, so 4.0, save this, F5, and let's see what happens. Okay, my Python launcher has now appeared. Wow, that's actually a pretty cool graph. I mean, if you think about it, you know, this is pretty neat. So what happened is we changed the background. So the green is in correlation to this patch, okay? We said rectangle is equal to fig.patch. It doesn't have to be rect. You could have done background. You could have done anything you want. But fig.patch basically allows you to change this back color over here. Then what we did is we set the face color to green. We added a subplot. So this graph that you see over here is a subplot, okay? This graph, let me try to minimize this for you guys, okay? So this graph that you see is called a subplot. We assigned it a 1x1 dimension, meaning that there's only going to be one graph. We assigned it that this is the first graph, so that's a third parameter over here. And then we made the axis background equal to black. So that's why our background is now black. Then we plotted our points, so x and y. We made the line red, and we made the line width to be 4.0, so we changed up the width. Awesome job, guys. In this lecture, we basically talked about some functions or some coloring options that you have with your figure. Now, in the next lecture, we'll continue along with coloring, and I'll tell you how to change the labels, the ticks. By ticks, I mean, you know, the 4, 5, 6, the small pointers in front of the numbers. I'll show you how to change those colors as well. So see you in the next lecture. Alright, so in the previous lecture we talked about colors, okay? We learned how we can change this background, the pre-background, and the line colors. We learned how we can modify some objects, and we learned how to create a subplot. So creating a figure, adding subplots, stuff like that. Now in this lecture we're going to be continuing that, except we'll learn how to change some more of the graph. So these tick params, the text, stuff like that. And by the end of this lecture, you should see fully colored graphs, so nothing will be left behind. Let's get started. So first thing first is the tick params. I'll show you how the tick params look in a second, but let's go ahead and set them. The way you set them is you say graph1.tickparams, okay? And then you specify which axis you're talking about. So axis is equal to whichever axis, X or Y. Let's go ahead and start off with X, and you say color is equal to whatever color you want. However, since we have a black background, I am going to do white params or white ticks, okay? So, you know what, just save this, F5, and I just want to show you what's happening so that you understand what you're actually creating. It's run, okay. So this is my figure, and I'm not sure if you see it on the screen. Again, I will zoom in for you, but you see these white params, these white tick params over here that specify where number 4 is, where number 5 is. That's what we've just changed. So before it was black, now we've turned it to white. So we're going to do the same thing with our y-axis. Graph1.tickparams. Axis is equal to y. And color is equal to white. Okay, save this, F5, and now we should see tick params on both our y-axis and our x-axis. Okay, so ta-da, here we go. I'm not gonna make it all the way, but you see the small white on the y-axis and these white params on the x-axis. Okay, so that's the first thing we've changed. That's pretty good. Okay, now the next thing you want to change is the spine. So by spine, I mean, you see this box, this black box that we've created. Actually, you can even change the boundary color. So this small border that you might say, this border, we can also change the color of so that it pops out and makes your graph look better. So we call those the spine. And to change the spine, it's actually pretty cool. What you have to do is you have to specify each top, left, bottom, right. So each side of the box you have to specify specifically and change the color. So to do that, you're going to say graph1.spines, and then you specify, what is it, bottom, right, top, or left. I'm going to do top first because I just like top. Top.setColor, and then just specify what color. So we're doing white again because white will pop out with the green, red, and black. So that's top. Go ahead, do one for left, right, and bottom as well. So I'm just going to Command C, Command V. Okay, here goes left, here is right. All right, and let's do one more. Let's do bottom. Okay, cool, and all of them are white. So save this, F5, and now if you take a look at that border, you're gonna see a little better looking graph, right? So it pops out now. Before it was just black, but now you see this white. You see this white line around the border of your graph, and that just makes it more, it pops out. So if you're creating a graph to show to someone or anything, it just gives it a better appeal. So I hope you agree with me there, but if you don't, that's fine. And to finish this lecture off, let's go ahead and understand how to change the text, okay? So right now we don't have any labels, but I do want to add the labels, and the way we can do that is actually by doing this. So say graph1.setTitle, and the title basically is the title of your, like I've talked about this, but it's the title of your graph. So I'm gonna give this title as, currently it's random, so a random graph. And then you also specify over here what color do you want this to be. So by specifying colors, it changes all three or any of the text. If you only specify color, I believe it doesn't. I'm not completely sure, but just go with colors for now. Okay, we have colors, and let's change this to white again. So random graph, comma colors is equal to white. So by setting it as colors, we don't have to change the x-axis, I believe. So it's .set x label, and our x label is going to be this is the x-axis, something simple. And go ahead and do the same thing for the y-axis. So graph1.setY label is equal to this is the y-axis. Okay, so save this, F5, and now you should see better text. So it just makes our graph at the end look better. Okay, it's giving me an error over here. It says unknown property in set title, title.update quarks, unknown property colors. Okay, that might be because of the extra S. Let's try doing color. That might work. Let's see. Yes, cool. So we changed the random graph, that made it color, but this is the x-axis and this is the y-axis is still black. I believe it would have worked with colors, but I guess it's not. So let's go ahead and try changing it specifically. So let's make this white as well, and let's make this white as well. Okay, so save this, F5, and hopefully now we should see, yes, there we go. So basically the error we were running into is it wasn't taking colors as a parameter. I thought that would work, but that's okay. So what we did in the end is we changed each one of the labels specifically, saying color white, color white, color white, and this is our end product. So this is actually a pretty neat graph. I mean, if I was showing this to someone for a lecture or something, I would use this graph. White, black, red, green, they're contrasting colors. Fantastic job. So in the next lecture, I'll be showing you two ways. One way, or two methods actually. One method will be to add another line to this graph. That won't take us much time. It'll be a short lecture. And then the lecture after that, I'll be showing you how we can have multiple graphs in one figure. So again, that's where the subplot parameter comes in. That's gonna be a lot of fun, but I'll see you in the next lecture. Alright, so in this lecture, we'll be talking about how to add multiple lines to your single graph, okay? So far in the past few lectures, and actually in all the lectures, we've only discussed with this one basic line. And many of you, whenever you're creating graphs, will be, hey, I want to compare several different data together. So how do you do that? How do you add multiple lines to this graph? So again, this is going to be a short lecture. There's nothing to it actually. The way you can add multiple graphs is using, the way you can add multiple lines to your graph is by using the dot plot function. So all you have to do is you have to say graph1 dot plot, and then you can say, well, whatever you want to do. So At the moment, I don't have different data types, so I'm going to go ahead and do that. Let's go ahead and add 2 more lines. So x2 will have the points 0, 4, 7, 10. y2 will have, y2 is, I'm sorry, my bad guys. y2 is equal to, let's do 3, 7, 1, 12. And then let's go ahead and create one more data set. x3 is equal to 2, 4, 6, 8. And actually, you know what? Let's make, no, it's whatever, that's fine. x3 is that, and y3 is equal to 13, 5, 8, 2. Okay? So those are our 3 data sets, and let's go ahead and add those over here. So we're plotting another line, graph1.plot x2, comma y2, comma, let's make this one. So let's take a look at our graph actually for contrasting colors. Let's do yellow as one. Yellow will really pop out. Yellow, and line width is equal to, I'm gonna make this 2.0. So I'm doing 2.0 because I just want to show you the difference on how the thickness varies. Okay, and let's go ahead and plot one more. So x3 comma y3 comma what's a better color? So we have red, we have yellow, and let's do let's see over here guys, orange. Orange will pop out nicely as well. So some bright nice colors. I think blue and purple will be a little too dark, but you can try it out. And let's do line width over here equal to maybe 6.0. Okay, so save this, F5, and oh whoops, I'm gonna get an error there guys. It should give me an error. If it doesn't, that's pretty cool. But yeah, exactly. So it gave me an error. I'm gonna make it back to 6.0, F5, and let's run this again. Wow, so taking a look at this, a very interesting graph. Basically what happened is, since we didn't start all 3 of the graphs from 0, it looks a bit weird. So quickly what I'm gonna do guys is I'm gonna start all of them from 0. So whatever their x initial values are, I'm going to make them all 0. And whatever their final values are, x comma 12, x comma 12, and x3 comma 12. So that basically gives us a better looking graph by making their initial and final x values the same. So now, ta-da! Take a look. So you can definitely see the thickness in our orange line. It's a lot more thicker than maybe you would like. The yellow looks a lot more simple and a lot more professional. The red also looks pretty good. So this is how we add multiple lines to a graph, okay? Basically use the plot function. You can add any data you want to. Comparing wise, you just gotta get your data over here and use the plot function to add those lines to your graph, okay? So awesome job, and in the next lecture, I'll be teaching you how to add how to add more graphs to your figure. So right now, we've been dealing with one graph. How do I add 2 graphs, 4 graphs, stuff like that? So I'll see you in the next lecture. Alright, so the time now comes where you ask the question, hey Avi, how do I add multiple graphs? So you taught me how to create one graph, that's fantastic. But what if I have, a completely different graph that I want to add to my figure? So I have one graph up top, maybe one graph to the right, one graph at the bottom, stuff like that. Where does the concept of multiple graphs come in? So that's basically what we're going to be talking about today, all right? What I want you to do is copy all the graph1 lines that we have created. So Command C, give yourself some space, Command V, all right? And now what I want you to do is change all the graph 1s to graph 2s, okay? So I'm not gonna waste too much time doing that, whoops. But basically all of them should become 2s. 2, 2, 2, 2, 2, and 2, 2, okay? And one more, sorry about that, 2. So graph 2 is now our second graph on our figure, okay? We don't have to change anything. It would be nice to change up some of the data. So what I'm going to do is we're not going to be plotting these extra lines anymore since we don't need them. I should have actually removed them before copy pasting to save myself some time. And instead, I'm going to make the graph 2's plot as x2 comma y2. Okay, and that's red and this is red as well. So let's go ahead and change the color of this to yellow. Okay, And line width, let's make this to 2.0. Let's make that one a 2.0 as well. Cool. Whoops, 2.0. Cool. So we have graph 1. Graph 1 is fantastic. It's a subplot of 1, 1, 1. Everything was good in graph 1. What do we have to change in graph 2? Actually, nothing much, alright? So it's not too complicated. Basically, I mean, if you're creating a completely different graph, you'd maybe change the X, Y labels, the title, give it some different colors. However, since we're just showing how to create another graph on the same figure, we only have to change this first line. So graph 2 is equal to fig.add subplot 1, 1, 1. And if you remember in the previous lecture, or maybe 2 lectures ago, when I was talking about how to create this, I talked about these 3 parameters. So the first 2 indicate how big your figure is going to be, like what's going to happen. Is it going to be a 2 by 1, a 2 by 2? Is how many graphs are there going to be? So I remember how I said that you always have to specify that early on. Right now it's 1, 1, and that means that you're only going to be creating 1 graph. Right now, if you run this, whatever code you wrote up top is going to be overwritten by the graph 2. Watch. So my Python launcher is appeared, and take a look. We have this and we have this. Yeah, that's not great. We wanted 2 graphs. So how to add 2 graphs? The simplest way is basically change this to 2 by 1. And what 2 by 1 does is it creates 2 graphs, one above the other, or one underneath the other, okay? So it's gonna be 1 graph up top, 1 graph at the bottom, and then remember what the third parameter was. The third parameter says, which graph are we talking about? Is this the first graph, the second graph, the third graph? Since the top one is already our first graph, we need to change this parameter to be our second graph. So it's 2, 1, 2, whereas the top one is 2, 1, 1, okay? So save this F5, and now if you take a look, let's see. Cool. So we now have 2 nice looking graphs. We have random graph over here, and we have random graph over here. And they both show different data. They're nicely arranged, stuff like that. So in this lecture, we basically learned how to add 2 graphs together in a figure. So I know what you're thinking. What happens if there are 3 graphs? Right now, with the dimensions we have, there's 2 by 1, that equals 2. 2 into 1 is 2. But the next one you can make is 2 into 2, which is 4. So what happens when you only need 3 graphs? Well, I'll talk about that issue in the next lecture. Right now, I just wanted to show you how to create multiple graphs in one figure. See you in the next lecture. Alright, so in the previous lecture, we discussed how to create multiple graphs in a figure. But I know what you're thinking. This is great, okay? The dimensions are working perfect. If you do 2 by 1, it'll create 2 graphs, one on top of the other. But what if we only want 3 graphs? I mean, based on my observations, if we do 2, 2, that's going to create 4 slots. What happens then? Well, let's go ahead and try it out, and you'll see for yourself. So we had graph 2. Again, I'm sorry guys, we're going to have to copy paste. So Command C, Command V, and go ahead and change, where was I? Here, okay. So starting from here, change all of them to 3 again. There's probably a faster way by Command F and searching for all the 2s and replacing them with 3s, but that's fine. I can do some manual work. So these are all graph 3s. Yes, okay. And now what we have to do is go ahead and change all of the fig.add subplots to be 2, 2. Okay? So this is 2, 2. This is 2, 2. And this is 2, 2, 3. So remember, this is the third graph we're talking about. And that's it. So by doing so, we have created a 2 by 2 dimension of graphs. We have graph 1 as our first graph, graph 2 as our second graph, and graph 3 as our third graph, okay? So everything else looks correct. One last thing we should do is change the values to x3, y3, and change the color to, orange, okay? So graph 3 is equal to fig.add subplot 2, 2, 3, graph 3.plot x3, y3, orange. Alright, so save this F5, and I'll now show you how creating these graphs work, okay? Okay, so we have this extra space now, and you're probably wondering, well, okay, this looks good. So we've created a 2 by 2 dimension, we filled it up with 3 graphs, but suppose I only want 3 graphs to show up. I don't want this extra space inside of my graph. I mean, that might be an issue you might have. You want one graph to be super long, cover the entire space, and then you want two smaller graphs to maybe display some other smaller information. So the way you can do this is by just changing up one number. Basically, when you create a 2x2 dimension, the module creates 4 spots in your figure. Okay, 1, 2, 3, 4. That's exactly what it's done over here. So this is spot 1, this is spot 2, this is spot 3, and this is spot 4. However, suppose we're talking about this graph. Right now for this graph, the orange graph, we have it set as 2, 2, 3. So basically we're saying in a 2x2 dimension, okay, that gives us 4 spots, I want this graph to be at the 3rd spot. Okay, so hopefully you're understanding how this placement of graphs work. Basically, multiply these two numbers together. That gives you the number of spaces inside of the graph, and then you just specify which number it should be. So in a 2x2 graph, which gives us 4 spaces, you have put it at the 3rd position, which is this one. Now, the goal is right now to extend this graph all the way to our right. So make it to the width of our yellow graph. So going back to the 2x1, what does a 2x1 say? 2x1 says, I want to create 2 graphs, and the dimension is obviously gives us 2 spaces, one at the top and one at the bottom. So what is the bottom's number? Well, if the top's number is 1, the bottom's number will be 2. So go ahead and try that out. Say subplot 2, 1, 2. So basically what that's saying is, think of this top part as one graph and this bottom part as the second graph, okay? So save this F5, and now if you take a look, you're gonna see our 3rd graph has completely expanded to the edge of our screen. Pretty neat, right? So let me just make this down. Awesome. So over here now you can take a look. We learned that by changing up the dimensions, you don't have to make the dimensions same for each graph. All we did is we specified graph 3 to take up the full space at the bottom by making it think that it's a 2x1 dimension of a graph. So by specifying 2, 1, that graph will now take up the whole bottom space. So that's it for this lecture, guys. One last thing actually before I end it. So taking a look at this, what I want you to do is open up our, not Zoom, but this one, the subplot configuration tool. And I quickly want to show you how this width space and height space work. So seeing this, the width space over here, try is expanding this. See, that's what it does. So if you want your graph to be a little neat, in case you're conserved with space, if you're working on a small screen and your graph is looking a bit scrunched up, what you can do is you can make your W space a bit greater, give it some gapping between the graphs, and then you can increase your horizontal space so that the random graph and the X and Y axis don't get interfered. Currently, right now, our numbers are being hidden by the random graph. Just expand the horizontal space or the height space a little bit, and that will give us some nice gap. Anyways, awesome job, guys. We learned quite a lot in this lecture. Let's quickly recap. So we learned about how to add multiple graphs in a setting, in a figure. We learned how to use our dimensions to specify where the graph should go. We learned that we don't have to use the exact same dimensions for each graph. If you want one graph to extend all the way, you don't want it to be in one specific place, then you can use different dimensions to get your specific outcome. All right. Last but not least, we learned how the height space and the width space works. So terrific job. Again, if you have any questions whatsoever in the past lectures or in this lecture, if you're a bit confused on something, if you're not getting it, please do ask the question. I want this course to be an open course. I want people to ask questions, be friendly, stuff like that. But that's it from my side. All right, so I'll see you in the next lecture and have a fantastic day. Alright, so in the previous lecture, we talked about creating, that 3rd chart. So we had 2 charts, we were able to get that 2x2 dimension, and we talked about how we can expand that third chart to go the whole distance of both those other charts. But anyways, moving on from line charts now, and the next topic is going to be our bar charts, okay? So again, this is going to be a short series, maybe 2 or 3 lectures max, and I'm just going to discuss on how we can create these bar charts, how they work, stuff like that. So importing wise, it's going to be a little bit different. What you're going to do is you're going to say import matplotlib.pyplot as plt, and then you're also going to import numpy as mp. Okay. basically NumPy is a module that will allow us to use one or two functions that is necessary for creating a bar chart. Okay, so that's great. Next thing is you're going to create a position. So just create any random variable. I'm going to call it pos or position, and set this equal to arrange, and then in brackets 6 plus 1 or plus 0.5. Okay. So let me quickly explain what's happening here. The arrange function basically creates an array, okay? So think of it as a range, not the word arrange, but a range. It's basically an array of 6 values that we haven't really created yet. And then you're specifying the distance between each bar of the bar graph, okay? So arrange 6 creates 6 bars, and 0.5 is the specification of the distance between the bars. Cool. Now the next thing is, you want to specify what type of bar graph. Is it a vertical bar graph or is it a horizontal? Let's create a vertical. So bar V, except before doing that, you have to say, I'm sorry, I missed one thing over here. It's going to be np.arrange. So make sure you specify np. NP is again for NumPy. NumPy module has the arrange function. So pos is equal to np.arrange 6 plus 0.5. And then you're going to say plt.barv and then you're going to say pos, comma, the 6 values. So these 6 values again will be numbers. These numbers will indicate how high the bar should be. Again, I'm pretty sure you know how bar graphs work, so go ahead and enter some 6 random values. I'm going to say 4, 8, 12, 3, 17, and 6. Okay. And then you can specify some other stuff like how do you want to align it. I'm going to align mine center, and then you can specify the color of the bars. So I'm going to say color is equal to, and for me I like red. Red's a nice color. So that's plt.brv, and then all you have to do is say plt.show. So again, this has no labels, no thing whatsoever, but we're just creating a basic chart. That's it. Okay, it has run. Whoops. Okay. Give it some time. It gives me module object has no attribute brv. It might be brv, I'm not sure. I know brh is horizontal. I wonder what vertical might be. Let's try, maybe w, I'm not sure. Let me see if this works. Otherwise, I'll go ahead and find it out for you. I know bar h gives you the horizontal, so let's go ahead and try that. Bar h does definitely work. There we go. Ta-da. Take a look. So this is our 6 bars, and the distance between that is 0.5. And by 0.5, you can sort of tell because 0.5 is the distance from 1 to 2, I guess. I think that's what they meant by 0.5, or maybe 0.5 is a different sort of value. But you can see the distance. You can see how it's now horizontally placed. Let me make it a little bit higher, and the values are all correct. So awesome job. This was our first introductory lecture into bar graphs. Again, I will find out what is the vertical. I'm not completely sure, but I'll go ahead and double check. And in the next lecture, we'll be adding those labels, so titles, stuff like that. See you in the next lecture. Alright, so in this lecture, we're going to be doing the same thing we did with the line plots. We'll be adding the text, we'll be adding the color, the ticks. I did do some research for the bar vertical, and most of the examples gave horizontal. You could do something by doing plt.bar and then adding those values. I did use the help function, as you can see, with the plt, and it gave me a list of functions that you can use. I searched for bar and I got this. So let me just bring it up for you guys. Where is it? Where is my bar? Yeah, I'm not sure where it went, but anyways, I did do some research for that and I couldn't find it out. So just leave it at that. That's fine. Horizontal is fine for now. Anyways, let's go ahead and add some of our data. So first thing first, our X label, Y label, and title. Those are quite key. The way I'm going to do this is I will, let me see over here actually. So let's go ahead and add our X label. Let's say we're creating, what do we use bar charts for? Let's say number of, okay, let's say we have 6 students and we're taking the height of each student, okay? So on the x-axis, we'll have height in inches, or height in inches, okay? That again will be plt.xlabel. and then plt.ylabel will be something along the lines of students, I guess. Those are our students. Let's go ahead and give each of them a color. So color is equal to red, color is equal to red. Okay, and then you're gonna say title, so plt.title. The title is going to be height of students in inches. Okay, and the color for this, let's do color equal to, whoops, where's my ending apostrophe? Color equal to, I'm gonna say, let's do blue, okay? So we have our X label, Y label, and title. Let's go ahead and get a tick params. So tick params, plt.tick params, access is equal to X, comma, colors is equal to white. Okay, let's go ahead and save that, F5. Let's see if it works. Okay, there's that, and all right, so right now, taking a look at this, we have students, that looks good. We have our height in inches that you can't really see, and you have height of students in inches. Cool. So let's go ahead and change a little bit more of the tick params. So plt.tick params, access Y. And you'll notice as we continue along in the course that most of the graphs work on a similar basis, that initializing them might be a bit different with the tick params, X, Y labels, titles, stuff like that. They're all the same. So there's nothing new for you guys. Future lectures might be even shorter than this one since it's just repetition, but you know, we'll cover some other graphs, don't worry. So we got the title, we got the tick params, what's remaining? So I'm sure you know in a bar graph that each bar has a different name. So the thing called Y ticks, our 6 bars, each bar represents a student. So how do we, you know, give these 6 students or these 6 stuff that, like, we have to give each bar a name. So what we're gonna do is use the function called plt.yticks, and then you can give each one a name. So it takes in 2 parameters, the position and then the name. So I'm gonna create a pos array over here. I'm sorry, no, never mind. It takes plt.yticks takes position, so pos, and then it takes in the name of each one. So since there's 6 values, we have to create 6 students. I'm gonna quickly just call them Avi, whoops, the caps lock, Avi, no. Yeah, okay. So Avi, Joe, Jose, I guess, Bob, Nick, Zelda, and Matt. Okay, so save this, and then let's go ahead and add our name over here. So we have to save this as an array first, my bad. I'm gonna call these names is equal to this, and then plt.yticks pos, comma, names. So save this F5, and now hopefully we're gonna see that our thing appears, our names appear. Yeah, they do, awesome. So now as you can see, we have height of students in inches. We have labeled each of the bars. We have students over here. Height in inches are at the bottom. You definitely could play around with this using the subplot configuration tool. You can maybe expand some, make it go all the way, and reduce the bottom a bit, make it go right a bit more. And in this lecture, let me just quickly show you how we can programmatically set these so that we don't have to do it when the time comes. The way you can do that is by using the function called subplots_adjust, and then you're gonna use left is equal to whatever you want. So as you can see, currently we have 0.11, bottom is 0.12. So I'm gonna go ahead and do that, 0.11. Bottom is equal to 0.12. Right is equal to, I'm not sure actually, so let me take a look. 0.94, excuse me, 0.94. So save this F5, and now if you see, we're gonna have our graph. Oh, I'm sorry, I forgot the PLT over here. It's giving me an error saying that subplots is not defined, obviously, since we haven't initialized PLT. And now if you take a look and hit your adjust, let me just move this up a bit. 1 sec. Accidentally hit the save button. So let me move this up for you guys so you can see. And if I hit this now, it's automatically at 11, 12, 94, whatever we've set. So this is how you can programmatically set your left, bottom, right, etc. to make the graph how you want it to be. End of this lecture, guys, we basically discussed how to change the bar options, how to add the bar names, and programmatically change the adjustments of our graph. Awesome job, and I'll see you in the next lecture. Alright, so our next chart is going to be a pie chart, okay? And we don't have too many more upcoming. I think this might be the second last or third last in our lines of charts. So we discussed the line chart, we discussed the bar chart, this is the pie chart, and then I know we have the 3D chart planned. I'm not sure if I have any more after that, but let's get started. So the pie chart is a little bit different, not too much different, but it's definitely fun. So what we have to do is to create a basic pie chart, you have to import matplotlib.pyplot as PLT. Okay, that's the basic. And then you want to create a list of sizes. So I'm going to say sizes is equal to, it can be anything you want, except at the end of the day, at the end of the day, the sizes numbers have to add up to 100. So if you don't know what a pie chart is basically a circle, and inside of the circle, it's cut up into different pieces, okay? And each piece is part of the whole, and the whole is considered as 100%. So the sizes that you put inside of this array is going to be, or are going to be, the sizes in the pie chart. So I'm going to put 50, 23, 7, 15, and 5. So these are my 5 sizes, okay? And then what I do is I'm going to say plt.py sizes, okay? That's pretty much all I have to do. So save this, and then we're going to say plt.show. So let's take a look, let's see if this works. Might take in 1 or 2 more parameters, and there are quite a lot of parameters, but I believe this should work. Yes, it does. Take a look. So this is, guys, a very basic pie chart, okay? It has 5 different colors, 5 different shades, horrible colors, doesn't even look like a circle, but this is the first pie chart that we have created with the matplotlib module, okay? So one thing I'm going to quickly fix is, let's make sure these are in descending order so that it doesn't look that bad. So 15, 7, 5 will just make it a little bit better. And now if you take a look, we should get biggest to smallest. So awesome job, guys. This was our first pie chart. It took us 4 lines of code and there was nothing hard in it. Now there is still a ton remaining. You're missing, first of all, it's not even a circle, it's like an oval, so we'll fix that. Second is we want to specify the colors, we'll fix that. Third is we can add a legend and a title. So we need to add a lot more stuff to this pie chart, and we'll do that in the next lecture. See you then. Alright, so let's get a few things cleared up. I mean, right now, our pie chart is just plain ugly. I mean, those are the worst colors I have seen in my life. I mean, I'm just saying here. Horrible configuration, not even a circle. But let's go ahead and fix some of those things up. So first thing is the colors, okay? The way I want to do this is basically, let me think about this here, actually, guys. So colors, let's go ahead and create a colors array. So over here, colors is equal to basically whatever you want. I'm going to do yellow, green, or yellow, I guess, orange, cyan, and I'll do magenta. So I'm not sure this color combination is going to be good even, but then let's do red. So 5 completely different colors. So yellow, orange, cyan, magenta, red. And then what you can do is inside of the plt.py, when you're saying that, you can also specify the colors. So I believe, taking a look at this, what we have to do is we say plt.py sizes, and then you say comma colors is equal to colors, the array colors that we've created. Command S F5. Let's take a look. Yeah, this should most likely work. So here comes my Python launcher. It's loading, here we go. Ta-da! So these colors again look better. Still not fantastic, but for now, for the purpose of this lecture, it looks great, okay? So we have this, now right now it's not a complete circle. A complete circle looks a little bit better than this, so this might be a problem with our axes. What we can do is we can specify the axes to be equal. So plt.axis is equal to equal. So we're just specifying that the x-axis and the y-axis of the circle should be equal. If you don't understand the concept, we'll think about it as a big plus. Going back to our pie chart. So this is our y-axis, this is our x-axis. For a circle to be an actual circle, both the x and the y-axes have to be the same length. Okay, so that's basically what we're doing. So we added this plt.axis line, and now as you can see, this is actually the whole circle. So before it was ovalish, but now it is the complete circle, which we wanted. Cool. So this step is done. Nice job. And what else is remaining? So we do have to get that legend going, and the legend I'll do in the next lecture, but is there anything else? One more thing is right now this pie chart looks ugly, and the reason I'm saying it's ugly is because normally a pie chart starts on the top. Right now we have half like this and it just looks a little bit weird. So what you can do is you can specify the starting angle to be something. So what you can say is you can say start angle is equal to 90. And basically what that does is instead of starting the pie chart from somewhere else, it's now going to start from the top. And it just gives a better appeal, it just gives a better look to the pie chart. See, now it's starting from the 90-degree angle and it's working its way down. That's 50, this is 20, 23, 15, 7, and 5. Awesome, so this pie chart looks a lot more better. We added some code including the axis, the start angle, and the colors. Now in the next lecture, I'll be showing you how we can add the labels and the legend to our pie chart. See you in the next lecture. All right, so we're almost done with our, with our pie chart. Okay, so we do have to add a title. That title can be easily created. plt.title. Go ahead and make the title as pie chart. But right now we still need the legend. Okay, sorry, a little bit of brain freeze right there. And to create the legend, what we have to do is first we have to specify the labels. So what are our labels of each section of the pie chart? The labels is equal to, and then specify the labels. So what does yellow stand for? What is our pie chart even representing? Let's think about it. So let's say languages spoken in the world. Okay, I'm pretty sure I'm wrong about this. Or not languages. Let's do phones. Okay, so which phone is most popular? I do know that Android is the most popular phone. I mean, out of devices sold, it beats Apple quite considerably. So I'm going to be doing Android first, and then will come Apple, and then comes, I guess, Windows, and then BlackBerry. I'm not sure, but let's just go with it. And then what other phone companies are there? Again, I'm pretty good with this stuff. I'm not sure what's happening, but I'll go with Xiaomi. It's a Chinese company. That's fine. So Android, Apple, Windows, BlackBerry, Xiaomi. So these are our 5 labels, okay? And the next thing we have to do is go ahead and in your plt.py, make sure you specify that the labels is equal to labels. So at least those things get a label. And then creating the legend is quite simple. All you have to do is say plt.legend, and then we specify a title. So what's our title of the legend? I'm gonna call mine legend because it's a legend, right? And save this F5, and now hopefully we should see our legend pop up. If it doesn't, I do know a quick reason why it might not. Let's see. So we do have our legend, okay? It looks nice. It's not in the position that we want it because our Windows is being covered up. So this is another key thing you might want to know. What you can do is you can use something called plt.location and set that equal to whatever you want. So I'm sorry, not plt.location, but you can set in the legend, title is equal to legend, and then location is equal to lower left. Okay, And by doing this, it's not going to be underneath Apple. So that's much nicer, okay? We have our pie chart. We have Xiaomi, BlackBerry, Windows, Apple, Android. We have our legend. What you can do again is you can select your subplot configuration tool, modify stuff. Maybe our title is a bit like that. I don't think you can change it maybe. No, you can't really. You could do some spacing and stuff, but for now it is absolutely fine. Awesome job, guys. This was a series of lectures on pie chart. We learned how to create a basic pie chart, make it a complete circle, add colors, add labels, and last but not least, add a legend and position it in the corner that we want. Fantastic job, guys, and I'll see you in the next lecture. Alright, so we've discussed quite a few plots by now. We've discussed line plot, the bar plot, and the pie plot. And there still are a ton more we could have done. We could have done contour, we could have done scatter plot. But I think it's time to up our game now. You know, it's time to go into the big leagues. We've done enough of the minors. It's time to go big. So we're finally going to be talking about 3D plots. I know. It is amazing. The 3D plots, what you can do with them, it's quite cool. Very cool, actually. And I'll be showing you in the following few lectures how to create some pretty awesome 3D plots, what you can do with them, stuff like that. So let's get started. With 3D plots, it is a slightly bit different with the code. We'll be doing something similar, but one or two things might stand out to you. The first thing that might stand out is the import. So what we have to do is we're going to say from mpl_toolkits.mplot3d, you're going to import axes 3D. And this basically allows us to create those 3D plots. And then the second one's going to be the exact same thing. Import matplotlib.pyplot as plt. Fig is equal to plt.figure. And then ax is equal to fig.add subplot 1, 1, 1. And then you're going to say projection equal to 3D. So let me quickly explain what's happening. Figure is equal to plt.figure. You guys already know what's happening, okay? We're creating a figure just like we did while creating multiple graphs. And this is AX basically stands for axes. You can say chart. Chart sounds easier. Excuse me. Chart is equal to fig.add subplot. We're just adding a subplot 1, 1, 1. It's 1 by 1 dimension, chart number 1. And projection equal to 3D basically tells our matplotlib module that, hey, this chart is going to be 3D, okay? So if you don't know what a 3D plot is, let me quickly explain to you. It's not at all hard. Basically, it involves the z-axis, so it's actually quite cool. Over here, this is our normal 2D plot. Yes or no? Yes. The way 3D works is it's sort of like a cube. So think of this as a cube. Horrible drawing, I know, but it works. This is our cube, okay? You have our dashed line over here, and you have the dashed line over here. So this is a 3D cube. This would be our x-axis, this would be our y-axis, and this is our z-axis. So up is z, right is x, and straight is y. It's a little bit complicated, but you know, it's very interesting. So you have x, y, and z, where z is basically a third dimension, okay? And that's what we have to create. So go ahead, say x, y, z. We're going to use multiple declaration over here. X, y, z is equal to 1 array, 2 array, 3 array. So what's x going to be? X, again, so remember, the number of points you use for x, you have to use the same number of points for y and z. If you create 10 points for x, you need to create 10 points for y and z as well, otherwise an error will occur. So we have x, y, and z. I'm going to go ahead and write some random points. First, 1, 2, 3, 4, 5, 6, 7, 8. For y, I'll do 2, 5, 3, 8, 9, 5, 6. Someone use that. 3, 6, 7, and let's do 1. And then for the z, so this is our third dimension, I'll do 3, 6, 2, 7, 5, 4, 5, 6. Again, I honestly have no clue what I'm typing because I can't think that far into the third dimension, but I understood what I was doing when I was typing the y. Anyways, x, y, z is equal to these three arrays. You can do whatever values you want. It doesn't really matter. The end product matters, and that's really what we care about. And now we have to plot these. So the plotting will be, again, a little bit similar. So it's going to be chart.plot, and we've used this function before, except chart.plot underscore wireframe. And we're using the wireframe to specify that we're plotting a 3D object. Okay? So now just go ahead and put in x, y, z. So that basically says we're plotting a 3D object. Here are the 3 coordinates. And now all we have to do is say plt.show. Save this, F5, and ta-da! Okay, I said that a bit too early. Wait. Okay, we have the restart thing. Here comes the Python launcher. Ta-da! So this is our 3D module. Okay, this is our 3D diagram. This is actually really, really cool. You can go ahead, spin it around, take a look at what we just created. The way you want to look at it is this is our x-axis, or let me see. What did we create? Yeah, I think so. So this is our x, maybe this might be our y, this is our z. Yeah, whichever has 9. Did y have 9? Yeah, okay. So this 1 through 8 is our x, this is our y, and this is our z, the one that's going straight up. So you can sort of correlate. I mean, let's take a look at the first. So x was 1, y was, let me take a look actually. So y was 2 and z was 3. So 1, if you look at it from totally at the top, you can see that y is equal to 2. And if you look at it from the 3D perspective, you can see that z is equal to 3. So again, it is a bit complicated, but 3D modules have, or 3D graphics do have quite a lot of popularity in gaming and stuff, but we have created our very own 3D module. Now, another thing is, if you wanted to, like, you know, say the PNG of this and stuff, it looks bad right now. You have all this gray space. So what I suggest is make this go up a bit. Sorry about that, guys. Been talking for a long time, that's why. But what I do is I go ahead and change the left to make it all the way to the left, bottom all the way bottom, right all the way to the right, and top all the way to the top. And the reason I'm doing this is because at the end of the day, it just gives it a better look, a better feel. You know, you have white space all around, and you know, it's a much more cleaner view than having that gray stuff around. Anyways, awesome job, guys. You've just created your first 3D graphic. Again, if you're not sure what I'm doing, you're supposed to select with your left mouse and you drag. So select, drag, select, drag. Anyways, awesome job, guys. This is, again, our first 3D module or 3D graphic, and I'll see you in the next lecture. Alright, so in the previous lecture, we created a 3D line plot, I guess you'd say. And this lecture and the next 2 or 3 lectures, we're going to be creating some other 3D graphs, okay? So I'm not going to be wasting your time with colors, labels, stuff like that. I'm going to make these lectures straightforward. We're just going to be creating the 3D graph, and I'll explain what's going on, okay? So we have our from MPL toolkits and the matplotlib stuff. We have our fig, and we have this fig add subplot projection equal to 3D, okay? These x and y, z values are all fantastic. We don't have to change them at all. But since we're creating the next chart, actually, that we're going to be creating is going to be a scatter plot. So the reason I didn't do these in the 2D module is because I wanted to save them for the 3D. I don't like repetition. So we're going to be doing these in the 3D module. Hopefully you can figure out how to do them in the 2D. Again, if you have any questions, as I create these 3D graphs, and if you're wondering how to create them in 2D, you can ask me. I'll definitely try to answer, or I'll answer your questions. So to create a scatter module, all you have to do is you have to say chart.scatter, and then you want to scatter the x, y, and z, the coordinates, okay? Then I'm going to say color is equal to red, and I'm going to say marker. So basically marker is how the scatter plot is going to look like. Each dot on your scatter plot needs to look like something. It can be an X, it can be anything you want. Normally you do O. O is basically a circle, it's plain and simple. So chart.scatter x, y, z, color red, marker is equal to O. If you don't know what a scatter plot is, it's basically a bunch of dots scattered on a plot. Pretty straightforward. I mean, if you know what I'm talking about. You can definitely search on Google for charts and stuff. This whole module actually is meant for data analysis, so if you're interested in this sort of stuff, definitely dive deeper into this modules and stuff. Again, I'm only touching the basics of what you can do, but there are tons of things you can do with the matplotlib and stuff like that. So let's go ahead and set the X, Y, and Z labels just because it's nice to know what's going on. Sometimes it gets really confusing. X label is equal to, I'm sorry, what am I doing? X axis, I guess, which I don't know what you want to say. Chart.set Y label is equal to Y axis. And then you're going to say chart.set Z label is equal to Z axis. So Indians say it Z. That's just how we like to say it. I mean, people differ. You can say Z, you can say Z. Doesn't really matter. But that's it. We set our 3 labels, and we have plp.show. So Command S, F5, and now I'll be showing you how a scatter plot is, and it's pretty nifty. I guess that's what you'd say. So this is our scatter plot, okay? And again, scatter plot is basically a bunch of dots representing values. And take a look. So we have our x-axis, our y-axis, and our z-axis or axis. And these are our dots. So as you can see, the O represented those circular dots. We have all these dots in a red color, and it looks pretty neat. One thing I definitely want you to know, and it's actually very useful, the coders thought of it one step ahead, is that take a look at these dots. Suppose we save this image and you were wondering, is this dot closer or is this dot closer? You can definitely tell one is that, I mean, if you were moving it, this dot definitely seems to be more in front. And second of all, you can tell the shade of the color. So this red dot is definitely closer. If we do zoom in, however, let me try zooming in here. It's not letting, what? I'm probably doing something wrong. Anyways, but if you do zoom in and stuff, you'll notice that this dot is a slight shade of red lighter. You can definitely tell the difference, and that's how these guys have made it so that you can tell the difference of which dot is closer to you. Otherwise, if these were the same color, you'd be confused and you'd think, huh, what's going on? Anyways, awesome job. This again wasn't too long of a lecture. We literally did the same code except we created a scatter plot. This scatter plot, again, you can change the color, you can change how the data is, you can change maybe the markers, stuff like that. But this was a very basic scatter plot. Again, if you have any questions whatsoever on our 3D plots, on our 2D plots, on the matplotlib module, please do ask. I'm always there. And this is the end of the lecture. Now, in the next lecture, we'll be creating multiple data sets for a scatter plot. Okay, it's gonna be a lot of fun, and I'll see you in the next lecture. Alright, so in this lecture, it's not gonna be anything too hard. We'll just be discussing multiple scatter plots or multiple data. Okay, wait, let me rephrase this. So multiple scatter plots on one graph, okay? And we'll just be using similar data here. All you have to do is just Command C this, Command V, change each X, Y, Z to maybe X, X, Y, Y, and Z, Z. So we're creating a second set of data. Make all the X's negative this time. And basically the whole concept of this lecture is to show you guys how you can have multiple data sets, data sets shown via scatter plots, okay? So we have this, go ahead and change some of the Y's, you don't have to change all of them. Let me see. 4 is enough, and then for Z's, just go ahead and change whatever you want. Some of them, I guess. Okay, or all of them. Let's just do all of them. Okay, let's leave the 5 and the 6. Okay, so we have X, X, Y, Y, Z, Z. Again, this is with different data, negative data this time, or at least most of it. And it's pretty much the same thing, okay? All you have to do is just say chart.scatter again. Chart.scatter, and then you're going to use the X, X, Y, Y, Z, Z. And then you're gonna say color. So let's do a different color this time. I'm gonna do, let's do blue, and then you can change the marker. So we used a circle last time. Let's go ahead and use a triangle this time. So to use a triangle, you can use the up arrow key. It's Shift 6. Shift 6 gives you that up arrow key. And after we scattered it, that's pretty much all we have to do. So save this, F5. And you're gonna notice a stark difference between the two scatter plots. Again, there wasn't much to this lecture in the first place. I just wanted to show you how you can put multiple data onto one scatter plot. So this is the red, this is the blue. As you can see, this axis over here, so the joining of the x, y, and z, this is the x-axis, the middle of the x-axis, middle of the y-axis is probably somewhere over here, but again, it's on both sides. I think you can clearly tell from the x-axis that these are all positive and these are all negative. So again, the purpose of this lecture was just to show you guys, hey, this is how you can put multiple data on a scatter plot. The blue signifies the new one and the red was our old data. But this is pretty cool. Again, you can see the dark blue triangles and the light faded ones in the background. That's it for this lecture. Again, short lecture, not much to it. But in the next lecture, we'll move on with some more 3D charts. See you then. Alright, so for our next 3D chart, we're going to be talking about the 3D bar chart. And this is actually a little more complex, and it's going to take a little more brain work for you guys to understand actually what's going on. So I've gotten back to our 5 basic lines of code. We're importing the 3D module, we're importing matplotlib. We need to import one more thing actually, and that's going to be numpy. We talked about that a few lectures ago. Import numpy as np, and numpy will allow us for a function that will just make your lives a little bit more simpler. So we have our chart.figadd subplot 111 projection equals 3D. And now you're probably thinking, well, let's just go ahead and add XYZ and add it to the bar. So just, you know, say chart.bar and then XYZ colors equal blah, stuff like that. However, it works a bit different here. So the way I want you to think about it is you have a starting position and then you have the ending position, okay? So the way this works is you first initialize your x, y, z, and then you initialize your delta x, delta y, and delta z, okay? And by doing so, the delta x, delta y, delta z basically tell the bar chart where to end the height or the width, the length of the 3D part of the bar chart. So it is a bit confusing, but think of it as the first 3 as the initial position and then the last 3 as the ending position. So it is a bit complicated, but luckily, again, this is all visual. So I'll write the code, we'll go ahead and run it, and then I'll show you what happens once we start changing stuff. So let's go ahead and write our x's first. So x is equal to our normal thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have y. Y is equal to, again, this can be anything. So this is completely up to you because this can be whatever height you want. So you can do 2, 3, 4, 5, 1, 6, 2, 1, 7, 2. Okay. And then what you can do is you can say maybe z is equal to, or so for z, you want all of them to be 0. So the way I want you to visualize this is this is an initial position. So for z, which is the height, we want our bars to start at the bottom. And then for the delta z, we'll tell them how high do we want the bars to go. Same thing with x. We're starting at 1. Then with delta x, we can say how maybe width-wise do we want our bars to go. So it is a bit complicated, but trust me, you'll get it soon enough. It's not that complicated. So these are, I believe, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And now we're going to write our deltas. So for delta x and delta y, we don't really want to change anything, do we? We just want it to stay there. We care about the height right now. We don't really care about delta x and delta y. So this is where the numpy module comes in. What we can do is say dx is equal to np.ones 10. And what this does is it generates an array of 10 ones. So it's basically creating 1, 1, 1, 1, 1, 1, 1, except we don't have to write that out. It just saves us, you know, some time. So dy is the exact same thing. np.ones 10, okay? And the reason why we're doing this is because we don't want x or y to go anywhere. We're just trying to, you know, make it a little bit, so increase it by 1 to give it that base, I guess. But other than that, we don't want it to move. And then with z, so dz, we're gonna set this equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the height, okay? This is the height of all 10 blocks. So hopefully that makes sense to you. Again, it is somewhat confusing, and once you visualize it, it'll make more sense. And let's go ahead and add this to our chart. So chart dot bar 3D instead of bar. And then it's going to be x, y, z, dx, dy, dz. And then the color, so I'm going to do color equal to cyan, because cyan's a pretty nice color. And then we have plt.show. So Command S, F5, and now you'll hopefully see what I'm talking about. Okay, here's our Python launcher, and here is our figure. So what I'm going to do is I'm going to minimize this, or I'm going to keep it like that, okay? So right now, let's just take a look at the x and the y axes. So what is our x? This is, no, wait, what's our x? You know what, before I even do that, let's go ahead and add the x and y labels so that I don't get too confused. X label is the x label is x label, plt.y label is y label. I feel like I'm forgetting something here. Y label, and plt.z label is, whoops, not x label, z label is z label. Okay, let's Command S, F5. Okay, so I believe I needed an underscore over here. Underscore x label, underscore y label, underscore z label. I think I'm blanking out. Forgot the labels, but yeah. Let me quickly check. I know how to do this. I have done it before. That's why. That's odd though. It's not working. Let me see. Right. Sorry. Set x label, set y label, set z label. Sorry about that, guys. Quick verification right there. So set y label. I guess once you record for a long period of time, you start blanking out. So I guess it's time for me to take a break. So set x, set y, set z, and now we are continuing on. Okay, so that worked. And now it's, it's not, what's wrong? Oh, okay, right. Chart.set label, that's the error I'm getting into. Chart.y label and chart.set z label. Sorry for the delay, guys. I'll definitely take a break after this video. Okay, here we go. So now, seeing that there's an x, y, and z, let's see. So this is 1, 2. Okay, that makes sense. That's 1, 2. 2, 3, 3, 4. Again, I think I'm looking at it the wrong way, but if you look at it like this, and this is the way it was meant to be displayed, you can see this sort of steps, okay? And this is the whole delta z coming in. So remember when we specified x and y just to be 1s and dz to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The dz is giving our bar the height. So you see this height, it's because of dz. Now, if you go ahead and change one of these, let's say the 3 to 10, save this in F5, you're going to notice now that we have one bar, which is a bit too big. So looking at it from the way we're supposed to, our third bar is now 10. So I think you're understanding how the dz works. Let's go ahead and try changing dx to 0. Just something I want to try. So the way this is going to work is 0, 0, is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, Command S, F5. And let's just go ahead and check out what happens. So this is what happens, okay? They become paper thin strips. Not something that we really require, but take a look. So the dx, the dy, and the dz give our they give our bar that 3D look. Okay. So the dx, the dy, by setting them as 1, 1, they make it as a square. So it's now a 1 by 1 sort of square, and then the dz gives it the height. So it's 1 by 1 by 1. So for our first one, it's 1, 1, 1. Second one is 1, 1, 2. So you have a 1 by 1 base, and then the height is 2. Okay. So that's what the dx, dy, and dz do. I'm gonna go back and make this as db1s, np1s, 10. And you know, just for fun, let's go ahead and change out a z. So you're probably wondering, well, why the zeros? Go ahead and try changing one as maybe 3. So again, we're changing the third one to 3. So Command S, F5. And the reason why we put them 0 in the first place is so that they're on the ground. Now, if you take a look, you can definitely see one floating right there. Let me get this to a place where it's, yeah. So these are our 10 bars, and you see one just floating in the air happily. That's what happened when we changed our Z to 3. So the Z value makes it all at 0. The X and the Y value specify where on the graph we're supposed to place them. Awesome job, guys. Again, this was probably the most complicated graph we talked about so far, but hopefully things made sense to you. Again, you know how to add the title, you know how to change the color, you know how to do all that stuff, so I'm not going to go into it, but this was our 3D bar graph. Terrific job, guys, and I'll see you in the next lecture. Alright, so I believe this is going to be the final lecture in our series of Matplotlib, and what a journey it's been. So we have covered a vast amount of data inside of the Matplotlib module, quite a lot than I would have expected, but we did discuss quite a lot of important things. So we started off with the basics of the line plots, we moved on to bar plots and then pie charts. Then we sort of moved on to the 3D area of expertise, where we talked about 3D line plots, then scatter plots, bar plots, and finally, in this lecture, we're going to be talking about wireframes. So again, it has been a fantastic journey with Matplotlib. Let's go ahead and quickly finish off this last lecture, and then if you have any questions whatsoever, please definitely ask. Alright, so I'm going to delete all of this stuff, except for that subplot, and we're going to start from here. So what I want to do is I want to first get my X and Y coordinates. However, you're probably realizing that there must be an easier way to get my coordinates rather than having to input my data every single time. So yes, there is. There is a module, again, Access 3D, that we've imported, and there's a function inside of it that enables us to actually, it generates us random X, Y, and Z data, okay? So all we have to do is say chart is equal to, or actually, I'm sorry. So we already have that line there. We already have that line. X, Y, Z is equal to Access 3D dot get test data. And trust me, guys, this saves us a ton of time while creating this wireframe. So we have to pass in a parameter, and the parameter is basically, you can call it delta for now. And delta here, I'll explain it, but delta basically is the time taken to compute a line. Okay, you're not going to understand it right now, but as soon as we start visualizing it and test out with some different test cases, you'll understand what's happening. So as soon as we get the test data, there's not much to it now. All we have to do is say chart.plot and then wireframe X, Y, Z. And then there's two other variables that you probably should know. rstride equal to 10 and cstride equal to 10. So rstride and cstride basically are how many lines are computed, I guess you could say, or something along those lines. Like, again, I will be showing you visually, so just go ahead, save this in F5. Basically, delta, the 0.05 is how fast these lines are computed, and rstride and cstride are basically the time taken to, or the distance. I'm not completely sure about the rstride and cstride. I'll definitely check it out. But as you can see, this is our wireframe, okay? Right now, as you can see, we have these lines. These lines do look good. But what if we could make it better, okay? So these lines look great. As you can see, every time we move it, it's getting generated and stuff. So try changing the delta over here, let's say to 1.05, okay? Save this F5, and you're gonna notice a vast difference in how our plot looks. It looks like a simple straight line. I mean, you can see the point where it is curving, but it's not at all fluid. It's not curvy. It's straight and pointy, which we don't like. So this immediately tells you what the delta does. It changes the time taken for the lines to be, what would you say, the lines to be computed. Now the rstride and cstride, try changing it to maybe 2, okay? Or let's do 1. Let's do 1 and see what happens. So by doing it to 1 and F5, and don't do this in a slow machine because it will definitely slow down your machine. Changing this, again, it's quite slow, but see how much more detailed it is, okay? the R stride and the C stride basically are the number of lines being generated per piece. There is a better definition for it, but that's the best definition I know of right now. The smaller the R stride and the C stride, the more lines that are generated. Again, it is quite hefty on your processor and stuff, so if you have a slow machine, don't try this out. But you can definitely see how much more detailed it is, okay? A good one to put it would be at like maybe 5, but just for comparison, put this at 10 and put C stride at 1, and you'll notice how the lines are. So you can see the detailed R stride, or I'm sorry, let me move this up for you guys. You can see the detailed C stride lines. Those are the lines going to the, which way are they going? They're going to the right, but you can see how spread apart the C stride lines are, and you can see those thick lines, right? So this is the difference between C stride and R stride. The smaller the C stride, the R stride, the more detailed your wireframe will be. Again, this is the last lecture in our Matplotlib tutorial. So please, if you have any questions whatsoever, definitely do ask. I hope you've had a lot of fun learning about Matplotlib. I know I have. It's been quite a journey actually. I learned quite a lot of new things while creating this tutorial. So hopefully you had fun, and I'll see you in the next section. Alright, so in the previous section we talked about Matplotlib, and we learned how to create some fantastic charts, plots, 3D figures, and so on. And I originally wasn't going to do this module, but then I thought, well, why not? It's a good module, we should cover it, and it's all about data analysis. So for this section, we're going to be talking about the module called Pandas. Okay, Pandas, what do you want to say? Basically Panda with an S. So Pandas is an open source Python library for data analysis, okay? And by data analysis, I mean what MySQL does, what Excel does, basically analyzing data into columns, rows, stuff like that. And that's basically what Pandas does. So before, Python wasn't a fantastic tool for data analysis. You usually had to import it to SQL, maybe even Excel, and it got pretty annoying. So someone went ahead and created Pandas, and now Python is a fantastic data analysis tool. So this again is just an introductory lecture to Pandas. Just to make sure that you have Pandas installed, go ahead and try the line, or actually you know what, go to your the shell, and over here just try importing Pandas. So import Pandas. And if it works for you, that means Pandas has been installed. So back in the last section where we talked about installing, I'm not sure what the module name was, I keep on forgetting this, but where we had Matplotlib, NumPy, and so on, in that list of modules that we had installed, Pandas is also one of those. So you don't have to download anything for this lecture. Again, an introductory lecture, just help you understand what Pandas is, what Pandas does. And in the next few lectures, we'll discuss some key terms that you need to know before we dive deeper into Pandas, okay? Alright, so see you in the next lecture. Alright, so in this lecture, we're going to be talking about a specific term with Pandas. Actually, this lecture, maybe next and a few more, we'll be talking about specific terms. So the whole concept is of data structures, okay? Data structures are basically structures in which you can have data inside. So the first data structure that has been introduced in Pandas is something called a series, okay? So a series is again a one-dimensional object. So when I say two-dimensional, I mean something that has both rows and columns. So it's, like a 2D figure, maybe a square. So it has one side and a top. A one-dimensional, on the other hand, is just a string of, or maybe an array of data, okay? So a series is a one-dimensional object, and it's quite similar to an array, a list, or maybe a column of a table. So it doesn't have any of the rows concept, but it's basically just one column, or maybe one row. It's assigned a label index, so you can call on each object in your series using indexation. I mean, it's probably quite similar to lists as well. And it starts off with 0. So it's quite similar to a list. Let's go ahead and talk about it. So what we're going to do is say import pandas as PD. So throughout this section, and actually in almost all cases when you're using pandas, you're going to say import pandas as PD, okay? And then all you want to do is say give your series a name. So normally series starts with an S. So So you just say S is equal to pd.series, and actually S is capital over here. And then you're just going to specify what is in your series. So you're going to do something, it can be anything again. So it's a series, it can be any type of data. You can have integers, strings, floats, anything you want. So just go ahead and put some random data. I'm going to put 10, namaste, 23.5, and let's do one more, hello. All right. So this is our pandas series, okay? And if you print out S, if you just hit S and hit F5, actually, you know what? I should be doing this in the shell. So let me just, after this happens, I'll go ahead and do that. So what's happening? Okay, it's not gonna work because we're not printing it out. Give me 1 sec here, guys. I'm just gonna write the code back. Import pandas as PD or S is equal to pd.series. And let me just copy my data from here. Sorry about that. Okay. Cool. So now if I print out S, I get 0, 1, 2, 3, 10, namaste, 23.5, and hello. So this is basically your first data structure that you've created in pandas. Take a look. So like I said before, there is indexation in a series. What you can do is after you create a series, you can call on each object by using, you know, the specific indexes. So 0, 1, 2, 3. If you did something like S0, I think this is how it works. Yeah. If you do S0, you get the first index. It's 10. If you do S1, you're gonna get your second index. It's namaste. So what I'm gonna do quickly is I'm gonna minimize this thing so that you still see it because it was quite big right now. Okay. Right, so this is a series where we created a simple array, I guess you could say, and we got an index, so 0, 1, 2, 3. Now, many times when you're creating such data, you might want to use a different index, right? So instead of using 0, 1, 2, 3, maybe you were using letters, so A, B, C, D. Maybe this was a question, and it was a multiple choice question, and you had 4 options, A, B, C, D. How do you do that? How do you change the index instead of making it 0, 1, 2, 3? So there is an index parameter in the pd.series function. So we've created our series, and then what you can do is say comma index is equal to whatever you want. So since there are 4 objects, you probably should have 4 indexes. So let's go ahead and do A, B, C, and D, and D. Okay, and then all you have to do is now, if you print out S, you get A is 10, B is namaste, C is 23.5, D is hello. And now again, what you can do is just like we did with 0, 1, 2, 3. If you say A, you're gonna get 10, and so on. All right, so this was series. Again, you can use series in a multitude of different data. So you can use dictionaries in series, you can use arrays, you can use whatever you want. Let's quickly do an example of dictionaries. So if you do S is equal to pd.series, capital there, and let's go ahead and add, or actually, no, let's actually create the dictionary first and then just call s.pd. So let me delete, okay, no, you can't delete this. So I'm gonna call my dictionary D, and I'm gonna create a very simple dictionary of maybe population. So let's do 5 or maybe 4 cities. Seattle's population might be, I don't know, 1 million. I actually have no clue right now. That's 6 zeros, I believe, yes. Let's do 2 more. Let's do maybe San Francisco. Let me actually, quotations. San Francisco to be 5 million. I actually don't know the population, so I'm just gonna put some random values. 5, and let's do maybe 1 more. Seattle, San Francisco, let's do another S. We'll do San Jose. Okay, so San Jose should be, let's do 1.5 maybe, so 1,500. That is too many. 500,000. Okay, cool. So we have Seattle, San Francisco, and we have this. I believe San Francisco has 1 less zero than we require. There we go. Cool. So D is now our dictionary. What we can do now is let's call a new series, and cities is now equal to pd.series and then D. So in the previous series, we created it with arrays. We are now creating our new pd.series with a dictionary. So if you print out cities now, you get San Francisco 5 million, San Jose 1.5 million, and Seattle 1 million. So this I think this is ordered based on which letter comes first. San Fran, the San are same in both, but since F comes before J, I think that's how it got ordered, that's how it's got indexed. But now that we have seen this, what you can also do is, just like in dictionaries, you can say cities and then get a specific value. So Seattle, and we'll get 1 million. And then there's also the concept of indexing for selection. So this is maybe a little bit confusing, but the way this works is you can do something like cities, and then you can specify, I want the cities in which the value is greater than 1 million. That is 6 zeros. Okay. So if you say cities is, or which cities is greater than 1 million, you're going to get San Francisco and San Jose. So basically all it's doing here is it's checking each city's value and it's seeing, hey, is the value greater than 1 million? And then it's returning only those cities whose value is greater than 1 million. So again, this is a very simple introductory lecture in the series. Let's do a quick recap. We learned how to initialize a series. We learned it's a one-dimensional data structure. We learned how to create a simple PD series using an array. Then we learned how to do it with a dictionary. We learned how it gets indexed, how to change the index. And then we learned how to use Boolean indexing for selection. So we realized that you can get specific results by specifying a parameter. Suppose if you had maybe number of students and you wanted to get those classes which have X number of students, you can specify that parameter over here. You can do something like, I only want the cities whose the value is equal to 1 million, equal to. And by doing that, maybe that'll give us Seattle. There we go. So you can use such parameters to get the specific values you want. Again, we will talk a lot more about this future on. Right now, just try to understand the concept of how Pandas works, how series works. And in the next lecture, we'll go ahead and talk about the next data structure, which is going to be data frame. See you then. Alright, so in the previous lecture, we had a very interesting introduction to series, and we learned how to create a series, how to get some specific results, but we haven't talked about all the functionality there is with series, okay? So let's go ahead and I'm going to create a new dictionary. Actually, not a new dictionary, but I'm going to add on to this, so give it some more values. What I'm going to be doing is I'll be just giving them some smaller values to make our lives a bit more simpler. So San Francisco might be 500, San Jose is 150. Let me go ahead and add 2 or 3 more. Let's do London. Maybe London is 15 or 1,500. Let's do 1,200. And let's do one more. So let's do London, let's do Tokyo. Tokyo is probably 15 million or 16 million, I don't know. So let's do 1,600. Okay, so we've added 2 more values to our dictionary. Again, your dictionary can vary, but the reason I'm doing this is because I want to show you guys some other functionalities with our series. So let's go ahead and create our cities is equal to pd.series function again, and it's going to be D. Okay, so now printing out cities, we have our 5 values: 1,200, 500, 150, 100, and 1,600. All right, cool. So in the previous lecture, we talked about a concept called comparing or finding out specific values. So we did cities is greater than 1 million, and we got these 2 values. So let's go ahead and try something new. Let's go ahead and just print out cities less than 1,000. And we get a list of true and false values. We get London false, San Francisco true, San Jose true, Seattle true, and Tokyo false. So looking at this, basically it's returning us a list of Boolean values for each parameter or each object in our dictionary, and it's just checking to see if the value is actually less than 1,000. So this is the whole concept of using that bool indexation, you know, searching through our dictionary using specific bool concepts and getting our specific values, okay? So that's good stuff. Now let's move on to changing a value. So we've created this series, and the series looks good. I mean, it works. But But let's say one day San Francisco somehow got a million more people in its city. So how do we update San Francisco from 500 to 600? So what we can do is, again, just like a dictionary works, you can say cities, San Francisco, and then set the value equal to 600, right? So now if you print out cities, we get London 1200, San Francisco 600, and the rest stay the same, right? So all that's good. And what if you have to change a lot of cities, a lot of values, okay? So right now doing cities San Francisco, cities London, cities San Jose, that's time consuming, right? We don't have the time. If you had maybe 20 cities, 30 cities, that's easily 10 minutes of work. So the fastest way to do this, for example, if you want to change all these cities to the same number, what you can do is currently, or let's say you want to change all the cities that are less than 1,000 to 750, okay? So you see San Francisco, San Jose, and Seattle, we want to change these three values to 750. How do we do that? Well, the concept here is actually quite easy. What you can say is cities, those cities that are less than 100 or 1,000, we want that to be equal to 750. So take a look at this code. We already know that cities less than 100 or less than 1,000 will return us those cities whose values are less than 1,000. Calling cities of those cities will return us those specific true values, and then once we have those cities, we can easily set their values by doing basically what we did up top over here. So go ahead and hit enter, and now if we print out cities, we get San Francisco, San Jose, and Seattle all to be 750. So hopefully that makes sense to you. Basically, all we're doing is the same thing as we did up here, except to get that city name, we're using that Boolean parameter, cities less than 1,000. Now let's say we've created a series, okay? And we created it somewhere way up top, and we're wondering, did I add Seattle to my list? Did I add San Jose to my list? If you're not sure whether an item is in a series, you can check using idiomatic Python. So the way that works is, all you have to do is say print Seattle in cities. So what this does is it returns, hey, is Seattle in cities? And if it is, true. Let's go ahead and try with one more city. Print, that's not a city actually, let's do Delhi. If print Delhi in cities, so since it's not there, it's going to return false. So this is something called idiomatic Python, where you're checking for each value inside of the dictionary. So we're basically printing to see, hey, is this city in our cities series? Now again, you can use mathematical operations with our series. So right now we have all these different values, and as you can see, they're all divisible by 10. So what if you want to divide all of them by 10 and remove the zeros, stuff like that? What you can do is just say cities by 10. And what that does is it gives you an updated cities with all the values divided by 10. So instead of 1200, it's 120, 750 to 75, and so on. So you can also perform mathematical functions with cities or with series. So you can do the square function, so np.square. Np again stands for numpy, but we haven't really imported that yet. So go ahead and import numpy as np, and then you can say np.square cities. So that returns us all the squares of the values that we have done. So taking a look at this, taking a look at what we have done, what we have accomplished, you can see how data analysis is happening. I mean, you can update values, you can divide, you can perform mathematical functions, you can get specific values using Boolean operators. So by now, I hope you're getting the concept of how Pandas will enable us to do data analysis with Python data. So let's go ahead and finish up this lecture. One last concept we can talk about is adding, not adding, but basically checking to see if a value is null or not. So what we can do is we can say the concept of cities.isNull. And what that returns us is it checks to see if any of the values is null. As you can see, you got all false, meaning that all of them have values. So that's it for this lecture. We discussed quite a lot of new functions. We learned about the np.square, performing mathematical functions with series. We learned about how we can use specific Boolean operators to get specific data, change all the data at once, stuff like that. So now you should have a better concept of data analysis, at least with series. And in the next lecture, let's go ahead and move on to our second data structure, which is called data frame. Alright, so in the previous lecture, we finished up with our one-dimensional data structure, and that was the series, okay? So by now you've understood, hey, this is how a series works, this is how I can get data from a series, this is how I can get specific data, updating values, stuff like that. And we're moving on to our two-dimensional data structure, and that's called a data frame. So a data frame is a tabular data structure that comprises of rows and columns. And when you talk about rows and columns, well, you get the idea of maybe an Excel spreadsheet, or if you've used R, maybe a data.frame object, something like that. But basically a concept of rows and columns. So if you guys have used Excel, if you guys have used maybe spreadsheets and stuff, you know what I'm talking about. Those are rows and columns. You have rows, you can specify the columns, stuff like that. And for the remainder of Pandas, and for most of Pandas, we're going to be using data frames. So let's go ahead and talk about how to create a data frame, how that works, and stuff like that. So import pandas as PD is going to be our first line, and that's always necessary to get those data frames, those series up and running. So let's go ahead and wait for that. Okay. Now we need our data. So the way this works is you can specify maybe a dictionary. So to create a data frame out of common Python data structures, you can pass a dictionary of lists to the data frame constructor. So if you're confused by what that means, let's go ahead and show you. First of all, we need some data. So the most common sort of data is normally like students, age, or I'm sorry, wait, let me think about this. So students, marks in subjects, I guess that's how it usually works. So let me see. Okay, I think I got this. So let me get data back over here. Whoops. Okay, so the way this works is you say something like students, and then you say colon, and then I'm going to put in some five students. So I'm going to put AJ, Mark, Bob, Rachel, and Steven. I don't know, some 5 random names. Okay, so this is our first data. Okay, this is our first, I don't know what you want to call it. But right, okay, so this is giving me problems. Okay, so let me go to the next slide to make my code a bit more easier to understand. So what I'm going to be doing is I'll be just typing it in this. I know it might be a bit time consuming, but I really don't like the shell right now. So let me just quickly get that concept back over here. Import pandas as PD. Data is equal to, okay, and see this gives me a little more leavage. So over here we're going to have students. Let me just copy that from here. Student is equal to those 5 random people. Command C, Command V. Okay. Now our next is maybe marks. So let's say maths. So what did they get in maths? Maths will be what was AJ's. I'm okay. I'm good at maths, so I'll give myself 98. This is out of 100. Mark was horrible. He got 50. I should not be doing that and that. So 98, 50. 23, 72, and 87. Okay, let's do science. I'm good at science as well, so let's go ahead and give myself 96, 45. This guy was very good at science, not too much, and he failed. Let's go ahead and do sports. So what sports did they play? I play basketball, table tennis, etc. So I'll just do basketball for my side. Mark did swimming. Bob did TT or table tennis. And Rachel did badminton. And Steven did taekwondo. I'm not sure if that has an E. That's okay. So taekwondo. So we got 4 sets of data. We have the students, we have math, science, the marks of maths and science, and then we have the sports that we play. I'm quickly gonna check and see how to spell taekwondo, and it's with D-O, not D-O-E, so I'm good with that. Cool. So we got our data, and that's probably what we wanted. So I think you hopefully understand what's happening here. So the students, math, science, sports are basically the column names, okay? And then these are the column values. So in the first column, which is called students, we have 5 values. The second column, which is called maths, we have 5 values and so on. But as soon as we create our data structure or data frame, you'll understand what's happening. So now what we have to say is you have to call or create a data frame. So I'm going to call this data frame as students. And I'm going to say this equal to PD. Now, instead of using series, you're going to be using data frame. Hopefully you understood that. And now you're going to say data frame is equal to data, and then comma, you can say what the columns is equal to. So the columns here should be equal to basically whatever you put in your data. So data, comma, columns equal to our 4 things. So students, we had maths, we had science, and we had sports. Okay, so I mean, honestly, it doesn't really matter what data you've used here. It just has to be equal. So if you had 5 people over here, you might as well do 5, 5, and 5 over here. You can add values empty, that works too, but it's better not to. And now what we have to do is just print out students. So print students. All right, save this F5. And let's take a look. It gives me invalid syntax. That's because I've used a semicolon. Ha ha ha. Save this F5. Okay, again, invalid syntax. So let me take a look. Let's see. It might be because of the space. I didn't give a space. Or let me take a look. Import pandas, data. Okay, I forgot the commas. Comma, comma. Save this F5. And we get we are getting, yeah, cool. So we got students. Students is returning us none. That means you couldn't find the data. Let's go ahead and take a look at what's wrong there. But math, science, and sports all have returned us the proper data that we wanted. So awesome job there. Let's go back and see why did it work. So students colon. Oh, yeah, obviously it didn't work because there's only one value. So let me quickly change that. I'm sorry about that, guys. And now we should see our data frame. Taking a look. What? That didn't work as well. So let's go back. Let's see. Students colon. Oh, okay. So I'm sorry there, guys. Let me quickly, I think the problem is because my students over here isn't capitalized. Let me try that again. Yes, there we go. So I think this columns over here correlates to what's happening over here. So when you say pd.dataframe data, then after when you specify columns, you can change up how you want the columns to be. So do you want students to be first, then maths, then science, then sports? Or do you want sports to be first and then, I mean, you could change it to stuff like that. But now if you take a look, we have students, math, science, and sports with our indexation as 0, 1, 2, 3, and 4. Awesome job, guys. In this lecture, we learned how to use a data frame, how to create a very basic one, and specify the columns. So great job, and I'll see you in the next lecture. All right, so I have Excel open, and the reason for this is, think about it. So normally when you're using Pandas, when you're using data analysis with Python, you're gonna have your data somewhere. You're not gonna be typing it up in the Python script. So the most popular data type is the .csv file, right? And what we're gonna be doing is we're gonna be creating a .csv file in Excel, and then we are going to be opening it up in IDLE and displaying the contents. Okay, so nothing too complicated, I guess, but you know, it'll be fun. So what I want to do is just in this lecture, you're going to create a very basic, very basic, what are we creating? A CSV file, I'm sorry. So let's go ahead and I'm going to call this date. I'll call this A, B, and C. And then let's go ahead and put in some values. So let's do 2015. 0101, 2015 0102, or I guess it's month and then day, so 2015, oh that's right, 2015 0103. Okay, now for A, B, and C, you can do whatever you want. I'll do A, B, C, 132 and 332. Okay, so this is our very simple Excel doc. Again, you can do whatever you want. You can have maybe something to do with food, maybe a menu, literally anything, but make sure to have some columns and rows. And you're gonna save this as, I'm gonna call this just test data. And you would have formatted it as .csv. So right now you can't see it, but it's right here. So comma separated values, this is the one you want to select out of format. So make sure that's selected. It's called test data, saving it in documents. Save it there. Awesome. It gives me this. It says this workbook contains features that will not work or may be removed. If you save it in the selected file format, go ahead and hit continue. And fantastic. So we created our CSV file. That was the goal of this lecture. And in the next lecture, we'll go ahead and read it in our Python IDLE. Alright, so in the previous lecture, we created a very basic CSV file. Okay, and we called it testdata.csv. And in this lecture, it's going to be very simple. All we're going to be doing is we're just going to display that data and learn one or two ways on how we can play with it. So let's go ahead and import pandas as PD. And then the command I want you to use to read this data is going to be the function pd.readcsv. Okay, so let's go ahead and do that, pd.readcsv. And then the parameter that you pass over here is what is your CSV file name. And for that, ours was testdata.csv. So hit enter and ta-da. So we got date ABC and then we have 012. So the 012 here is basically the indexation. You can get the specific rows by doing what I showed you in the previous lectures. Now, with this data, there are many things that we can do. Throughout the next few lectures, we're just going to be using data frames. So the first function that I want to talk about is changing this date ABC. Many times you're going to have your own headers that you want to use. You don't want to use these headers. What can we do to change these? So instead of ABC, I want to make it hello Bob cat. I don't know. And the way we can do that is by calling the function p.readcsv and then pass in a parameter. So we have testdata.csv, comma. We're gonna say names. Names is equal to basically whatever you want to call your four columns. Let's go ahead and call them pizza, cat, dog, cheese. Okay. And if you do that, you have now pizza, cat, dog, cheese. But however, we still have our date ABC. So how do we get rid of that? Well, what you have to do is you have to specify header is equal to none. Okay. And by doing that, it basically removes whatever header was before, and that was a date ABC, and then it'll put the new header, which is pizza, cat, dog, cheese. Okay. So by doing that, well, let's see. No, it's not working. That's odd. So let's go ahead and try putting header equal to 0. I think 0 will help us actually, not none. Yes. Okay. So pizza, cat, dog, cheese is now our new header. We have 012, our rest of the data. When you put header is equal to none, it just made the next our header a new row. So sometimes when you have your Excel data, you won't have a header. You'll just have that data. It'll just be whatever this is. You won't have that ABC stuff. So what you can do then is you'll say header is equal to none to make that first row go down. And then you'll put names as whatever you want. So whatever headers that you wanted, that is what you're gonna choose, okay? So one last thing before I end this lecture. We have understood how to get the CSV. What if you had a ton of data? So let's see here. What if I only wanted maybe one column or max 2 columns? So right now we have 4 columns. One is pizza, one is cat, one is dog, one is cheese. Again, they're not the best columns. You could have probably chosen some better names. But what if I only wanted the first 2 columns and I really didn't care about the dog, cheese? What did I do about it then? So the next parameter we're going to be talking about is called the useCalls parameter. So let's go ahead and just get that test data back. pd.read CSV, test data.csv, and let's go ahead and go back to our normal columns. Okay, date ABC. So what if I only wanted date and A? How does that work? So the function again is going to be the useCalls function. So I'm going to go ahead and bring this back down. And in here, pass the parameter useCalls. So useCalls again is short form for useColumns, and you basically specify an array of which columns you use or you want to use. And in this, you can either specify the name of the column, so you can do something like, oops, I'm sorry. You can either do something like date, A, okay? And again, that gives me an error saying it's not in the list. So the better way to do it is actually to just specify the number. So what position is that column on? Date is 0, A is 1. So immediately we get date equal to whatever it was, and the other 2 columns are gone. So pd.read CSV, test data.csv, and then using the useCalls function, what you can do is you can specify which columns you want to use. For example, if I want the first column and I only want maybe the 3rd column and the 4th column, no, I don't want the 2nd column, I'd use something like this. useCalls 0, 2, 3, hit enter, I get date, B, and C. Alright, awesome job guys. In this lecture, we learned how to read a simple CSV and play around with the data, you know, specifying which columns you want, specifying how to get those headers, change up the headers and stuff. But great job. In the next lecture, we'll learn how to write to a CSV. So now that we've played around with the data, how can we export it out back as a new CSV file? Okay, so see you in the next lecture. Alright, so this lecture is going to be simple and sweet, and basically we're going to learn how to write to a CSV this time. So by write, I mean we're going to have a data frame, and we're going to save that data frame as a new CSV file. So first thing first, let's go ahead and get our original data frame there. Our original data frame was testdata.csv. And let's go ahead and modify it a bit. So I'm going to say new CSV is equal to pd.read CSV, okay? And then let's go ahead and pass in some parameters. So the first parameter is your file name, testdata.csv, okay? And then after that, let's go ahead and using the knowledge that we learned a few lectures ago, or last lecture, let's go ahead and change some stuff. So headers is equal to 0. This data is only going to have 3 columns. So let's go ahead and say names is equal to let's just do food, price, and quantity. Okay, quantity. So that's good stuff. Header is 0, name is equal to that, and then let's go ahead and say useCalls. I'm going to use my 1st, 2nd, and 3rd. The date one will go away. So hit enter. It gives me and says unexpected. Extra S over there. So header is equal to 0. All right. Print out new CSV. What do we get? We get food, price, quantity, ABC 1, 2, 3, 3, 3, 2. So this looks good. This is our new CSV. And now what we want to do is we want to get this as an actual file. So it'll save us, you'll be using this data now. So to do that, what we can do is you can say new CSV dot to CSV. All right, just take a look at this. New CSV is our file name, our data frame dot to CSV, and then basically all you say is whatever your new file name is. So I'm going to say testdata2.csv. So to verify now, one thing you can always do is go ahead and do this whole line again, except just remove this stuff. So let's go ahead and try printing it out now. So testdata2.csv, and what do we get? So new CSV now is this. You get an unnamed, that's fine, that's an indexing issue, but we got food, price, and quantity, which we wanted. Let's go ahead and view this in our Finder. So one sec here, let me go to my documents. Yeah, you guys can see what I work on. But going up, testdata2.csv, let's open it up with Excel. All right. As you can see, that 0, 1, 2 happened because of the indexing. In the next lecture and the next 2 lectures, I'll be showing you how you can get rid of the indexing, how to index in a different way. However, good job. As you can see, we have updated the values. We got food, price, quantity. We got rid of date, and we have now saved it as a new test data2.csv. Awesome job, guys, and I'll see you in the next lecture. Alright, so in this lecture, we're going to start actually playing around with some actual data. So right now, we've been using some random data, but now it's actually time to get some serious data and start playing around with it. So I'm going to be taking data from MovieLens. Basically, it is, it said somewhere over here. So we're going to use MovieLens 100K. Let's take a look at the index of unzipped files. And basically, it is a data set of 1,000 or 100,000 ratings made by 943 users on 1,682 movies. So what I want you to do, guys, is, again, it's grouplens.org/datasets/movielens. I should be providing this download in the download section. You should go ahead and check it out. If it's not there, I'm sorry about that. Then go ahead and go to this website, again, grouplens.org/datasets/movielens. I can't speak. And you want to click on this link, ml100k.zip. So I've downloaded it. Let me just go ahead and open this up. Okay, so my archive utility is opening up. And I get this. So scrolling down, MLK100, where did it go? Okay, so it's over here, ML100K. Opening this up, you have all these different files. So it's in my download section. I'm going to move it to my document section. And there we go. So now it's in my documents, and we're going to be using this file for basically this lecture and hopefully the next 2 or 3 lectures. So going back to my IDLE, let's get started. So first thing first, we need to import pandas. That is absolutely necessary. As soon as we do that, let's go ahead and get started. So I forgot to write import pandas as PD. I'm sorry. There we go. Now we have to specify what our file name. So we're going to be using the users file in this. So I'm taking a look, going to our index of unzipped files. So we're going to be taking a look at the u.user. So basically what this is it contains all the data of the users, the user ID, their age, their male, female, their gender, their occupation, and their zip code. So that's the data that we want to get into a data frame. Okay, so user or users, let's do users, is equal to pd.readcsv. And now we're going to specify the file path, I guess, ml100k/u.user. So that's the file name. And right now, taking a look at this data, well, what does CSV stand for? CSV stands for comma separated values. And you know that there's commas, right? So whenever we use the this function over here, pd.readcsv, pandas searches for commas. However, right now, all there is are those shift backslashes, those straight slashes. So we have to tell pandas there's no commas. Instead, you have to search for these slashes. So let's go ahead and add our second parameter, sep is equal to straight slash, okay? And then last but not least, we need to add the headings. So right now, as you can see, there's no headings, there's just data. So names is equal to, let's go ahead and add it. First was user ID, second was age, third was gender, and fourth, fifth were occupation, and so on. So occupation, and we have our occupation and zip code. Awesome. So hit enter and it's worked. Okay, so we have no errors whatsoever. And if you print out users, you're gonna get a bunch of data. So this is the first function we're gonna talk about today, and it's called .head. And what the head function returns, instead of throwing at you all those 500, 1,000 lines of data that we really don't have any use of, we just want to see, hey, how does our data frame look like? Instead of throwing that at us, what you can do is you can say users.head. And what the head function returns is, as you can see, the first 5 lines of our data frame. So again, it saves us a lot of scrolling through and all that stuff, and it doesn't slow down our IDLE that much, and it's neat. So as you can see, we've generated a data frame. We have user ID, we have age, we have gender, we have occupation, we have zip code. So I think so far so good. In this lecture, we learned how to use a separation key, what the head function does, and how we got a huge amount of data into a data frame and only printed out part of it. So in the next lecture, what I want to do is, again, I'll move on with our functions and data frame. We'll talk about slicing and some other good stuff. Alright, so in the previous lecture, we imported our ml100k/u.user file. We separated the data out and we finally created our data frame. So all that's good. Now let's go ahead and talk about some functions that we can use in our pandas module with this data frame. First of all, we talked about users.head, and that returned us the first 5 lines of our data frame, and that was fantastic. Now the next thing I want to talk about is a tail. So if you're one step ahead of me, you probably have understood that the user.tail function returns me the last five lines of our data frame. And one more neat feature here is that you can also do is specify how many lines of code you want. So if I only want the last 3 lines, I can do users.tail.3. If I want the first 2 lines, I can do maybe users.head2. Does that work? Yes, it does. So this head and tail is useful when you want to sneak peek at your data, but you don't want the whole thing to be printed. Okay, so that's head and that's tail. Now, if you remember in the beginning of the section, I talked about how you can also do slicing. So let's go ahead and discuss how that works. For example, if I want the 10th guy to maybe the 13th guy, okay, not the 13th, 13 is an unlucky number. Let's do 14. Just like in arrays, so when you talked about the concept of slicing, it's the exact same thing here. What you can do is you can say users, again, it's 10 to 14, so we're going to do 10 to 15. And we'll get 10, 11, 12, 13, and 14, okay? So taking a look at this data, index-wise, we got it correct. However, user ID-wise, we got it 11 to 15. That's something you could play around with, I think. Yeah. Wait, so, yeah, because R starts at 0, you'd have to do one more, so it would be users, 9 to 14, and that would return us the proper data. So over here, user ID 10 to 14. It's a little bit confusing because they start at 1 and the indexation in Pandas starts at 0. But anyways, that's slicing for you. Again, there's many different things you can do. You can do maybe 5 to, or let's do 900 to everything. Does that work? Yeah. 900 everything prints us everything that's from 900 and above, so that's going to give us 44 rows of data. And then just like we talked about arrays, going back to that, it's the exact same concept. So you can do whatever slicing we talked about in arrays. You can do users 3, and that's only going to give you the first 3. You can do users, I don't know, -2. What does -2 give you? It gives us everything except the last 2 rows. Okay, so that's pretty good. As you can see, it cut the data over here because, hey, who's going to go through all of that lines? Anyways, it saved ourselves some time. So awesome job. In this lecture, we learned about slicing. We learned about the head and the tail. Again, you're probably noticing I'm cutting these lectures a bit short. The reason is Pandas does get a bit confusing as we go later on. So I'm just, making these lectures nice and simple so that you can understand. In the next lecture, let's go ahead and go back to that Boolean stuff we talked about with the series. So that Boolean indexing, stuff like that.
Alright, so we're finally here with the good stuff of data frames. We're going to talk about Boolean indexing. But before that, I do have 1 or 2 more functions that I want to talk about with data frames. So the first one is, again, take a look here. What you can do is, if you want a specific column, right, you can do users and then that column. So users, let's say I want, what was our heading names? User ID, age, gender. So let's say I want the genders of all these people. And again, I don't want all of them, so let's do head 10. Using that, I can get the genders of the first 10 people. So looking at this data, again, it's a bit confusing. I mean, you have all these conflicting numbers. What if I just wanted the zip codes? What if I just wanted the gender? To do that, what you can do is, again, users and then in square brackets, whatever column you want. Okay, so that's one way to simplify the data.
second thing I want to talk about is multiple columns. So we got gender, but how do we get all the columns that we want? Okay, so we have our CSV. We're not trying to rename the columns this time, but we basically just want to see these columns from our data frame. The way we can do this is just specify more columns. It's better if you specify an array and then put the array here, but what you can also do is, just specify it like this: occupation, zip code, okay, and then I just want the head of it. I don't want to print it out all. And it gives me an error saying key error, occupation, comma, zip code. Let me take a look if I spelled it right. Occupation, zip code. All right, so I think the reason why it's giving me this error is because it does want an array. So let me go ahead and first create an array of columns I want. So columns I want, and set this equal to occupation, comma, zip code. And then let's go ahead and put that in my users thing. So users columns, I shouldn't have made it that big actually, and then dot head, and that gives us basically the occupation, comma, zip code. So I was wrong actually up here. I'm sorry about that, guys. I thought it would work if I just specify occupation, comma, zip code there itself. Looks like it takes, if you have multiple objects, it wants an array, not directly putting it there. But now it's returned me the occupation column as well as the zip code column. So this is quite neat for when you have data that has several 20, 30 columns and you only want some specific ones. Like if you have a stock column, and we'll get to that in the near future. If you're parsing for Yahoo stocks and you have all these release, sell, all that random stuff, and you only want maybe the quote and up and down and stuff, that's where you could use these multiple column concept. Okay, so that was multiple columns. Next thing is, our Boolean indexation. So let's go ahead and get started with that. So we talked about it briefly in the series, how we can use this Boolean indexation, that greater than, less than stuff. We're gonna talk about it more in this series, okay? So let's say I want the users whose age is greater than 35, okay? So I am a movie developer or a movie producer, and I was looking for critics, except I don't want young critics, I want old critics. So what I can do is I can say users and then whose users.age is greater than 25, print out the head of that. So that gives me an error saying data frame object has no attribute, which is age. Taking a look, what did I call it? I should have called it age actually, yeah. I think it might be capital A. That might be there actually. So bringing this back down, I think capital A might be the issue. Yeah, okay, so basically one key thing that I should have told you guys, and I actually just made a mistake on here, is you can access each column's value from your data frame by specifying your data frame name dot the column name, and it is case sensitive, so if you have a capital column name, then you must specify that. If you're not understanding what I'm saying, basically you want to say users dot whatever column name you have. If I want the zip code of all my users, I'd say something like user dot zip code, but it gives me invalid syntax. Okay, so it's better to specify it like that, but it's gonna give me an error. So I'm gonna make a quick change here, guys. I probably should have done this much earlier, but going back to this user equal to PD stuff, I'm gonna put an underscore in my zip code and an underscore in my user ID. And you're probably wondering, well, why am I doing this? The reason for that is because when I try to call users.zipcode, Python gives me an invalid syntax saying that, hey, why is there a space here? So it's better to keep all your column names one word, otherwise you won't be able to access them later on. Okay, that's another mistake I made. So looks like it's worked. Let's go ahead and try users.zipcode now. Users.zipcode. And that gives me 942 zip codes. Okay, so again, going back to Boolean stuff. Let's say I want male people who are less than 35. Okay, so how would I do that? Here's a challenge for you: male people who are less than 35. All right, ready, set, go. If you got that, that was fantastic. Let's go ahead and try it out. So again, it's gonna be users, and then you're gonna specify in here those users. or I'm sorry, so those users whose age, what did I say? I think it was less than 40. I'm not sure what I said, but those users whose age is less than 40, and so this is again where those conditional statements come in. You're gonna put and, only one, not two, and those users who are male, right? So you're gonna say, so users age less than 40 and users dot gender, so capital G and capital A over there. That's one thing I forgot. Users age less than 40 and users dot gender who's equal to male. So we're looking for males under 40, and let's just go ahead and get the head of this. I don't want to get too much information. There we go. So our first, third, fourth, eighth, and ninth guy are all male, and they're less than 40. So that's pretty cool. If you want to check them out, that's fine, but I'm joking. Okay, so we got this. Let's go ahead and try one more. Let's do females who are writers. Females who are writers. So again, here's another challenge. We saw how we did this. You saw this. Let's go ahead, replicate this, and give me 5 females who are writers. Okay, so I'm gonna pause the video here. All right, if you manage that, that's fantastic. Otherwise, it's quite simple. It's gonna be the same concept where we're gonna say users dot gender this time is equal to female. So we're looking for females, and the second parameter we said was users. Who were writers, right? So we're gonna say and users dot occupation is equal to writer. So let's go ahead and get the head of this. We get 5 results. We have female and they're all writers. So hopefully by now you're understanding, hey, Pandas is actually pretty awesome. I mean, we're now editing data, we can modify, we can change, stuff like that. And the whole power that you have with Pandas is huge. So if you actually want to make Python your primary language and stuff, definitely take this further. Right now, this was good stuff. Let's do one more example. So in the past, in these 2 examples at least, we've been using the and. Let's go ahead and do one example with the or. So I want male people or those older than 60. So there's a challenge for you guys. Return me 5 rows which have male people or they have people older than 60. So obviously, I think we're gonna get all males, but let's take a look. So users, we have users dot gender is equal to male. Okay. And then we're gonna say or. So if you guys remember in our conditional statements, we talked about how it's double, so and or actually type it out like this. But in Pandas, it's like this. So just an or statement. Or is this, and is that ampersand sign. And then or you're gonna say, I believe it was users greater than 60. Yeah, people older than 60. So let's go ahead and do that. Users dot age greater than 60. So let's go ahead and try this out. Oh, I should use head for that. I'm sorry. That's too confusing for me. So dot head, and we get 5 results. And as you can see, all of them are less than 60. So the reason I said we're probably gonna get all males is because when you think about it, in our data, going back over here, a lot of them are already males. And to find a female who is greater than 60 or even a male who's greater than 60 is pretty difficult. Looking at the first 20, 30, 40 lines of data, I'm not seeing anything. Okay, I found one 60 person. All right, 61 and retired. That's obvious. But okay, good job, guys. In this lecture, we talked about Boolean parsing or Boolean indexation, and we learned how we can manipulate our data. So that's good. Now we're gonna go ahead and continue this. So we do have a few more functions that I'm gonna talk about. And yeah, so that sounds good, and I'll see you in the next lecture. Alright guys, so this following lecture, or this lecture, is going to be quite a lot of fun, okay? And we're going to learn some pretty neat ways how to index, how to replace the index, and stuff like that. So right now, as you can see, I no longer have my data per se. So if you don't mind, you can just wait 1 or 2 minutes here. So import pandas as PD and then pd.read CSV. Give it a few seconds here. So pd.read CSV. So users is equal to pd.read CSV. I'm sorry about the delay, guys. I probably should have not restarted my IDLE, but I did, and I'm sorry. So ml 100k / u.user. Okay, and we did sep is equal to /, and we had names is equal to. For now, I'm gonna just make them back to lowercase. Just save me a little bit of time here. Don't have to hit the tabs key or caps lock key or shift key. I'm sorry. User ID, age. One too many there. Age. We had gender, so gender. We had occupation. We had zip code. Okay, so when I type zip code or when I type user ID or age or gender or occupation, if you wrote yours in caps, then make sure you please write them in caps. Again, I'm restarting it and I didn't write it in caps, but if your column names are in caps, then please remember to use them in caps, otherwise you're going to get an error. Okay, so this is our users, and right now printing out users.head, it looks good. So we have everything back, it's all great. So before I talk about some indexing functions, I want to just quickly touch base on two other functions. The first function is going to be users.dtypes, and what dtypes is it returns the data type of your columns. So as you can see, our user ID and our age are both integers. Gender, occupation, zip code are all strings, so it's return an object. User.dtypes is a very useful function when you're trying to figure out, hey, what's in each column, stuff like that. The next function I want to talk about is something called users.describe. And the users.describe function is very useful when you have integers in your column. So it only picks up the integers. It's picked up the user ID and it's picked up the age. Count basically returns what is the number of items in that column. So forget about user ID. That's not really useful, but the age is useful. So there's 943 items in our age column. The mean is 34. So this is huge. Instead of having to calculate the mean by using some random Excel function, just hit users.describe and you got the mean. So the mean here tells us it's 34. What does that say? That means that the most common person who is voting is a middle-aged man, okay? So that's definitely useful information. This is all data analysis right here. You have the min and you have the max. Min is 7. So the youngest person to vote was 7 and the oldest was 73. He's probably retired. But this is a describe function. So if you ever need to do some quick mathematical function like count, mean, min, max, those simple Excel functions, that's where you'd go. You'd use users.describe. Okay, so the next thing I want to talk about in this lecture is going to be, again, indexation. So it is a bit complicated, but as soon as you understand what's happening, you'll get it. So right now we have, if I do users.head, excuse me, I should probably get myself some water. But we have users.head and we have these 5 columns. That's fantastic. Except we have this recurring the pandas index itself, the 0, 1, 2, 3, 4. So we did talk about how to use the index call function to make user ID as the set index. But what if I don't want to reinitialize the file every single time? Shouldn't there be an easier way to set the index? Well, guess what? There is. The function I want you to use to set the index is going to be users.setIndex. Users.setIndex, and then just specify which column you're using. So let's use user ID dot head. Okay, and that returns us user ID as the index. Okay, so now things have changed. However, if I print out users.head, what do I get? See, now I get back to that normal index, and I don't like that index, okay? I want to permanently change my index, okay? So, if you want to modify your existing data frame, we have to use the in-place parameter. So, go ahead and let's say users.head, users.setIndex, user ID, and then comma, you're going to specify in place equals true. So the first time when we were doing it, this part, users.setIndex, userid.head, we're just saying to show us the results when user ID is the index. However, when we're saying this, the in place part, we're saying change it completely. Don't just show us, change it. So now, if we print out users, we no longer have that issue of that index coming now. Okay? So all that's good. Now, the next part is, let's try slicing this. So we got rid of that random, the index pandas was providing. We have the user ID now, and we want to slice this, okay? So I want to get from 10 to 14. Okay, so now I'm probably thinking, well, hey, it should be much easier now. So it's actually going to be 10 to 15. However, yeah, so we get 11, 12, 13, 14, 15. That works. Another way you can do this, suppose I want to get like first, second, and third. What happens? It gives me an error saying that doesn't work. What you can do is selecting rows. What you have to do is you have to use the ix method. So you're going to say users.ix, and then in here, you are going to specify the rows that you want to see. Suppose I want to see the first row, 12th row, and 32nd row. It returns us 1, 12, and 32. Note how I put two arrays, one inside of the other. If you try removing an array and just do 1, 2, 3 in that, it's going to give us other. So the ix function, again, it takes in the two arrays instead of one, so it's two square brackets. That's something key. Okay, so this is good stuff. In this lecture, we discussed quite a lot. We learned how to set the index permanently. We learned about the describe and the dtypes function. And then we learned about slicing and the ix, where using the ix function, users.ix, you can choose any row you want. So if I want the 112th row, 543, and 912. Close it. It returns me those three rows. So awesome job, guys. Hopefully now you're understanding pandas, you're getting comfortable with it, because that was the whole goal of this section. That's it for this lecture. If you have any questions whatsoever on this lecture or any of the previous lectures, please don't hesitate to ask. I'm still learning pandas, so I'm not completely experienced with it, but it's definitely been a learning experience with me creating these videos, understanding how pandas works, stuff like that. So see you in the next lecture. Alright, so in the previous few lectures, we have been discussing data analysis with Python and with pandas. And so far, so good. We have discussed quite a few functions. In the last lecture, I believe we left off with the ix and the head and all that random stuff. Or I mean good stuff, I'm sorry, not random. And in this lecture, we're going to talk about something called joining. So many times we'll have many different data sets or many different data frames. And at the end of the day, you want all that data to be in one single data frame. So to do that, Pandas has created a function, and that function is called merging. Okay, so the function itself is pd.merge, but there are four different ways you can actually merge. So the first way is, there's four different parameters you can pass in while merging: left, right, outer, inner. So let's go ahead and discuss all four of those concepts. Before that, we have to create two different data sets or two different data frames. Let me go ahead and do that. So left frame, I'm going to call this frame 1 and frame 2. So import pandas as pd. And then we're going to create two frames, frame 1 and frame 2. So frame 1 is equal to pd.dataFrame. And then we're going to say, we're going to be creating a dictionary like we did, I think, in the first lecture of data frames. So it's going to be key and value. So key. And instead of doing an array, I'm just going to do range of 5. So range 5 will return 0, 1, 2, 3, 4. And comma, let me go ahead and get one more. So we got key, and then let's do frame 1 value. Let me just do frame 1. So frame 1 and colon range 2, 7. So we're doing a bit different values here. So 2, 7. Okay. All right, I'm sorry. So we have key as 5, and then let's go ahead and just put an array of letters. We weren't supposed to do numbers. So it's numbers for key and letters for the next value. So go ahead and put any you want. I'm going to do A, B, C, D, and E. Okay. And then let's go ahead and create frame 2. So frame 2 is equal to pd.dataFrame. Same thing, except go ahead and change up the key values this time. Do it like this, so do range 2,7 this time. So some numbers will overlap, some won't. The reason I'm doing this is because I want to show you all the different ways we can get these values. So frame 2, A, B, C, D, E. So let's do T, U, V, W, and X, T, U, V, W, X. Okay, so that looks good. These are our 2 data frames. So let's go ahead and talk about merging now. Printing out frame 1, what do we get? We get frame 1 and key. Let's go ahead and print out frame 2. You get frame 2 and key. Okay, so all that's good. There's not much to what we're going to be doing right now, but basically the concept is pd.merge, and then you specify what 2 are you merging. We're going to be merging our frame 1 and frame 2. And then you can also specify on what you are on what you're merging and how you're merging. Okay, so we're merging on the value key. So whatever the key values were, we want to merge those. In the sense of, we're going to say key is equal to, or I'm sorry, on is equal to key. Okay, so if you don't put anything after that, if you hit enter, you get 0, 1, 2, CDE, 2, 3, 4, TUV. Okay, the way this looks like right now is you have frame 1, which got the CDE values. You had 2, 3, and 4. These were the overlapping pairs, if you remember, because in range 5 you get 0, 1, 2, 3, 4, and range 2,7 you get 2, 3, 4, 5, 6. Okay, so the 2, 3, 4 were overlapping, and that's exactly what's been picked. So that's what happens when you don't specify how. Now let's go ahead and specify how, and some different results will happen. So how is equal to right. And by doing so, what happens? We get frame 1 is equal to CDE non, key is equal to 2, 3, 4, 5, 6, and frame 2 is equal to TUVWX or VWX, okay? So when we specified how is equal to right, we basically said keep frame 2's values the way they are, don't change them. If frame 1 doesn't have those values, then go ahead and put null. So that's exactly what it's done. It's taken frame 2 to be that superior frame, hasn't changed anything about it, but it has changed frame 1's values. Since frame 1 didn't have a key of 5 and 6, that's why non and non are there. So the exact same way right works, the exact same way left works, okay? So if you try putting left here, now frame 1 is full. So frame 1 has A, B, C, D, E, 0, 1, 2, 3, 4. Key frame 2, however, only has TUV. The upper 2 are empty. So this was right and left. Basically, if you want one graph to be, or one data frame to have priority over the other, you're going to specify that one should have its values intact. Now, the other 2 are outer and inner. Outer basically uses union of keys from both frames, okay? So outer in this sense would be, if you specify outer, let's go ahead and instead of left do outer. What do you get? You get everything. It doesn't matter if it has it or if it doesn't. You're just joining both data frames together. So the full key list comes 0, 1, 2, 3, 4, 5, 6. Frame 1 is complete. Frame 2 is complete. And then at the places where it's not, where the key couldn't find a value, that's where the NaN is coming, the null value. So pd.outer is basically merging both data frames without any that sense that if there's no value, then that's fine. And inner is the default one. So inner is the first value that we got up top, and inner is where if both of them have it. So if frame 1 and frame 2 both have the same key, only then will it be displayed. So since frame 2 and frame 1 had 2, 3, 4 the same keys, that's how it was displayed. Okay. So this was merging. Now there is also a concept called concat. The way that works is pd.concat, and then you do left or frame 1, comma frame 2. And basically what happens in concat is it's repetition. So whatever was in frame 1, so 0, 1, 2, 3, 4, frame 1, frame 2 didn't really have anything of those, and then frame 1 will come none for frame 2's value. So it's a bit confusing, concat. It's not something I'd always recommend using, but it's something you can always do. Now, right now, this is coming one on top of the other. So suppose you wanted to do it side by side, you can also use the axis parameter. So pd.concat frame 1 comma frame 2 comma axis is equal to 1. And by doing that, now instead of coming one on top of the other and getting these nons, it has been concatenated side by side. So now we don't have that error. We have 0, 1, 2, 3, 4, frame A, B, C, D, E, key 0, 1, 2, 3, 4, frame 2 is T, U, W, V, W, X, and key 2, 3, 4, 5, 6. So in this case, there is no union. The concept of union and all that stuff is gone. In this case, it's just based on the index, okay? So if there's 5 values in frame 1, 5 values in frame 2, then it's going to show like this, okay? So in this lecture, we basically learned how to concatenate and how to merge data frames. So we learned the 4 ways how to do it. There's right, left, outer, inner, and then we learned the pandas way of doing it using the concat function. All right, so awesome job, and I'll see you in the next lecture. Alright, so in this lecture, we're going to learn about a function called group by, okay? And our data for this is going to be a little bit different. So what I want you to do is go open up your Chrome, and I want you to search City of Chicago or Chicago salaries, okay? So if you just search for Chicago salaries, it might be the first link or it might be the second link. Let me take a look. Yeah, it's going to be the second link. First or second, doesn't really matter. But once you open it up, you should see something called a menu. And what I want you to do is go ahead, menu, and then download. So over here, let me make this a bit smaller for you guys. And menu, download. So Chicago shares its name, salaries, position titles, etc. To the whole world. So all we're going to be doing is getting a CSV of that, and then we are going to basically, I'm going to be showing you how the group by function works. So you're probably wondering, well, why am I taking a new file for this? And the reason is because of how it's laid out, because of basically the department wise and stuff like that. It's just going to make our lives a bit more easier. Okay. So let me go ahead and minimize this, and let's get started with our basic pandas. And what I want you to do is, let's go ahead and create a headers, or let's wait. Headers is equal to, we have name, we have title, we have department, and we have salary. Okay, so those are our 4 headings. And now let's go ahead and create a Chicago data frame. That is equal to pd.readCSV, and in brackets we're gonna say city, or what did it save as? Let me take a look. So Finder, it's saved as this. That's a bit big, so I'm just gonna call this as Chicago data. Okay, so it's now Chicago data, and let me move this to my documents because that's where it actually everything is saved. So pd.readCSV Chicago data.csv. Okay, and then let's go ahead and say header equal to false. So that basically moves that top row down. And then names is equal to headers. Okay, so hit enter, and now if you say chicago.head, we get our name, title, department, and salary. So today, again, we're going to be talking about the group by function, and we're not going to be doing too much with it, but I want you to understand how it works. So the pandas group by returns a data frame group by object, which has a variety of methods. Okay, so what I want you to do is, let's go ahead and let's call this DEPT, department is equal to Chicago dot group by department. So if you're not sure what the group by function does, it's basically groups it by the department, okay? So this department variable is our data frame, except it's now grouped by department. So department is that key index over here. So there's two functions here that we're going to talk about right now. One is the count function and second is the size function. So if you say department.count and then you specify just the head part for now, we don't want the whole thing, it returns us the total number of not null values within each column, okay? That's what the count function does. So for admin hearing, there are 39 not null values for name, 39 not null values for title, and so on. The other function here is the size function. So department.size.head basically returns us the number of times or the total number of records. Okay, so every time admin hearing is seen, +1 is added. So there are 39 instances of admin hearing, 67 of animal control, 1344 of aviation, 111 of board election, and so on. So again, this is pretty useful data if you want to find out, hey, how many people are in aviation, stuff like that. Now there is also, you can do summations. You can find the sum of stuff, you can find the mean, you can find the median. The way that works is, again, you need integer values. Right now the values are in $signs, so we won't be able to do them, but going back to maybe a more simpler CSV file, the way it works is you can do stuff like data frame. This is not a real variable, but you'd say data frame.sum, or you could do data frame.mean, and you can do data frame.median. Okay, so all those good stuff, you can do that with the group by object. So as you can see right now, there is no integer for which we can do this for, since all the values are strings. However, next time whenever we choose, or when we're talking about the group by function, you can always perform these summation functions with the group by object. Okay, so again, like I was saying, this is a short lecture. I don't want to talk too much about the group by right now, but following this lecture and lectures after that one, basically we're gonna finish up the Pandas module now. So we'll go back to our movies, and we are just going to learn a few more key concepts where we will create some charts from our data using Matplotlib, and we're also going to learn some other pretty neat stuff. Okay, so that's all good, and I'll see you in the next lecture. Alright, so the following few lectures are going to dive deeper into a little bit more complicated Pandas programming, okay? So first thing first, we're going to be going back to our normal movie data, except this time we're going to be using the functions we've learned, like merging, group by, stuff like that. So let's get started. First thing first, I've imported Pandas, and now I want to open up, well, the first document is going to be my .data file. Okay, so going back over here, we have the u.item. That's one we're going to be opening, and the second one is going to be the u.data. Okay, so let's go ahead. I'm going to create call1, make this an array, and the data in this should be user ID, comma, movie ID, comma, rating, and last but not least, we have Unix timestamp. So those are just the columns that we want. And then we're going to say ratings. So this is our first data frame. pd.readcsv. And then we are going to pass in our location. So MLK or ML100K. And then /u.data, comma, again, all these files are separated by the same thing, which is that straight slash, and then names is equal to ucalls, or ratings, or what is it? Call1. Let's go ahead and try out ratings.head. Let's see what we get. Okay, user ID, mover ID, rating, Unix, and timestamp. So taking a look at this, it looks like actually it was separated by /t. Looks like I was wrong, guys. So instead of that straight slash, let's go ahead and put /t, hit enter, and now if we print out ratings.head, we get user ID, movie ID, rating, Unix, timestamp. Okay, So that's exactly what we wanted. Now the second data frame that we're creating is going to be one of the items itself, the movies itself. So let's go ahead and create call2 is equal to, again, it's going to be a list of some good stuff, movie ID, comma, we have title, comma, we have release date, comma, video release date, so video release date, and last but not least, we have IMDb URL. So all that's good stuff, okay? And now let's go ahead and create our second data frame, which is going to be movies. So movies is equal to pd.readcsv, and then we are going to pass in ml100k / u.item, okay, comma, sep is equal to, this time I'm pretty sure it's a straight slash. I did take a look at the document and it was. And we're saying names is equal to call2. And over here is something neat actually that we have talked about. And we only want to use the columns from range 5. Okay, so we're saying use calls equal to range 5. And you're probably wondering why only the first 5 columns? Well, take a look for yourself. So let me bring this file over here. Yeah. So this is the file we're parsing. We got Toy Story. That's going to be the first thing to parse. Then the date, then the URL, and then you have a bunch of random stuff. So rather than parsing that data as well, it's better to just not even talk about it. And that's why we're only keeping the first 5. Okay. So all that's good stuff. Taking a look at this, yes, that's good. So hit enter. It gives us an error saying UDF8 codec cannot decode byte 0xe9 in position 3, invalid continuation byte. So I'm pretty sure all of you got this error, and this is just a simple encoding issue. So the error you're running into is that the file is not encoded properly, or there's some encoding problem. Anyways, the fix for this is going back up top and bringing this down. You can pass in a parameter called encoding, and then what you want to do is set the encoding equal to ISO-8859-1. Okay, so that's going to solve the problem. Hit enter. See, we don't get the error anymore. If you do movies.head, we get Toy Story, Jan 1st, 1995, GoldenEye, 4 Rooms, Get Shorty, Copycat. All of them are 1995 1st Jan. That looks, yeah, oh wow. That's interesting. I didn't know all 5 of these movies were released on the same day. Cool. So we have our values now, and now let's go ahead and manipulate these values, okay? So let's do a quick simple thing right now before I end this lecture. And that is to, first of all, merge our 2 data frames. So go ahead and say movie ratings is equal to pd.merge, and then you're gonna say movies, comma, ratings. Okay, those were our two data frames. So if you now print out movie ratings dot head, what do we get? We get movie ID, title release, video release date, IMDb URL, user ID, rating, and Unix timestamp. So a lot of good data. And excuse me, the last thing we want to do is we want to get our users. Okay, so we want to create one data frame of all our data. Okay, so go ahead, and if you remember back long time ago when we were talking about those users, I still have my code with me. So let me just paste this. Go ahead and get those user ID, age, instead of sex, let's go ahead and change that to gender. That's just better for us. And then occupation and zip code, okay? So that's good stuff. And then let's go ahead and create our users data frame. So users is equal to pd.readcsv mlk or ml100k / u.user, and comma sep is equal to that straight slash, this one I know for sure, and then names is equal to ucalls, okay? So hit enter, and if you now print out users.head, I always like to make sure we got the correct data. Yep, that looks fantastic. So let's go ahead and merge our users with our movie ratings. So let's go ahead and just create lens. Lens is the movie lens website. Lens is equal to pd.merge movie ratings, comma, users. Alright, so now we finally have our data accumulated in one place. So this lecture was just getting our data into one single data frame. As you can see, it now has everything from movie ID, title release, video release, date, IMDb, user ID, rating, to our age, gender, occupation, zip code, and so on. Okay? So now that we've gotten all our data in one place, in the next lecture, let's go ahead and start analyzing and modifying it. Alright, so now that we've gotten our data, the next step is to actually analyze and do stuff with it, okay? So let's go ahead and get started with that. The first thing I want is to know, let's see which movies were the most rated, okay? And the most rated, I mean which movies received more ratings. So let's go ahead and start off with maybe the first 20, the most rated 20 movies, okay? So to do that, taking a look at our data, we can definitely start with title, okay? So what we want to do is we want to find out which movies are repeating more and more often, okay? So most rated is equal to lens, that's our new data frame, group by, so we're using that group by function, and then we're going to specify title, okay? And then once we specify title, remember the size function. That size function tells us where is it being repeated, all of the total places in which that specific name is being said. And now what we can also do is something called an order. Okay, what the order function is basically you can say, how do you want to ascend? Do you want it to make it ascending, descending? How should it work? So what we're going to do is we're going to say dot order ascending equal to false. Okay, and now to get the first 20 values, what we have to do is say at the end :20. So that's our most rated. And now if we say most rated, we get Star Wars 1997 or 1977 583, Contact 1997 509, Fargo 1996 508, and so on. Awesome job. So taking a look back at our code, we grouped it by title, okay? So wherever Star Wars got a review, that's where it got grouped, okay? And every single time Star Wars got a review or Star Wars was mentioned, that's where the size function came in. So every time Star Wars was mentioned or got a review, +1 was added, okay? And then we said order ascending equal to false, and by doing that, the biggest came instead of the smallest. And then :20 basically gave us the first 20 values. So it's a very simple code. I mean, hopefully you're understanding what's happening here, but there is a simpler way. This time I did it using the group by function because I wanted to show you how we can use it. But an easier way is to say lens.title.valueCounts. Okay? The value counts function basically returns you, hey, where are these values being repeated? And then just to 20, so that returns us the exact same thing. Star Wars 583, Contact 509, Fargo 508, and so on. So this is Pandas' function, the value counts, and it's quite nifty as you can see. So it's much more simple, but my goal above here was just to show you how you can use the group by function. Okay? So lens.title.valueCounts returned us those titles which are being repeated the most. Okay? So that's good stuff. Now let's go ahead and finish up this lecture by, I guess, maybe sorting it out. So what we can do is, let's sort these movies out by which movies have the highest average score. Okay? So that's our goal right now, which movies have the highest average scores. To do that, what we need to do is, first of all, create a data frame having both the title, the rating, and as well as the size and the mean. So let's go ahead and do that. The way we're going to do this is movie stats is equal to lens.groupBy title. So we're grouping it by the title again, except this time we're going to use the .agg function. It's called the aggregate function. And over here you're going to say rating so rating is our header or our heading, and then you're going to pass in two values here, the np.size, comma np.mean. Okay, So basically what this does is it's returning, so it's going to create us a data frame in which it has a title as one column, and then our second and third column will be under the class of rating, where one column will be the np.size, so it's going to return us the size of the title, again what the function up above here was returning, and then the np.mean, so it's going to return us the mean of the ratings per se. So hit enter and it gives me an error saying NP is not defined. The reason for that is because I have not imported numpy. So go ahead and import numpy, and then let's go ahead and call this function, and printing out movie stats dot head, we get till there was you 1997, size is 9, mean is 2.333. 1-900, size is 5, mean is 2.6. So right now, let me quickly explain what's happening here. Till there was you was rated 9 times, and the average of those 9 ratings was 2.33. 101 Dalmatians was rated 109 times, and its mean rating was 3 stars. 12 Angry Men was rated 125 times, and its mean rating was 4.34. Okay, so that's what our function is doing right now, and it's working. However, there's one more thing we still have to do, and that is to ascend these movies to find out which has the highest rating. Okay, so right now it's giving us these random ratings. Our goal was to find out which movies have the highest average score, the highest rating. Okay, so doing that, what we're gonna say is movie stats dot sort. Okay. And in the sort function, you're going to say, basically, what are we sorting? We're sorting the rating, and we're sorting the mean, where, oops, forgot that extra quotation mark there. So rating comma mean, where we are saying ascending is equal to false. So again, we want the highest to come first, and then we want the head of this, okay? So hopefully this makes sense too. We're basically sorting it based on the rating, and part of the rating function is the mean. So rating was the entire thing. Rating was that entire column that we created over here, and then we're sorting the mean part of it. Hit enter, and we get they made me a criminal. Its size is 1, so it was only rated once, and obviously someone gave it a 5-star. That's why it's coming first. Star Kid actually looks pretty good. You got 3 people rated it, and they all gave 5 stars. So that's pretty neat. Anyways, awesome job. In this lecture, we covered quite a lot. We learned how to use the group by function up here, using the size and then ordering to say which ones we want to get first. And we learned how to use the value counts function. The value counts, again, returns those that are, whichever is coming the most, the value counts. And then we learned about the .hg function, which is the aggregate, where we're creating a column called rating using the NP, NP functions, the np.size and the np.mean. And we were able to get our data frame. And then what we did is we sorted the data frame based on the mean. Okay, so whichever had the highest mean, we said ascending equal to false, and we got the head of it. Awesome job, guys. Hopefully you're understanding what's going on. Again, this may seem a bit confusing to you, and I'm doing my best to explain here. I myself was severely confused as I was learning about this, as I was taking tutorials on this. So trust me, if you're confused, it's not something to be worried about. It is quite a confusing module. If you do have questions so far on, hey, what is this rating comma mean? What does this mean? Or what is this group by? What is this AGG? Stuff like that. Please don't hesitate to ask, and I will reply and get an answer for your questions. Okay, so that's it from my side. I'll see you in the next lecture. Alright, so hopefully by now you're understanding how the pandas modules work, how we can format our data, how to sort it, stuff like that. And I'm starting to finish off this section now. So before I completely end our whole pandas tutorial, let's go ahead and understand how can I upload my data to graphs, okay? So the first thing that's with graphs is we need to get our data, and let's go ahead and start off with age. So what I'm going to be doing is I'm going to create a histogram based on the user's age. So back, we had created a user's data frame. So we're just going to be using that. Let's go ahead and import matplotlib.pyplot as plt. And the next lines are actually going to be quite simple. So what I want you to do is say users.age.hist bins equals 30. So we're basically creating 30 or so of those square boxes of a histogram. And what we're trying to do over here is we're creating a histogram of all the users' ages. So if you don't know what a histogram is basically a bar graph, except all the bars are joined together. So there's no gap between the bars in a bar graph. And histograms are functionality a bit different, but you'll understand as we go along. So as soon as I create this, or as soon as I hit enter, I get users.age. Or at least my Python launcher opens up. So let's go ahead and see what the Python launcher looks like. Let's give it a few moments. So it seems to be bouncing around right now. Let me try doing this plt.show. Does that show us the... Yes. So calling plt.show does give us the entire histogram, so take a look. We haven't added the X label, the Y label, or the title, but this is a very simple way we can upload our data into a chart in Matplotlib. So taking a look at the ages, as you can see from the data we had gathered some time ago, 34, 32, 33, those are the common ages. So the middle-aged man is probably the most common reviewer here. As you get younger, it slowly goes down, but this 20 to 30 group is definitely much higher. As you slowly grow older, it starts to decrease. So let me go ahead and add some X, Y labels and titles so that it'll just make our lives a bit more easy. So plt.title is going to be distribution of users age. plt.xlabel is going to be age, and then we want the Y label to be count of users. So plt.ylabel, you want this to be count of users. So I think you saw how easy it was to get our data into a chart. Okay, so it's quite simple. It doesn't take up too much time, and I think now you're realizing that how useful Pandas is in data analysis, in all this good stuff. So now taking a look at this, we have age, we have count of users, and we have distribution of age. So that's great. Again, this is how we upload data into a Matplotlib chart. So there are many different ways you can do this. You can create scatter plots, you can create bar graphs, stuff like that. Let's go ahead and do one or two more lectures of this where I'll show you how we can create a bar graph as well, and then I'll finish off this Pandas section. Okay, so that sounds good, and I'll see you in the next lecture. Alright, so our next item or task at hand is to create a bar graph, and the way this bar graph is going to work, we're going to create a bar graph which will basically show male versus female average ratings. Okay, so we'll use some high-tech code here, and at the end of the day, the way this is going to look like is if the bar is ahead of 0, that means that men favor it, and if the bar is less than 0, that means that women favor it. So we're going to be using the top 50 most popular movies. So first thing first is we want to get those values, the top 50 movies. The way we can do this is by saying, let me quickly exit out of my chart. Okay. The way we can do this is by saying most 50, so the most popular 50 movies, is equal to lens.groupby, and you can group by anything you want here actually, but I'm going to just do movie.id. Okay, and then I want the size of this, so what the size is .order, and you should probably know this by now. We're just going to set ascending equal to false. So again, we want the top values first, and how many do we want? We want 50 of them. So printing out most 50, we should get the first 50 movies, right? It's grouped by movie ID, and we have ordered them as that. Let me print out lens and make sure everything is okay. Okay, so lens looks good, movie 50, most 50 looks good. So the next thing is we want to separate out those male and female ratings. Okay, right now what's happening is gender is a separate column, and we have our ratings as a separate column. So the way this is going to work is we're going to put male and female as the columns, and then rating will then become a row. So the concept might be a little bit confusing to you, but the way I want you to think about this is, so currently right now we have like one row right now will have something like, taking a look at this. No, don't take a look at this. But we have our gender, so we have all these as males, and we have our rating, okay? So the way I want to do this is our gender, M and F, will then become a column. So instead of seeing gender over here, you're going to see M and then F, and then based on whatever the gender was, we're going to put that rating. So the way it's going to be is M over here, F over here, and then whatever ratings there were for that specific thing, then it's going to be there. So M, then 4, M, then 5, M4, M5, and we'll have the female values over here. And by doing so, then we'll easily get the difference. Okay, so right now the way this is working is we'll subtract the female rating from the male rating, and if it's positive, that means that males liked it better. And if it's, or I'm sorry, if you're going to subtract the male values from the female values, if it's positive, that means that the males like the movie better, and if it's negative, that means the females like the movie better. Okay, so let's go ahead and reset the index in case we have changed the index anywhere. So I'll go ahead and say lens.reset index. We're going to set it back to movie ID, and we're going to say in place. So remembering back to our indexing lecture, we are now making sure that it's been indexed by movie ID, and we're going to talk about a concept called pivot table. So the way pivot tables works is you can now change up this. Okay, wait. I'll explain it via the code. I'm not too good at explaining how this is going to work. Just follow me here. Pivoted is equal to lens.pivottable. Okay, and you're going to specify some parameters. First parameter is the rows. So what do you want in your rows? We want the movie ID, and we want the title. Okay, so that's basic. And in our columns, we now want the gender. So the reason why, we want gender over here, and the reason why we're doing gender is because we want the male female to appear up top now. So columns equals gender. I'm pretty sure it's gender. Let's take a look at the data. Yes, it's gender. And now what we're going to be doing is what's the values that are going to come in this new column. So we want the ratings to come. So comma values is equal to rating. Okay. And go ahead and just specify fill value to be equal to 0. So hit enter. It gives me an error saying unexpected keyword argument rows. So the reason. Alright, so I did have to change up this code a little bit. I'll just quickly show you what I did. Instead of doing our normal rows, I had to change the index. So that was an issue I was running into, and calls is no longer the valid variable name. It's now columns. So index is equal to movie underscore ID comma title. Columns is equal to gender. Values is equal to rating. Fill value is equal to 0. And when I printed out pivoted, I now got movie ID title, the F values, and then movie ID title, the M values. So again, this data is probably looking a bit confusing to you as to what's happening. So I do have an example over here that I want to show you guys how the pivot table works. I did follow this for part of the course where I fixed the pivot issue. So right now, just look at the data here. Right now, what was happening is they had date, they had the variable names, AAA, BBB, CCC, DDD, and then they had the values for each variable, okay? Now this data, it works, but wouldn't it be better if you had the column name A, B, C, D, and then underneath each of those columns, you have the 3 values. So 0 point whatever, minus 0 point whatever, minus 1 point whatever. So using the pivot table, okay, they use df.pivot, the index is equal to date, comma, columns is equal to variable. So they specified that whatever the variable was, that's the columns. and then the values is equal to value, okay? So taking a look at what happened, the outcome was they got A, B, C, and D as the columns, and then the values then came underneath. So the pivot table is quite useful when you're trying to reshape data. That was the whole goal of basically showing you this example. And taking a look at this, we now got our female, and then we have our male. So let's go ahead and try printing out pivoted.head. And we get movie ID title, female, male. So we basically achieved what we wanted to, okay? So the gender section had the female and the male, and we brought these up top. The movie ID title remained the same, and we now have female values and we have male values, okay? So the next thing that we want to do now is what? Well, we want to get the subtraction, the difference, okay? So the way this is going to work is you want to add a new column called diff. And the way we can do that is by saying pivoted, and then in square brackets diff is equal to whatever. So pivoted diff is equal to this column, so pivoted.m, minus the f column, so pivoted.f. So the way we can do this now is say pivoted.m minus pivoted.f. It's actually pretty neat. So now what this function is going to do is it's going to create a new column, and each time in each object it's going to say, hey, what's the m value, what's the f value, let me subtract, and I'll put in that difference. So now if we print out pivoted.head, we get f, m, and difference, where difference is, again, the difference between m and f. And now you can see that Toy Story is a better rated movie for male, Golden Eye is for women, Four Rooms is for male, Get Shorty is for male, and Copycat is for women. So what we've done now is we've created a sort of comparison base to see, hey, do men like these movies better or women? So we're almost done with our creating the bar chart, and we have one or two more things to go. So the first thing is, remember we created our most 50 index up top? Well, we're going to be using that here, okay? So go ahead and create a new variable name. It's going to be called disagreements. And this is equal to pivoted. We're going to get some values now. We're going to say pivoted.movieid, okay, dot is in most 50 index, dot index actually. So you're probably confused at what's happening here, and we're basically saying get those values of pivoted whose pivoted.movieid is in. So again, is in is a pretty straightforward function. We're basically saying if it's in the most 50 dot index, okay? That looks good. Now, one last thing here we have to say is, what do we want of it? We just want the diff, okay? We don't care about our f values anymore. We don't care about our m values anymore. We only care about the diff, okay? So hit enter, and it gives me an error saying data frame object has no attribute movie ID, okay? So I'm not completely sure why we are getting this error. Let's go ahead, and I think the reason is we have to reset our index. So say pivoted.reset index movie ID, so that will make our index back to normal, and then comma in place equals true to make sure that it stays. So now let me just go ahead and try pivoted.movieid. Yes, so now we're getting our correct values. Let me just go back and get this line. So disagreement is equal to pivoted. Which part of pivoted? The pivoted.movie ID, which is in the most 50 dot index. And what do we want of this entire thing? Only the difference part. So hit enter. And now what I want to do is let's go ahead and just print out disagreements.head. So what happens? We get our title and we get the difference. Isn't that neat? So look at what we've done. We've taken a data frame which is, we had tons of values, tons of data. We learned how to, first of all, use a pivot table, get or reshape the data. We learned how to subtract the data. And then we learned using the isIn function how to find out which data is inside of this bigger data frame and only get those, okay? So we're almost done with this lecture, with this whole section. Last but not least, we have to create this bar chart. So I know we've imported matplotlib before, but in case you guys have maybe created a new file, maybe a new shell, maybe you restarted the shell, just go ahead and import matplotlib.pyplot as plt. Okay guys, almost done. Last 4 lines to go. Go ahead and first of all specify the titles and stuff. So the way this is going to be is male versus female, average ratings, and let's go ahead and put a new line and say where difference greater than 0 is equal to favored by men. Okay, that's the title. Let's go ahead and set the X label. Our X label is going to be the average rating difference. Average rating difference. And our plt.y label is equal to title. Okay? Alright guys, last line that we're gonna write for this whole pandas section. Are you ready? I know I am. So go ahead and say disagreements.order.plot. And what I want you to do is go ahead and say kind. Again, this is a horizontal bar chart, so go ahead and say kind is equal to bar h. And you can also specify the figure size. Let's go ahead and leave that for now, and let's take a look at what happens. So I'm going to call on plt.show. Okay, so because we didn't specify our fig size, that's why we're getting this scrunched up data. So let me go ahead and specify my plot size, or my figure size. So close this out. Let me get this back down. And comma, so kind is equal to bar, comma h, and fig size is equal to, let's do 10, comma 15. Okay, hit enter. Plt.show. I'm sorry. Hit enter. Okay. So this looks much better now. You guys probably cannot see what's on my screen. I'm sorry for that, but just take a look at this first data. Or you know what? That's not good on my part. So let me bring this up for you guys. Let me play around with the white space a bit, so you can see this part at least. Let me make the left a bit more so that you can read what's happening. You know how to change the left by now. You know how to change the bottom and the top. So I'm gonna let you guys play around with this. But let me just try to show you the values of what's happening. Okay, that's too much. So just wait, guys. I'm sorry. Minimizing this, yeah, it's bad, okay, but just understand that we have the minus 0.4, minus 0.20, 0.2, 0.4, 0.6. So I'm going to expand this data and I'll just talk. You should have the exact same data in front of you. So it looks like Terminator is the most popular movie for men. At the bottom, Independence Day, wow, is actually the most popular movie for women. So that's pretty interesting. I didn't think that they'd like it. Mission Impossible is actually pretty popular for women as well. I guess that might be because of Tom Cruise. Shawshank Redemption again is also popular with women. Going back up top, Forrest Gump for men, Toy Story for men, Men in Black definitely for men. Star Wars I never was a big fan of, so I'd probably give it a bad rating. But Pulp Fiction I know was a good movie. Terminator 2 again, part of the Terminator series. Obviously it's gonna be good. Anyways, guys, awesome job. Okay. So we have covered basically all the basics there is to data analysis with Python. We started off with the matplotlib series. We learned how to create some fantastic 2D and 3D plots, graphs, and charts. Then we moved on to pandas. So we learned about data analysis, reading in CSV files, writing out CSV files, manipulating the data, getting what we want, when we want, and where we want it. Okay? So I couldn't be prouder as an instructor to see how far you guys have come. Again, great job. So if you've enjoyed my course so far, if you've enjoyed my teaching, you thought that this was a very helpful course, I would really appreciate it if you could leave a review. It helps future students and it helps me. Other than that, if you have any questions whatsoever, if you have any feedback, so far, if you think that maybe you needed to add some more lectures for pandas and some more lectures for matplotlib, please do. Tell me that. So I love constructive feedback in the first place, so if you have any constructive feedback for me, that would be fantastic. Otherwise, that's it for this section. I hope you have understood the basic concept of pandas, how to use it, how to create charts using our data, and so on. And I'll see you in the next section. Thank you guys and have a fantastic day.